this is Mission Control Houston, bringing you live coverage today of the fourth and final planned spacewalk to repair the alpha magnetic spectrometer on the space station's truss segment. The alpha magnetic spectrometer was launched on Space Shuttle Endeavour to the station 8.5 years ago to study dark invisible matter that can't be directly detected. The goal of the alpha magnetic spectrometer has been for scientists to track down sources to help understand dark matter and the origins of the universe. And over the last 8.5 years, the alpha magnetic spectrometer has collected data on over 140 billion cosmic ray events. With many items that are exposed to the harsh environments of space, the alpha magnetic spectrometer needed to be upgraded to continue data collection. You are looking live inside the station's Quest airlock, where two astronauts, NASA flight engineer Drew Morgan on your right and Expedition 61 Commander Luca Parmitano of the European Space Agency on your left, are suited up, ready to begin the fourth and final planned spacewalk to repair the alpha magnetic spectrometer. AMS began showing signs of age in 2014 when one of the cooling pumps stopped working and another one was found to have degraded. In March of 2017, researchers switched to the last fully functional pump to keep the science alive. The AMS team realized they would need to take action to keep the scientific instrument going and enable the AMS to function through the lifetime of the International Space Station, leading to the series of 4 spacewalks. These spacewalks are considered to be the most complex of their kind since the Hubble Space Telescope. The AMS was originally designed for a 3-year mission and, unlike Hubble, was not designed to be serviced once in space. The work to prepare for the spacewalk, which began about 4 years ago, involved making, testing, and launching more than 20 new tools to the space station. Many specialized for specific steps of the spacewalk, such as removing the debris shield, which was done in the first spacewalk, and tools to splice cooling lines, which was performed in the second spacewalk. These tools have gone through years of iterations and tests here on Earth by scientists, engineers, and astronauts. The 2 spacewalkers today, and for the series of these repairs, Drew Morgan and Luca Parmitano, had 7 training sessions in the Neutral Buoyancy Lab to repair magnetic spectrometer spacewalks. For some additional background on the series of spacewalks that have been done to repair the alpha magnetic spectrometer, the first AMS spacewalk set the stage with preparation work on November 15th. During the 6.5-hour spacewalk, Drew Morgan and Luca Parmitano successfully positioned materials, removed a debris cover on the AMS, and installed handrails in preparation for the spacewalks to follow. Parmitano and Morgan have completed several get-ahead tasks originally planned for the second spacewalk, including the removal of the vertical support beam cover for the area that houses the 8 stainless steel tubes. Then the second spacewalk came just 1 week later on November 22nd. Parmitano and Morgan successfully cut those 8 stainless steel tubes, including one that vented the remaining carbon dioxide from the old cooling pump. The crew members also prepared a power cable and installed a mechanical attachment device in advance of installing the new cooling system. And the third spacewalk on December 2nd, the crew successfully installed a new cooling system for the alpha magnetic spectrometer. The crew completed the primary task to install the upgraded cooling system called the Upgraded Tracker Thermal Pump System, or UTTPS, completed the power and data cable connection for the system, and connected all 8 cooling lines from the AMS to the new system. The intricate connection work required making a clean cut for each of the existing stainless steel tubes connected to the AMS, then connecting it to the new system through a process of metalworking known as swaging. The astronauts also completed an additional task to install an insulating blanket, which will be removed on the spacewalk today.
We're ready to copy.
During that third spacewalk, the flight control team on Earth initiated power-up of the system and confirmed it was receiving power and data.
Copy. Good numbers.
Copy.
The spacewalk today marks the 227th spacewalk in support of International Space Station assembly, maintenance, and upgrades, and the third spacewalk of 2020. This will be the 7th spacewalk for NASA astronaut Drew Morgan, bringing his total spacewalk time to 39 hours and 32 minutes. Morgan's 7th spacewalk in a 6-month time span is a record for frequency by a U.S. astronaut, and the spacewalk today is the 9th spacewalk for the Expedition 61 crew, which is more than any other increment in the history of the station. The spacewalk today will also be the 6th for Station Commander Luca Parmitano of the European Space Agency. His previous 5 spacewalks bring his career total time to 26 hours and 53 minutes. Back in the airlock, you've been looking live into the equipment lock section of the Quest airlock, where the crew is suited up and running through some final procedures before venturing out into the vacuum of space this morning. NASA astronaut Jessica Meir is the crew's suit-up lead today, backed up by Christina Cook of NASA, who will serve as the robotics lead today, controlling the robotic arm to maneuver Drew Morgan around during today's spacewalk to various tight spaces and the Worksite on the starboard 3 truss on the International Space Station. Christina Cook there in your near field of view. Today is her 316th day in space. Again, Cook is serving as the robotics lead for today's spacewalk. She's in the final stretch of her long-duration mission and currently sits in 8th place on the U.S. astronaut all-time endurance list. Cook returns to Earth on February 6th and will land in 7th place on the U.S. astronaut all-time endurance list, with the record for the longest single spaceflight by a woman. You can see Drew Morgan on the right of your screen. He is designated as EV1 today, or Extravehicular Crew Member Number 1, wearing the suit bearing the red stripes, which you can see there on the bottom of your screen on his legs. And on your left, Luca Parmitano, who's designated as EV2, will be wearing the suit with no stripes. During the spacewalk today, Morgan and Parmitano will be running through a series of procedures, including critical leak checks on the newly installed systems and the installation of thermal insulation on the upgraded alpha magnetic spectrometer. John Malarski has been the lead spacewalk officer for all of these AMS repair spacewalks. We have a narrated overview of what you'll see throughout the spacewalk today when Morgan and Parmitano venture out into the vacuum of space. Let's take a look.
Luca Parmitano and Drew Morgan will be conducting AMS EVA number 4, the final EVA in the repair series. Drew Morgan will be the EV1 spacewalker and riding the SSRMS, the Canadarm2. Here you see him translating up the Zeta spur to prepare the Canadarm2 for the EVA, followed by Luca. The arm will be waiting for them on the front of the truss, and they will set up a Whiff extender to extend the reach of the arm, as well as an articulating portable foot restraint that will carry Drew to the AMS worksite. While Drew is ingressing the arm, Luca will collect a bag full of MLI, and he will translate out to ELC2 and prepare the worksite and bags and tools for Drew's arrival at AMS. Drew will then fly up over top of the ISS and past AMS to wrap the arm around behind and underneath of AMS to start the leak checks at the Nader worksite, where 2 fittings will have leak checks conducted. Once Drew is at that worksite, he'll peel back the MLI, exposing 2 fittings, and use the visual leak indicators to verify that they are leak tight. Luca will meanwhile check 6 fittings at the VSB worksite, while Drew flies up to the zenith side of AMS to remove the mud flap and the shower cap to expose the AMS new radiator system. Luca and Drew will also work together to install an MLI tent underneath of the AMS pump system to close out the former debris shield worksite. With the 8 leak checks and the MLI installed and those are complete, the crew will clean up ELC2, and Drew will start flying back to the airlock while Luca removes the foot restraint from ELC2 and translates it back to the front of station for future EVAs. Drew will fly from the zenith side of AMS, back over top of the truss, back to face 1 to deconfigure the arm. Once the SSRMS is deconfigured and all the bags have been stowed, if the crew has any remaining time, they will perform some get-aheads, including some lens filter removals and battery get-aheads to prepare for future EVAs.
Assuming a successful spacewalk today, if all goes as planned, the AMS Project Office has forecasted a preliminary date for the reactivation of the instrument and the resumption of science by Wednesday, January 29th. Again, that date is preliminary and subject to change. Back in the International Space Station Flight Control Room, the Orbit 2 team is on console, ready to execute the spacewalk under the direction of Flight Director Emily Nelson, closest to your screen here. To her right, at the Capcom console, is Capcom or Capsule Communicator Ricky Arnold. You'll hear him communicating with the crew all the way through depressurization this morning. In the ground IV for today's spacewalk, to his right is Jeremy Hansen, who will essentially serve as the spacewalk communicator, talking directly to the 2 spacewalkers from start to finish of the spacewalk today. He'll be helping them choreograph the tasks and procedures. Hansen trained extensively on all of the work associated with the AMS repairs. And John Malarski on the EVA or extravehicular activity console today. Again, he served as the lead spacewalk officer for all 4 of these alpha magnetic spectrometer spacewalks. Back in the Quest airlock, you can see the crew is starting to wrap up its spacewalk preparations, having completed a round of light exercise to purge nitrogen out of their bloodstreams, preventing decompression sickness from occurring once they step outside the airlock a short time from now. Again, Drew Morgan on the right of your screen is designated as EV1 today. He'll be wearing the suit bearing the red stripes, and on your left, Luca Parmitano is designated today as EV2, wearing the suit with no stripes. That'll be an easy way to identify the crew members throughout the spacewalk today. The crew members will also both be wearing helmet cameras for the spacewalk, which will give us the same views that the 2 spacewalkers will have as they conduct their tasks outside the space station. Morgan will have helmet camera number 20, and Parmitano will have helmet camera number 18. Those numbers will appear at the bottom of your screen when we begin receiving those views from their helmet cameras, so that'll be another way to identify the spacewalkers throughout the day.
Good numbers. Thanks very much.
Houston airlock on 1. Time for the resuming EMU pre-breathe, 10:46.
Copy, thank you.
Again, the spacewalk today marks the 227th spacewalk in support of International Space Station assembly, maintenance, and upgrades, and the third spacewalk of 2020. This will be the 7th spacewalk for NASA astronaut Drew Morgan, bringing his total spacewalk time to 39 hours and 32 minutes. Morgan's 7th spacewalk in a 6-month time span is a record for frequency by a U.S. astronaut, and the spacewalk today is the 9th spacewalk for the Expedition 61 crew, which is more than any other increment in the history of the station. The spacewalk today will be the 6th for Station Commander Luca Parmitano of the European Space Agency. His previous 5 spacewalks bring his career total time to 26 hours and 53 minutes. These jet backpacks you see on the screen now are something that all spacewalkers wear, carrying the acronym SAFER for Simplified Aid for EVA Rescue. Spacewalkers wear these backpacks when they venture out as a precaution in the unlikely event that they would become untethered. They could propel themselves back to the safety of the International Space Station. Once those jetpacks are fixed to their spacesuits, Morgan and Parmitano will be moved through the hatchway you see at the top of your screen into the crew lock section. The hatch will then be closed behind them, and the final preparations for depressurization of the crew lock will begin, from 14.7 pounds per square inch down to vacuum, which will be the final step before the crew conducts final communications and suit checks with the flight control team here in Houston. Jessica Meir and Christina Cook are now going to put the simplified aid for EVA rescue or SAFER pack onto the back of Drew Morgan's spacesuit. The extravehicular mobility units, or EMUs, are the suits that you see Morgan and Parmitano in now, and these suits essentially serve as an independent life support system, providing environmental protection, mobility, and communications for the crew members during their spacewalk. Drew Morgan's safer backpack has been installed, and he has been moved through the hatchway into the crew lock section of the Quest airlock. Next, they will install Luca Parmitano's safer backpack. Again, these safer jetpacks would be used in the highly unlikely event that spacewalkers would become untethered during the spacewalk, and those jetpacks would give the crew the ability to then propel themselves back to the International Space Station. Everything is still proceeding along the timeline for the start of today's spacewalk. Once Parmitano moves through that hatchway, now that Morgan is already in and it's closed, depressurization of the crew lock section of Quest will be done in a two-stage fashion. First, they'll take the crew lock down to 5 pounds per square inch of pressure. They'll pause to do a systems check, and then they'll resume the depressurization all the way down to vacuum. Once it reaches vacuum, the two spacewalkers, Drew Morgan and Luca Parmitano, will conduct suit checks and communication checks with Mission Control here in Houston before they place their suits on internal battery power to mark the official start of today's spacewalk. Jessica Meir and Christina Cook will now begin the work to fix the safer on the back of Luca Parmitano's suit now. Jessica Meir on your right is the crew's suit-up lead today, backed up by Christina Cook of NASA on the left, who will serve as the robotics lead today, controlling the robotic arm to maneuver Drew Morgan around during today's spacewalk to various tight spaces on the Worksite, on the starboard 3 truss on the International Space Station. We're in a short handover between satellites called the Tracking Data and Relay Satellite System, and we should be reacquiring video from the station momentarily. Flight Director Emily Nelson is currently taking a poll from flight controllers around the room here in Mission Control Houston for pressurization of the crew lock once that hatch is closed. And you can see Christina Cook and Jessica Meir now helping Luca Parmitano move through the hatchway of the Quest airlock. Again, once Parmitano moves through the hatchway entirely, the hatch will be closed, and they'll wait for a go from the flight control teams here in Houston to begin depressurization of the crew lock section. Again, that call will come after the hatch has been closed.
Airlock on 1. We have completed step 62, and we plan to defer step 63 until after depress, if you concur.
That sounds like a great plan for us.
Copy.
The sequence of events now calls for the hatch to be closed, which will isolate Morgan and Parmitano in the crew lock section. Once the crew gets the go from teams here in Mission Control Houston, there will be a period of depressurization of the crew lock from its current 14.7 pounds per square inch down to vacuum. Final communications between Mission Control and final checks of the spacewalkers' suits will be conducted, and the crew will be given the go to place their suits on internal battery power, which will mark the official start of today's spacewalk.
All right, guys, we are about to close the hatch. Anything you can think of that you need? Staff? You guys rock. You're going to have an amazing time out there.
As you can see now, Jessica Meir is in the process of closing the hatch between the equipment lock and the crew lock. Morgan and Parmitano now isolated before their final minutes of preparations before they begin the 227th spacewalk in support of International Space Station assembly and maintenance, and the third spacewalk from the station this year.
Houston Airlock on 1. We've completed step 70 and 71 of 1.225.
Copy that. We'll put step 72 in work. And just for your information, the power up of the robotic workstation is complete and the monitors are configured.
Okay, we copy all. Thanks, Ricky.
Copy. Copy.
And Airlock Houston on 1. Crew is hot mic on space to ground 1.
that, Ricky. Good morning.
Good morning, everyone.
We copy all, Ricky, thanks.
And good morning, Ricky. Great to talk to you.
Okay, Luca, on the UIA, you can check that the depress pump power switch is off OSS.
It's off OSS, LED enable green.
Copy, and check the depress pump enable, okay, copy the green.
Say that again.
Drew and Luca, we're going to move over to the crew lock depress Q card.
Copy.
And Houston, do you concur that we are ready to pick up on the depress Q card?
We'll see you on the Q card.
Copy, thanks, Ricky. Okay, Luca, switch on the UIA, switch the depress pump power to on, and wait 10 seconds.
Depress pump power to on.
After your 10 seconds, you can bring the manual isolation valve to open and expect alert tone.
Press pump coming to open. Press pump is open.
Copy open. Both of you, please monitor your suit pressure gauge remains less than 5.5.
Everyone copy. CV2, copy.
And flight controllers here in Mission Control reporting that depressurization of the crew lock section of Quest is underway at 5:21 a.m. Central Time. Again, the depressurization of the crew lock section of Quest will be done in a two-stage fashion. First, they'll take the crew lock down to 5 pounds per square inch of pressure. They'll do a pause to do a systems check, and then they'll resume the depressurization down to vacuum. Once it reaches vacuum, the two spacewalkers, Drew Morgan and Luca Parmitano, will conduct suit checks, communications checks with Mission Control here in Houston before they place their suits on internal battery power to mark the official start of today's spacewalk. A U.S. spacewalk start and end time is measured from the time the crew places their suits on internal battery power until the time of repressurization when they're back inside the crew lock once they've completed their spacewalk tasks for the day. The spacewalk today is the fourth and final planned spacewalk in a series to repair the alpha magnetic spectrometer. Morgan and Parmitano will finish installing the new cooling apparatus and lines and verify they are ready for use. Assuming a successful spacewalk today, the AMS Project Office has forecasted a preliminary timeline for the reactivation of the instrument and the resumption of science. If everything goes as planned, Sunday, tomorrow, will complete the filling of the thermal control loop with CO2, then allow the system to stabilize. Monday, January 27th, the first pump will be powered on, which will allow it to filter out any debris in the system. The tracker will also be turned on. Then on Tuesday, January 28th, verification of the other 3 pumps to verify proper operation will begin. And finally, on Wednesday, January 29th, is when the teams expect to be receiving good scientific data again.
Yeah, copy that. We are seeing the depress as well. It's just a little slower than we expected.
I agree. My pressure is stable at 13.6 and has been like that for a while now.
We're seeing the same thing as well and thinking about options.
And Ricky, Christina and I are looking at the hatch right now. It says we are in fully latched position, but it does seem like we might have a leak or out of the upper right corner. We can hear an audible airflow.
Copy that. We're hearing it in the background.
And Ricky, should we stop the depress at this time?
Yeah, we're talking about it. Stand by.
I'm looking.
Pete, Ricky?
I do see I know what it is. It's one of the straps is in the airlock, in the hatch.
Okay, Airlock, Houston, we copy all. Hey, we're going to actually have you repress, open the hatch, reclose. We're just putting together steps for you right now.
Okay, we copy, Ricky.
Airlock, Houston on 1 with steps.
Go ahead, Ricky.
Yeah, for right now, we'd like you to go ahead and just close the manual ISO valve, and then we'll repress using the equalization valve as we usually do.
Okay, we copy. Luca reports the manual isolation valve is closed.
Copy that. Your go to repress.
Okay, and the depress.
This is Mission Control Houston. Just moments ago, Luca Parmitano reported there was a strap from a bag caught in between the equipment lock and crew lock section. The crew is going to repressurize the crew lock now, open the hatch to get the strap out, and go ahead and close it again for depress.
We are not in the repress cue card. We just want you to go ahead and you already have the manual ISO valve closed. Just repress using the equalization valve, and then we'll reset with further steps once you have the hatch equalized.
Copy and work. Okay, guys, repress is in work.
Again, Luca Parmitano reported there was a strap from a bag that was caught between the equipment lock and crew lock section in the hatch. So the crew is going to repressurize the crew lock section now, open the hatch back up to get that strap out, and go ahead and close the hatch again for depressurization.
Okay, Ricky, we see equalization of pressure. Are you ready to open the hatch?
You are go to open the hatch.
Okay, copy.
Jessica Meir now going to open that hatch to get the strap out.
Okay, the tether is clear now.
Okay, Luca, we copy the tether's clear. So if you can somehow keep eyes on it, once we have it down, we can't see that portion.
Yeah, I'm holding it now.
Copy. All right, Richie, Luca is holding the bag, and we have the latch open. We haven't fully, brought it up the reels or anything. Can we just go ahead and close it again as is?
Yeah, Jessica, we want you to go ahead, open the hatch, inspect the seals on the hatch, and then we're going to pick back up in the depress cue card.
Jessica, I can point you to where it was this flap, it was this, and it was right there. There, yeah.
The crew is doing a quick inspection of the hatch seals to make sure everything is good to go.
Have good integrity.
Okay, copy that for the thank you, and thank you, Luca, for the description. What you can do now is we can go ahead, close the hatch, close the equalization valve, and pick up in step 2 in the depress cue card.
Okay, copy. We'll close the hatch and pick up in step 2, and the equalization valve is already closed off.
Jessica Meir now going to close the hatch again.
Okay, Luca and Drew and Houston, the hatch is now closed. We're in step 2 of the depress cue card. So, Luca, you can once again open the manual isolation valve.
It worked, and the manual isolation valve is fully open.
Copy. You can expect an alert tone, and for both of you, monitor your suit pressure gauge remains less than 5.5.
You want copies? You copies.
And depressurization is back underway at 5:32 a.m. Central Time.
Okay, we have past 13. Okay, fine.
Copy. C11.
Jessica Meir in the equipment lock section of Quest, monitoring the depressurization across the hatchway of the crew lock section where Drew Morgan and Luca Parmitano are now. The depressurization continuing down to vacuum.
B9. Drew and Luca at 6, you can expect an alert tone.
Here you go, copy. Stay 2, copy. Eight, yes,
Copy 8. Seven, yes, Copy 7.
CSI.
Copy 6, we show the same. Luca, when you reach a pressure of 5, we'll have you close the manual isolation valve, and I will also call that for you in case your switch is toggling.
You too, copy.
We're in a short handover between satellites called the Tracking Data and Relay Satellite System, and we should be reacquiring video from the station momentarily.
Yes, and follow the instructions.
You want copy? Can work. Copy. Work. Seconds remain for EV1.
Copy.
EV1, check complete. EV2 recheck complete.
Copy EV1 and EV2. Check your oxygen actuators are in EVA.
And work. EV1, EVA.
Copy, both in EVA. Luca, you can open the man isolation valve.
It worked. Yeah, isolation valve is open.
Key open, you can expect an alert tone. I'll be opening the emergency MPEV. Please monitor your suit pressure gauge remains less than 5.5.
One copy. EQ copy. The pressure decreasing 4.5.
Copy, 4.5. Luca, once you get to 2.0, you'll once again be closing the manual isolation valve.
EQ copy.
Still standing by as the depressurization continues in the crew lock section of the Quest airlock. Again, once depressurization is finished, the crew will conduct final suit checks and final communications with ground controllers before they place their suits on internal battery power to mark the official start time for today's spacewalk.
Copy.
Yes, sir.
Copy 3.
13.5.
Copy.
It's got 2.0 on my DCM.
Okay, copy. We are almost seeing that. You can go ahead and close the manual isolation valve.
Copy, work. Keep a stop manual isolation valve is closed.
Copy, closed. On the UAA, you can switch depress pump power to off, OSS.
Depress pump power off, OSS.
Okay, Drew and Luca, at this time you can report your initial tether config.
Okay, copy that. To start with the load path from the airlock D-ring extender, I see the large hook of Luca's weight tether large hook, gate closed slider lock, black on black. His small hook is to his right D-ring extender, closed slider lock, black on black. On his left D-ring extender, have his red hook, gate closed, slider lock, black on black. His red reel, which is unlocked. His large hook, yellow hook, gate closed, slider lock, black on black to his green reel. The green reel is unlocked. Green hook is back to the red reel, and it is in the unlocked position.
Copy all.
And then we've got his large hook, anchor hook, to my right waist tether. Large hooks are both gate closed, slider lock, black on black. Over to my right waist tether. Large hook is gate closed, slider lock, black on black. To the small hook to my right D-ring extender, gate closed, slider lock, black on black. Then on my right D-ring extender, I also have two small hooks. The first one is my green hook, and that goes to my green reel, which is an unlock, and the large hook, which is labeled Airlock, my mini workstation, gate closed, slider is in unlock. Then the final hook on my right D-ring extender is my small hook labeled and it's red. The red reel is an unlock, and the yellow hook labeled arm. Large hook is closed, slider unlocked to my mini workstation.
Copy all. I show that as a good config. Houston, do you concur?
And Drew, can you just check that both your red and green small hooks are locked?
The red and green small hooks to my right D-ring extender are both in the lock position.
Houston's good.
Copy. Thanks, Lead. Drew and Luca, when the crew lock DPDT is about 0, you can expect an alert tone. And for Drew, when the EV hatch delta P is less than 0.5, you will have a go to open the hatch.
Viewing copy.
And you just heard Drew Morgan checking his tethers and the configuration of his suit before receiving a go to open the outer thermal cover of the Quest airlock in preparation for placing their suits on internal battery power to begin the official start of today's spacewalk.
Show the delta on the hatch just a little bit above 1 psi.
Copy.
Could you give us the GMT time?
Sure thing. It's currently 11:55 GMT, so looks like we will egress just about right on time.
Copy that.
Optimus, you will be egressing in daylight, but it will soon after become night.
Copy. .8 psi on the hatch.
Copy, we're showing the same.
Luke, I'll take a little, if you can go, Cliff, a little bit forward, belly toward me. Like that? Yeah, I think that's better. Getting close, or some about point, about 0.7.
Copy and concur.
closeup showing just below 0.6. How does it look on your side?
I'm showing about the same in the airlock, Drew.
Copy. Give it a couple more potatoes.
Concur.
It looks to be about 0.6, so we're in the ballpark.
We are very close. Houston, do you concur?
Checking. Okay. We're going to wait 1 more minute for hatch opening. Waiting 1 more minute, Jessica.
Copy. 1 more minute.
And we copy.
We're in a short handover between satellites right now, but we should be reacquiring video from the equipment lock section in the Quest airlock, where Jessica Meir is standing by as depressurization of the crew lock continues.
I'm showing a minute has passed, Drew.
Okay, copy. And Houston, if you concur, go ahead with putting the hatch.
Houston's go. We're handing over in 20 seconds, so I'll talk to you in about 40.
Copy.
Crews here in Mission Control Houston are reporting they are a go for hatch open. And the thermal cover is open.
Andrew, you should have just the last few minutes open.
Okay, now it's stowed.
All right,
And the thermal
Jessica.
cover opened.
We're back with you.
Okay, copy. Andrew just reported that the hatch is open and stowed. I am closing the emergency MPEV. And with that, Drew and Luca, I'll be handing you over to Weed. Good luck out there. Have a lot of fun. We are very excited for you to be finishing off all of the amazing work that you've already put into this AMS repair. And I think everyone's excited as to the prospects of what AMS has to offer once you guys finish off the work today. We will see you in several hours. And Weed, over to you.
Okay.
That's that, Jessica. You guys are perfect.
Great work, Jessica and Nana. All right, Drew and Luca, let's get after it. You can stagger these switch throws, switch power to BAT on your DCMs for both EV1 and 2.
Copy and work. One, power back.
EQ power back.
Okay, check your display switches are functional.
And EV1 display is functional.
EQ display switch functional.
Luca on the UIA, switch power EV1 and 2 to off, OFF, and check the 4 LEDs are out. They're off.
EV1, power EV1, power EQ off. LED off.
Okay, and you can disconnect your SCUs at this time, install the DCM cover, and stow them in the pouch.
Copy. EQ copy.
EV1 stowed.
EQ stowed.
Drew Morgan and Luca Parmitano have officially placed their suits on internal battery power, marking the official start of today's spacewalk at 6:04 a.m. Central Time.
To max hot.
The final planned spacewalk in a series of 4 to repair the alpha magnetic spectrometer on the space station's truss segment officially underway.
EV1's max hot.
EV2 max hot.
Both of you switch water on.
EV1 water on.
EV2 water on.
Check DCM blank, bite off.
And EV1, DCM blank, bite is off.
EQ, DCM blank, bite off.
Temperature control valves as desired. We'll track your numbers if you don't mind.
Copy.
Next is check your suit P gauge, and we can get the parameters from your suit data.
Okay, copy. My TCV is set at about 3.5, and my P gauge reads 4.3.
I have 4.5 for the TCV. Suit pressure, 4.4.
Okay, those are good numbers. Looks like the sun is on its way down right now. So visors as required, and you're go to egress. Drew, you're leading out, obviously.
Copy that.
And putting down the safety tether, your own safety tether.
Copy. Egress, I know.
Drew Morgan will be the first out of the hatch this morning, followed by Luca Parmitano. Again, Morgan as EV1 in the suit bearing the red stripes, and Parmitano, EV2, in the suit bearing no stripes. Once the crew gets outside and over to their respective work sites, we'll begin getting helmet camera views. Another way to distinguish the spacewalkers will be through those helmet camera numbers. Morgan will have helmet camera number 20, and Parmitano will have helmet camera number 18. Now, just under 5 minutes into today's spacewalk, we're getting our first views of Drew Morgan coming outside the hatch.
We have got my large hook, the one labeled Airlock, closed slider lock, black on the forward green.
Okay.
Tether point, rather.
So that's a good config. You can go ahead and put Luca's safety tether on the aft ring.
Yeah. And I've got B2's large hook to the aft ring, be closed, slider lock black on black.
Okay, that gives Luca a go to release his waist tether. We need the MLI bag. And Drew, are you picking up both the APFR and the Whiff extender, or are you guys splitting those up?
We're splitting them up, and Luca will take the APFR. Hey, Luca, as you make your way out, I'm on the forward side, and getting in position to receive the bag.
Here's the bag. Let me know when you have a red on it.
Copy. I have a red on it.
You have a red, and the large hook is coming out.
Copy.
It's the bag.
Copy.
Let me know when I'm good to come out.
Get the bag out of your way.
Drew Morgan outside the airlock, clearing the way for Luca Parmitano to follow.
Copy, go for egress.
Okay, it's on the airlock, toolbox as we briefed.
Copy.
Okay, looking good, gentlemen. We've got a great view of the airlock. As Luca slides out there, Drew, we can start the buddy checks.
Copy. And Luca, you would take a last look over the interior there and the airlock and see if we're going to be good, if we got to go back in.
Looking at all the different bags that we are leaving, and it looks everything is in order. Coming out.
Roger. See your legs. Head back. Yep. Lean your head back toward the hatch just a bit.
Can you tell what it is that it's impinging? Because
yeah. I think that you just need to get it just a touch more vertical. If you lean your head back towards the hatch just a bit, and now you'll come straight down. There you go.
It's been 6 years since I've done this. Okay.
All right. I'm having a look at you, and I see your WVS light on, and I see both of your handles are down. And if you tap your camera up just so I can have a look at the tabs. Camera up a little bit so I can see your main workstation tabs, yep. And I see tabs up.
Should we get closer? Okay. All right. let me see you. See 2 lights, 1 camera on. 1, 2, 3 tabs are up, and handles on, and 2 handles down.
Okay, copy. Right, my half is dry, and got a long look at my gloves, spaceline gloves.
My hat is also dry, my gloves are in pristine condition, I'm ready to close the thermal cover.
Okay, that sounds good. Drew, I heard tabs. I just didn't hear 3 tabs up on Luca. Confirm you checked all 3?
I did. I'm going to look again just to make sure that we're all on the same page, and I'm looking again, and there's 3 tabs up on Luca.
Okay, you guys are picking up the Whiff extender and the APFR from Whiff 11 on the wagon wheel.
Roger that. And all of our reels are unlocked, and Luca, your Tether's in a good config there.
Okay, good to know. Then I'm ready. Starting with the APFR, I'm going to retrieve it. I have a red on it.
Copy. In the meantime, I'll get onto the Whiff extender.
And I have the APFR, and I have the jaws are closed and locked. Others are out.
And I have a ret to the Whiff extender. Paddles, entry jaws are closed, paddles are out. Whiff extender.
All right, Drew, you're leading out for the arm setup.
Copy. I need to open this up some. Look, I'm going to put this fair lead here on 5.4, so I'm right behind you.
All right. Follow you. Did you do it, Drew? I can take care of that.
Yeah, it's there, I think, now. Good.
Looks good to me.
"15 minutes into the spacewalk today, the final in a series of 4 spacewalks to repair the alpha magnetic spectrometer. First order of business for Drew Morgan this morning will be to make his way over to the Canadarm2 robotic arm, which will be operated by NASA astronaut Christina Cook. Morgan will set up an articulating portable foot restraint, or APFR by its acronym, which you'll hear throughout the day. He'll place his booted feet in that APFR, and he will be maneuvered around the station toward the starboard 3 truss worksite. Meanwhile, Parmitano will head to the worksite to get it ready for Morgan's arrival. Once Morgan arrives to the worksite, he'll peel back the MLI, or multi-layer insulation, exposing the 2 fittings, and use the visual leak indicators to verify that they are leak tight. Parmitano will then check 6 fittings at the VSB worksite, which is the vertical support beam where the cooling lines are housed, while Morgan is maneuvered to the zenith side of the alpha magnetic spectrometer to remove the mud cap and shower cap to expose the new radiator system. Parmitano and Morgan will also work together to install an MLI, multi-layer insulation tent, underneath the AMS pump system to close out the former debris shield worksite. Assuming the 8 leak checks go well and the multi-layer insulation is installed, the crew will begin cleaning up the worksite. Once the Canadarm2 robotic arm is deconfigured and all the tools have been stowed, if the crew has any remaining time, they'll perform some get-ahead tasks, including filter removals and battery get-aheads to prepare for future EVAs.
It's your call whether you want to do the safety tether first or get the Whiff extender and APFR in first.
I think it's going to be a little easier to do the, go ahead and do the Whiff extender.
Works for us. Clocking of 6 when you need it.
Look okay, Luke?
They're reeling out okay behind me?
It looks, everything looks clear and clean. I'm coming out from following you. Just making sure that all our tethers are very deconfigured. Everything looks clean, and so far everything looks completely separated. And I'm right behind you. I'm right at your feet.
Roger.
Coming up.
Andrew, the SSRMS brakes are on. Your go for APFR and Whiff extender setup.
Copy that. In my mind, I was just about to call you. I'm about to install the Whiff extender.
Copy.
And, Jen, if you can read me the settings for the APFR, I can do that for Drew, I think.
Sounds good. You'll be looking for Fox, Fox, Fox 12.
Fox, Fox, Fox 12.
So, Drew, your clocking was 6, and then it's Alpha 7.
Okay, copy. We're in at 6. The good pool twist test is black on black.
Copy.
Okay, and I see the pitch is alpha. Extension of 7, I recall.
Okay, good words. Luca, when you set the pitch, we'll take a pitch knob check that it can be pushed in.
Already done, and it pops out and it can be pushed in.
Okay, Drew, you're going to put the APFR with a clocking of 6.
Okay, copy.
It's still very to me, Drew.
Before I put a red on it, just double check to make sure the reach on my waist tether is okay. Yeah, on my right waist tether.
Your waist tether.
Yeah, my local here.
You'll be okay to install, you mean?
Yeah, I just wanted to see where it was, okay.
Yeah.
Okay, right for the APFR. I have a red to it.
Okay.
And here's your red back.
You can release it.
Okay.
It's already set for you.
Copy, thanks.
Okay, Luca, you can go get the MLI bag.
Copy. All right, Drew. I'll be back in a minute. Copy.
Clocking of 6.
6 as well.
A-firm, 6.
I see it. I see black on black. It is clocking at 12. Black on black. Full twist. Check the lip extender one more time. Black on black.
Now 22 minutes into today's spacewalk, Drew Morgan is doing work to get set up in an articulating portable foot restraint, or APFR by its acronym. He'll place his booted feet in that APFR and he'll be maneuvered around the station toward the starboard 3 truss worksite.
We're facing the Artemis.
Christina Cook at the controls of the robotic arm today that Drew Morgan will get set up in, and she reported just moments ago that the Canadarm2 is ready for Andrew Morgan to get set up.
Let us know if you put it somewhere else.
Copy. Copy.
Hey, Drew, you're clear on down. Your lead. I'm going to reset it.
Which one?
The 500.
Okay.
Just reset it. The motion. Okay, looks good now.
So first step, Drew, is putting your arm tether down on the arm, obviously, and then back to that handrail I was giving you.
Copy. So I have the large hook, one labeled arm, taped yellow, and I'm going to put it on the handrail on SSRMS.
Good words.
Close, slider lock, black on black.
Jeremy, I have a ret. Take a ret on the medium of your bag.
Okay, great. And grab that on your BRT, and then you're heading out to the worksite. Reminder for you, we're going to do a poor man's fair lead at the top of the CETA spur.
Copy. Okay, bottom right out. Jaws are closed.
On your screen now, in your near field of view on the bottom right side of your screen, is Drew Morgan, who is again setting up his APFR, which he'll place his booted feet in, and he'll be maneuvered around the station. Again, Morgan is EV1 today, bearing the suit with the red stripes you can see there on the legs, and Parmitano is EV2 with no stripes.
Okay, Jeremy, so I'm safe to the arm, and I confirmed that with the yellow hook, and now I'm going to remove the green hook, which goes back to the airlock, and I'm going to put it on 3444.
Okay, that sounds like those are good words, Drew.
Okay, It's on 3444.
Copy.
It remains in unlock. The reel remains in unlock.
Okay. Next is getting yourself in the arm.
Okay. Okay. All right. Nana, if you're there.
Drew, I am with you.
Okay. I think we're ready to gauge over to the ingress position, but let's wait 1 second until Luca gets cleared. He's almost there.
Copy.
And I can confirm for you that my reel is in unlock.
Copy, reels in unlock. And another check we'll do before motion would be the ingress aid is in a good position.
Do that.
All right, Luca, before they take the comm, you're doing that fair lead at the top of the CETA spur, and then your green hook goes on 3217 just below the CETA cart, the outboard CETA cart.
Yeah, already. I have a good, I can see my fair lead on top of the spur, and I'm on my way.
Okay. Weeder, you go for us to take the comm.
You got it.
Okay, Nana, over to you, and Lucas, clear the arm, and I have eyes on the ingress aid. It is cleared.
Copy that. Stand by while we set up.
Copy.
Andrew, this motion
Getting our first helmet cam view now, helmet cam number 18, and that is from Luca Parmitano.
You've already checked your ingress aid is in a good config and your reel is unlocked.
Sure, reel's on unlock.
Starting motion.
Copy. I see good motion.
Copy.
You can stop motion in 3, 2, 1, stop motion.
Okay, that's motion stopped. And are you happy with that position?
Yep, I think we'll be good.
Gotcha.
Good here, and GCA.
Copy, GCA complete.
Copy.
Brakes are on. Your go for APFR ingress.
Copy, brakes are on. I'll go for ingress. And we, one more time, the APFR settings that we're expecting.
So 6, Fox, Fox, Fox 12.
Okay. I think that I saw golf on there when it came by. For the golf. Okay, nope, I can confirm it was just a little parallax. It's Fox, Fox.
Okay. You go for ingress then.
Okay, copy.
Okay, Luca, as you approach the work site, a couple things to think about is attaching an adjustable fair lead on ELC2 as required, and just to prevent that tension on the safety tether that we had on earlier EVA, and then the MLI bags going on the ELC.
Copy all. Okay, I'm ingressed into the APFR.
Copy, Drew. We're setting up for the next.
Copy, Nana. So on you, go for the back off.
Copy.
And Luca, just a reminder about that fair lead. We think Drew left you an adjustable out there on the outside, used it to hold the bag down.
Yep, I think I'm familiar with the location. I am at UTSR, and I see the handle Drew used for his local tether, and sorry for his third lead, and I will use the same one.
Sounds good, Luca.
Okay, Drew, the tag is still here. Oh, good, yeah. Luke and I have been having recurrent nightmares that we'd go out there and the red tag wouldn't be there. So that's a relief.
I'm glad you didn't tell us.
Yeah, I just never know. A couple of reboots have happened since then.
Drew, I copied you or go for the back off. We are ready for that. It's going to be about 1 meter, body left for you, station forward, and confirm your ingress aid is still in a good position.
Copy, ingress aid tucked in.
Copy. Starting motion.
Okay, I see good motion.
Copy.
The Canadarm2 is now in motion, taking Drew Morgan to his respective work site on the starboard 3 truss. Christina Cook at the controls of the Canadarm2 robotic arm today as she maneuvers Drew Morgan over to his work site where the alpha magnetic spectrometer is located. Cook is in the final stretch of her long-duration mission and currently sits in 8th place on the U.S. Astronaut all-time endurance list. Cook returns to Earth on February 6th and will land in 7th place on the U.S. Astronaut all-time endurance list, with the record for the longest single spaceflight by a woman, which she acquired on December 28th, passing former record holder Peggy Whitson.
Looks hopefully it's pretty stable. It's enough.
All right, a note for you, Luca. Remember about that grapple fixture behind you when you're in the APFR.
Copy. Okay, my gloves are still pristine, no changes, and my hat is dry.
Copy, Luca.
And Luca, that grapple fixture never ended up being much of an issue for me, but it definitely could be. Copy. I'll try to make sure that it's not.
All right, Drew, from you, looking for a glove and hap check as well as your safer handles, just because we saw you close to the truss there when Luca was squeezing by you.
Andrew, for you, we are ready for your next motion. It's going to be a 3.5-minute JOCAS to S1 intermediate in burn.
Okay, stand by 1 second. And then I'm going to check my handles.
Copy, standing by.
Okay, both handles are down, and the gloves are pristine, app is dry.
Copy.
Okay, Nana, with that, I'm going to go for the next showcase.
Copy, starting motion.
Good motion.
Gentlemen, you're probably noticing the sun is coming up.
And we do.
Another helmet camera view from Drew Morgan's helmet camera, which is helmet camera number 20. Another way you'll be able to tell the difference between the two spacewalkers today, and also by their spacesuits. EV1, Drew Morgan, will have the suit on bearing the red stripes, and Luca Parmitano will be in the suit with no stripes.
Copy that.
All right, Luca, we see you've been working away on your nest. Once you're all set up there, the next thing for us to talk about is your access for the VSB leak checks. And you know I've got some potential APFR settings for you if you want to try doing it from the APFR.
Hey, let me give a look at the site. And go ahead and let's do the APFR setup, yeah.
Okay, so I'll give you the suggested settings. So it's clocking a 6, which should be no change, and then it's Mike Hotel 6.
Mike Hotel 6 copy works.
From my understanding, those APFR settings are for this work, or those were not the original ones, were they?
No, they're not the original ones. These are just some suggested settings based on Doug that might be helpful for the leak inspection check.
Copy.
All right, for both of you, when we're in the VSB area, we want to avoid contact with the nut plates on the back of the IPA, just for sharp edges. So that'll apply to you first, Luca, if you're heading that way.
Yeah, copy. Luke and I were talking about that. We're calling that the backside of the IPA was.
And Drew, this is Christina. That's position hold. Stand by while we set up for the next.
A view now of the Canadarm2 robotic arm, which will maneuver Drew Morgan over to his respective work site.
Okay, I have Mike, and I did check that the button can be depressed.
Okay, good check, Luca.
Drew, this next showcast is going to be a 3-minute in course to S3 intermediate.
Copy, 3 minutes in course.
Starting motion.
Copy. See motion.
Copy.
All right, we're going to be handing over here in about 50 seconds. Let me just talk through a few warnings and cautions for both of you on how you can hurt yourself or AMS. We're avoiding contact with rough cut tubes that are still in there. Avoiding loads into the UMA cables for the NATO Worksite, the ACC cables, the forward side of the radiator crates. We don't want to put gross motion into the tubes or the tube clip at the NATO site, Drew. And avoid contact with connectors and cables on front and back of the LUSS bricks, the LUS bricks. And finally, you can't both put loads on AMS or ELC at the same time. You need to stagger those. We're handing over. I'll talk to you in 20 seconds.
Okay, copy, good.
We're in a short handover between satellites right now, but we will be reacquiring video from the station momentarily. Now just over 43 minutes into today's spacewalk, Drew Morgan has installed his APFR, or Articulating Portable Foot Restraint, on the end of the Canadarm2 robotic arm. And Christina Cook, at the controls of the Canadarm2 robotic arm, is in the process of maneuvering him over to his respective worksite on the starboard 3 truss, where the AMS is located. Again, the spacewalk today is the 4th and final planned spacewalk in a series to repair the alpha magnetic spectrometer. Morgan and Parmitano will finish installing the new cooling apparatus and lines and verify they are ready for use. Assuming everything goes as planned today, the AMS project office has forecasted the following preliminary timeline for the reactivation of the instrument and resumption of science. Again, if everything goes as planned, Sunday, tomorrow, we'll complete the filling of the thermal control loop with CO2, then allow the system to stabilize. Monday, January 27th, the first pump will be powered on, which will allow it to filter out any debris in the system. The tracker will also be turned on that day. Then on Tuesday, January 28th, verification of the other 3 pumps to verify proper operation will begin. And finally, on Wednesday, January 29th, is when the teams expect to be receiving good scientific data again.
Get caught up to you here. So big warning, or big note here, Luca. Remember, as we do this, we do not want to bump that cylinder. And I know you're aware of that. So that's after we open the VLI. So I understand we're going for number 5 first. First step is to open the MLI sleeve.
Okay, teamwork. I'm manipulating it first so that it's a good position for me. And the MLI is coming up.
Copy.
Okay, and I have the AS is visible now.
Okay, once you're convinced you've got it in the right orientation, think about the line of sight you want on that leak indicator. Get that all set up, and then very carefully open the the VLI handle. And remember, you need to look at it from the angle of the number side.
That's where I am right now for number 5.
And Drew, if I may break in here, the next move is going to be a 3-minute showcast to AMS Common in course.
Copy. AMS Common in course.
Bring motion.
Copy.
Okay, Luca.
Okay, I'm attempting to open the VLI.
Yep, go for it.
Okay, and as soon as I open the VLI, I have red showing on number 5.
Okay, we copy that. I think I can see it in the camera as well. Just move that tag, the number 5 tag out of the way there, Luca, for a second. Just lift up the 5. Yeah, that's it.
An acronym you'll hear throughout the day is VLI, which stands for Visual Leak Indicator.
All right, first thing you can do right now, Luca, is go get the wrench from the MLI bag.
Sure. Copy. In work. Luca, I'm going to start to become visible to you. Copy, Drew.
Drew, that's position hold. Stand by while we set the next.
Copy, position hold.
Now 49 minutes into today's spacewalk, the International Space Station is flying 270 statute miles above the Pacific Ocean.
Did the MLI peel back nice and easy?
Yeah, MLI comes out pretty easily, yeah.
Sorry, Luca, I missed that call if it was for me.
What's for Drew?
Yeah, I was just asking about how easily the MLI came back off the AAS. And he reported it was pretty easy.
And Luca, we watched. It looked like it was hard to open that VLI handle, which would make sense if there was pressure on that cap. Yeah. All right.
It was pretty hard, and he popped out. He popped out quite fast. So I'm safe to say that I'm pretty sure that I didn't move it.
Yeah. No, it looked good. We had a good visual when you did it, so we concur.
Andrew, for your motion, the next is going to be a 3.5-minute JOCAS invert to the nadir back off position.
Copy. Nadir back off.
Motion.
Okay. Well, our day just got a little more challenging, but we have a good plan for this, so we'll get after it.
Okay, I have a good, I have the wrench.
Copy. Good motion.
Okay, Luca. So we'll go back there, and you can assess whether you think you want to be doing this free float, or we want to wait to get Drew in there.
The view we're getting now is from helmet camera number 18, which is that from Luca Parmitano's helmet camera.
I think I am in a good position to do it on my own.
Yeah, I think that looks reasonable to me, Luca. So Luca, we're interested in whether that went the full stroke or not. It's the next step we're going to do anyway, is to vent the VLI cap anyway.
It looks to me that it's fully vented.
Okay.
Luca,
So
I'm right off your left side.
you can go ahead and cycle it. You can go ahead and cycle it, Luca, the VLI cap.
Okay, that's recycled and it's closed.
Okay. And let's go all the way towards the VLI handle and then back to close, just to double check. We want to make sure we vented all of it.
Okay, all the way to the VLI handle, fully open, and then back fully closed, cycled.
Okay, and based on what you did inside Space Station with the trainer, it looks like it's going all the way open?
Going all the way open, means going all the way closed.
All right, thanks. Okay, what do you got for letter number alignment?
I have Bravo 8.
Okay, so the way we think we left it was in between Bravo 1 and 8. Is it, does that line up, Bravo?
I agree. That's the correct, that's what I'm seeing. I didn't know how to call it, but yeah, that's what I see.
Okay, Bravo 1-8. Okay, so what we're going to tighten to, Luca, is Bravo 2-1, Bravo 21.
Copy, Bravo 2-1. I'm opening up the main handle, the AF handle.
Yeah, and so
Andrew, that's position hold. Stand by while we set up the next.
We're going to install the wrench, and then we're going to loosen the VLI handle all the way to soft stop, and then tighten one turn.
Okay, copy. I'm going to lock with the wrench installed, and then loosen the VLI handle completely, you said, to soft stop.
A firm, and then back one turn, tighten.
Copy. Okay, it's at soft start. I'm going to make one full turn. One full turn.
And Drew, for you, this is going to be a manual maneuver about a 1/4 meter nadir, which is going to be in the direction of your body back slightly. And Luca, we think clearances will be good for this first manual maneuver, but be aware, pretty soon we're going to be taking you for GCA.
Copy. I'm in a good position anyway. Or very easy to get in a good position.
Copy. Starting motion.
Copy. Motion.
All right, Luca. So you're going to tighten one flat. We're going to Bravo 2-1. Does that make sense to you?
It does.
Drew, that was the nadir motion. Your next motion is going to be about 1 meter forward. That's about in the direction of your head. And for Luca, watch Drew's clearance to AMS and structure. For Drew, check your ingress aid.
All right, Nana and Drew, just stand by one. Nana and Drew, stand by one. We're going to finish this tighten, and then we'll do the robo, because this is a long pull for us. We want to start the 1 hour clock.
Copy all.
Bravo 2-1 set.
Okay, I copied Bravo 2-1. That's good. Go ahead and tighten the VLI handle. Remember, we do this quite snugly, if that's a word.
It's as tight as I can get it without over forcing.
Okay, and we're going to cycle the VLI cap one more time.
Okay, fully open, fully closed.
Close the VLI handle and the AF handles, and then put the...
And just to recap so far, there was a slight leak on the first 2 tubes they performed leak checks on. Luca Parmitano will continue running through procedures to check the tubes to follow.
Okay, that's complete. All right, Whiff. We'll go next.
All right, that's it. So now you can go ahead and help out with the GCA.
All right.
Okay, do you think you're going to have similar access to the remaining?
I have a perfect access to all of them, yeah.
Okay. Just check your the reel right now is between your legs. If you go up a little bit, you'll see it.
I cannot see right now, Drew. But I'll take care of it when I have to. Is it in between my legs right now?
Correct.
Sure, what's a good motion to get rid of?
If you can go to your head, or you could kick your feet back, straight back. You know, you have the ingress aid to your left. And if you can put your left hand on the ingress aid, and then lift your feet.
Okay.
Yeah, and then use that to help you lift your feet straight back. Okay. Yeah. There you go. Perfect.
Thanks, Drew.
To clarify, only one tube showed a leak, and Luca was able to tighten that one up, so he's going to go ahead and run the leak test one more time on those tubes.
Copy, and when you guys are working, I'll go ahead and repeat the description of the motion. It's going to be about 1 meter station forward. Drew, that's going to be in the direction of your head, and Luca will be watching your clearance to AMS and structure.
Okay, I have a good view.
Okay, we're ready for motion.
Copy, starting motion.
Motion.
Copy.
Clearances.
Half meter to go.
Copy.
Motion to clearance.
And Drew, this is the published Nader Worksite position. And would you like to go ahead and flown to the as flown Nader position from before?
Yes, I think that'll be a good idea. Well, I assume we'll do them one at a time.
That's affirmative. For your first motion, it's going to be about 12 centimeters to your left. Stand by while we set up.
Copy. And Luca, I think we can go ahead and release hook A.
There you go.
Perfect. I think that will be enough.
I agree.
Okay, Drew and Luca, we're ready for that motion I described, 12 centimeters to Drew's left.
Copy.
Copy.
Motion.
Motion.
That's your 12. For your next, it's going to be about 15 centimeters in the direction of your head.
Does that look, Luca?
Okay, it looks good to me. I don't see any issues.
And Luca, for you, you'll be just continuing to check Drew's clearance to the AMS.
Copy.
Starting motion.
Drew's clear. Make a motion.
And that motion is complete. The next is about 15 degrees, pitch down.
Okay, makes sense.
Starting motion.
Copy. Motion. Clearances.
Okay.
Look up here, Luke, pretty good.
You look good.
And there's your pitch motion.
Copy.
And your next motion is going to be body in. It's going to be about 30 centimeters. And again, just Luca checking Drew's clearance to AMS.
Good clearance.
Starting motion.
Okay, good motion.
And that is the final motion. This is the as flown Nader Worksite.
Okay, Drew is completely cleared. The arm is cleared. Whiff and Whiff extender and APFR are clear. Drew, just watch your own body with regard to the edge of the radiator.
Yep, I see it. How much clearance do we have at my head, do you think?
You have about 45 centimeters to the top of structure. You have to your right and 45-degree angle, you have some cabling, which are a little closer. So unless you lean to the right, you should be clear.
Okay. Could I get 10 centimeters to my head, you think?
You can get 10 centimeters, yes.
Okay.
Then I can watch it.
And then I would take 10 centimeters toward my head if that's an acceptable move.
Copy. 10 centimeters, body up.
You can also take 10 body forward, Drew, if you need it.
Okay, let's do 10 through my head.
Okay, Drew, starting motion.
Motion.
Good clearance.
And there's your 10.
Okay, and we'll take 10 more body in.
Copy. 10, body in.
Body in, copy.
Starting motion.
Motion.
And there's your 10 additional body in.
Okay, let's call that GCA complete.
Copy. GCA complete.
Copy is here complete.
Okay, Drew, the big thing here is we don't want to put a lot of stress on that clip. We already talked about it, but I just remind you. So as you position the AAFs for you to do your inspection, keep that in mind. And Luca could tie off that that MLI. Maybe you could put that hook down if you want, if that would help you. And Luca, one thing for you, if you could check your WVS video, we think it got bumped off.
Okay.
Luca or Drew? Luca. Okay, yeah, your light is out. Is mine on?
Yeah, we've got you, Drew. Just Luca we lost.
Okay.
Drew Morgan now in a comfortable position at his work site to begin doing his leak checks.
And we've got Luca's video. All right, Luca, so you're going back to choose another tube, and Drew, you choose whatever one's most convenient for you.
Okay, I have tube 2 here.
Okay, copy, you're on 2. You can remove the MLI.
Copy.
I'm going for number 8.
Okay, copy. You're on 8. Remove the MLI, Luca. Andrew, just a reminder for you, you need to position yourself so you're looking from the number side for the leak. Looks like you got pretty good line of sight there to me.
I do.
Okay, and reminder for you, Drew, is that when you do open this VLI, do not touch the cap or the cylinder.
Copy that. If you go, I'll go ahead and open the VLI.
So, Drew, just be advised, the MLI is underneath your WVS, so we can't back you up here. All we see is MLI. But we're okay with that, however it works for you.
About now.
Almost. Just push it up a little bit further. There you go. We're with you.
Okay, if you go, I'll open the VLI.
Okay, you're go to open the VLI. Watch the cylinder.
Drew Morgan now opening the visual leak indicator, or VLI, on the first tube that he'll be performing a leak check for today.
Okay, closing the VLI. VLI's closed.
And then close up the MLI sleeve, and then you can position yourself for number 4.
And number 8, check red.
I didn't copy that, Luca. Say that again.
I checked number 8. I opened the VLI. It opened up very easily, and I see no red, no motion.
Okay, copy. Good check on 8. We see you closing up the VLI.
I have the MLI sleeve pulled all the way up to the foil.
All right, Drew. On to number 4.
And on to number 6 for me.
Copy, Luca.
And Luca, check your feet here a little bit over on the nadir side. Yeah.
This view now from the helmet camera of Drew Morgan, who is about to begin a leak check on his second tube.
You have the MLI back on number 4.
Okay. Same as before, Drew, if it's convenient, you can put that MLI above your WVS for us. We'll back you up.
A view now of Drew Morgan in the center of your screen in the suit bearing the red stripes attached to the Canadarm2 robotic arm as he performs his second leak check.
Okay, I have number 6, and I'm ready to open the VLI.
Okay, your go, Luca. And we see you, Drew.
Okay, for number 6 VLI, fully open, no red.
Copy. Good words, Luca.
Okay, I'm going to go ahead with 4.
Okay.
All right, fully open, no red. No, it was a very clean open, very easy.
Okay, for number 4, 6.
Okay. Understand that, Drew. Luca, we hear you're going to, you're wrapped up on 6.
Complete, and the MLI cover is down. And next will be number 7.
Copy, Luca. Drew, you can make sure all the MLI sleeves are secure. There's no metal shown anywhere. And then you can button that worksite back up.
And we just received confirmation that there were no leaks on the Nader worksite.
We, in addition to no metal showing or exposed tubes, make sure there's no contact with structure.
Okay, for number 7, I have a good view of the VLI.
Okay, Luca. Our view's obscured a little bit, but you can go ahead.
Okay, the VLI is fully open, very easily, no red.
All right. Copy, 7 is good.
The MLI sleeve on 4, we're covering it. I can feel that both AF handles and VLI handles are down, covered, and I'm going to duck it back in place.
Sounds good, Drew.
Okay, the inner MLI covered.
The next one for me will be number 1.
Okay, Luca. Drew, you want to grab some imagery of the worksite, just how it got left before you button it up?
Good work.
And just a heads up for you, Nana, inside station will be done at the Nader worksite here very shortly. We'll be moving the arm.
Okay, number 1, I have a good view of the VLI.
Okay, your go for 1, Luca.
VLI fully open, and I have no red, good check.
Okay, 1 is good. Just number 3 left to check.
Yep.
Now only 1 tube left to check for Luca Parmitano, and that is the view that we're getting from this helmet camera right now, helmet camera number 18. The International Space Station and the 2 spacewalkers now flying 263 statute miles above Africa.
Yeah, we've got a good view in the WVS, Drew. We're just doing a quick scan here. All right, big picture for both of you here. We got about 40 minutes left on the clock to check the VLI on number 5, so we're not really in any rush here. We got lots of time to close this out. work together at the NATO Worksite to get that the MLI put back.
Okay, Jeremy, I have 3 visible. I'm ready to open the DLI.
Your go, Luca.
And no red. Recheck. Cleanly came out and cleanly closed. Three's
Okay.
good.
All right. 3's good.
And the final tube reported to be in good condition.
Worksite there, Drew. You'll probably just wait on Luca to come back and do up the MLI ret there.
And then I'll take pictures of that fully installed again.
Hey, Jeremy, I'm going to have to maneuver a little bit to reposition this MLI over 3. It's
Yeah, understood.
impinging. Yeah.
Like I said, there's no rush.
Hey, do you have a visual of my safety tether and my legs?
Yeah, let me see here, because I did see it right before you moved. So it is right now. I don't have eyes on it. Okay, you got it. Turn toward me. And go back and feet into the vertical again, where you were. All right. Yep, and rotate that way, and you should see it off your right side now. Okay, and it is in front of you.
All good.
Okay. So the next thing we need to do is reconnect that hook A to the.
As soon as I'm done with this, I have one more MLI to cover. And okay, and 3 is back covered. So I'm ready to go back to you, Drew.
Okay, yeah, all you got to do is take that hook there and put it on back on the diagonal beam hammer, and I'll take some closeout photos of this to make sure this all stays down. And I don't recall, is that thing fixed length? Yeah, it's a fixed length.
And it's back onto the tether point.
Okay. I'll get some closeout to this. We'll be ready to move to the next site.
Yep, that sounds right, Drew.
And in the meantime,
Just to recap the events so far, Drew Morgan completed the leak inspections at the Nader worksite and found no leaks. Luca Parmitano tightened the connection on the leaking tube that he found, starting the 1-hour dwell clock, after which it will be re-inspected. Luca Parmitano also completed the remaining VSB, or vertical support beam, tube inspections and found no additional leaks. The crew will now close up some MLI, multi-layer insulation, while they wait to recheck the leaking tube. There's currently 35 minutes on the clock before the recheck can occur, so now both spacewalkers are taking some closeout still photos of their work sites.
Okay. And with that, if you are satisfied with the WVS survey, I've got some closeout photos of this, and MLI is back in its original configuration, and on you, we can continue on to the next robo maneuver.
It sounds good, Drew. Yeah, we will be ready for that. Just stand by a minute. We're working some robo issues inside.
Teams here in Mission Control Houston are reporting that all other alpha magnetic spectrometer systems look good and everything is proceeding normally.
Like my camera is set on a single shot.
The shutter actuating for you?
That
Was the shutter actuating for you?
it is actuating, I can see, but it's a single shot every time.
So,
Okay, guys, you have a little bit.
See that your waist tether.
You guys have a bit of time here. We're handing over in about a minute, and I'll talk to you on the other side of that, and then we'll see where we are with the robotics inside.
Copy. And good. So just so that you're tracking, your waist tether is just going right straight across there. So
Straight across my in front.
Yes, straight in front. It is all in front of you.
Yep.
We're in a short handover period between satellites right now, but we will be regaining that video connection with the crew here soon. Just to recap the events so far, Drew Morgan completed the leak inspection at the Nader worksite and found no leaks. Luca Parmitano was able to tighten the connection on the leaking tube that he found, starting the 1-hour dwell clock, after which it will be re-inspected. Luca Parmitano also connected the remaining completed the remaining VSB, or vertical support beam tube, inspections and found no additional leaks. The crew is now closing up some multi-layer insulation and taking some closeout photos while they wait to recheck the leaking tube. And they'll be able to recheck that tube that is now tightened in just under 30 minutes from now.
Let's see, we got the MLI deployed. Do you want to hand the wrench off to me now, or get me one of the wrenches?
I think at this point I'll just give you this one.
Okay.
Because the only use that we have from over here is what I just did, so might as well. What do you think?
Yeah.
A view now from Luca Parmitano's helmet camera as the International Space Station flies 264 statute miles above Asia.
Bring you back out to the nadir worksite position and remove those additional GCAs when you are.
Okay, we're ready for the additional GCA. Standby 1. We're just going to do one hand off of the tool.
Copy.
Hang on, Drew and Luca. We're just talking that on the ground. We think Luca needs to keep that wrench for now.
Okay, roger that. All right, we'll leave it on. You still have a red to it?
Yeah, I read it.
Okay, and the red is off.
Yeah, I have it.
Okay. Wrench is still with Luca.
Okay, thanks.
And I copy as well. And with that, we are ready to take you body out. It's going to be about 45 centimeters.
Roger that. Start GCA. Your go.
And Luca, that'll be body out for Drew, so he will be, clearances to AMS should be increasing, but we'll take your eyes on any clearances in the area.
If I can ask you to go body down first, clean that 10 centimeters EVP best.
NASA astronaut Christina Cook at the controls of the robotic arm today. She's going to go ahead and back Drew Morgan off from his position where he is right now, working on the AMS.
Good motion.
And starting motion.
Yeah, that was you, Drew.
That was all me.
Okay, we're starting motion now.
Copy. Okay, yeah, there we go. Good motion.
That was your 10 body down. And if you agree, we'll go ahead and do what will be about 40 centimeters body out at this time.
Okay, Christina, thank you for adjusting. It's now much better. And there you go for body out.
Okay, thank you for that adjustment. And starting motion, 40 centimeters, body out.
Good motion, good clearance.
Good.
And stand by for the next. Okay, your next motion up about 15 degrees.
Okay.
Motion. Okay, Drew, that was your pitch. Next, we're going to just take out a little bit more body down. It'll be about 13 centimeters.
Copy.
Motion.
Good motion.
Okay, and that was the rest of your body down. Finally, we'll go right about 15 centimeters.
Copy.
Starting motion.
Motion.
Okay, and that was your 15. Stand by while we set up for the next.
Copy. Do you still have good WVS on me?
Affirm, Drew. We do.
Okay. Looking back at the MLI, there's the two notches cut in the bottom, the side closer to the C-hook. The way that it fits over there, it kind of gaps over here to the right, if you can see that, and I can adjust as I've taken some pictures of it. But just the way that flap is cut and the way the cutout of the bottom of the Worksite here, it kind of opens it. It's over to the right side, so it's not near the AAF Worksite.
Okay, we're handing over here, Drew. I'll be back in 20 seconds.
Hey, Drew and Luca, this is Nana. We are ready to proceed with your next manual maneuver. It's going to be approximately 1 meter aft, which, Drew, is going to be in the direction of your feet.
Copy.
Starting motion.
Okay, Drew. We couldn't really see what you were talking about. It was just too dark in that view, but based on your words and description, we're okay with that because we have the original blanket underneath that area, and so we don't have a concern based on what you said. Does that make sense to you?
It does. Yes, the original inner layer is definitely there, intact, and covering everything. So yeah, I just wanted to make sure.
Okay. Yep. Good call. We're happy with that.
Drew, that completes that motion. Your next motion is going to be about a quarter zenith, which is body in for you.
Copy.
Starting motion.
Motion.
Just to recap some milestones so far, Drew Morgan completed the leak inspections at the Nader worksite and found no leaks. Luca Parmitano tightened the connection on the leaking tube that he found, starting the 1-hour dwell clock, after which it will be re-inspected. Luca Parmitano also completed the remaining VSB, or vertical support beam tube inspections, and found no additional leaks. The crew is currently waiting for the clock to run out in just under 20 minutes from now, when they can re-evaluate the tube that Parmitano tightened. If the tube shows a slight sliver of red, Parmitano will tighten the tube again, and if it's more than a sliver, the crews will re-evaluate how to proceed. The complexity of these AMS repairs and the initial expectations for its full restoration, which is anticipated after today's spacewalk, harkens the thought of Icarus, the son of the master craftsman Daedalus. In the mythological interpretation, Icarus' father asks that he fly neither too high nor too low. The AMS repair work being conducted by Morgan and Parmitano is often compared to the servicing of the Hubble Space Telescope.
Okay, gentlemen, we're tracking that you're on your way to common. Drew, here's a big picture update for you. We're an hour 40 into the EVA. We're essentially on the original timeline of the EVA. Our limiting consumable is Medox on you, Drew, at 6:42. So the big picture plan right now is we're just going to leave you at common, Drew, once you get there. We'll wait another 18 minutes until the clock expires on tube 5. We'll have Luca check it. And there's 3 options there. 1, it's good to go. Then we'll just proceed with you going to zenith. 2, if we have a sliver of a leak, then we'll probably go ahead and do 1 more flat and another hour clock. If we have a big leak like we had initially, this would be the 3rd option, then we're going to talk about that, but that might send us direct to a jumper, and that's why we'll hold you at common, Drew, because we might want to bring the arm into the VSB in that case.
All right, copy all. Sounds like a great plan. Agree, Luke?
Give me 2 copies, and sounds like a plan.
Okay. All right. Well, we got 17 minutes left on that clock for number 5.
Andrew, that is position hold at AMS Common, and we copied that we'll be waiting here with you for a little while.
Copy that. Not even a day pass.
Now 1 hour and 43 minutes into the spacewalk today. This is the final in a series of 4 spacewalks to repair the alpha magnetic spectrometer. The AMS was launched on Space Shuttle Endeavour to the station 8.5 years ago to study dark, invisible matter that can't be directly detected. The goal of the alpha magnetic spectrometer has been for scientists to track down sources to help understand dark matter and the origins of the universe. As with many items that are exposed to the harsh environment of space, the alpha magnetic spectrometer needed to be upgraded to continue collecting data. AMS began showing signs of age in 2014 when one of the cooling pumps stopped working and another was found to have been degraded. In March of 2017, researchers switched to the last fully functional pump to keep the science alive. The AMS team realized they would need to take action to keep the scientific instrument going and enable the AMS to function through the lifetime of the International Space Station, leading to the series of 4 spacewalks. These spacewalks are considered to be the most complex of their kind since the Hubble Space Telescope servicing missions. The AMS originally was designed for a 3-year mission and, unlike Hubble, was not designed to be serviced once in space. The work to prepare for the spacewalks, which began about 4 years ago, involved making, testing, and launching more than 20 new tools to the space station, many specialized for specific steps of the spacewalk, such as removing the debris shield, which was done in the first spacewalk, and tools to splice cooling lines, which was performed in the second spacewalk. These tools have gone through years of iterations and tests here on Earth by scientists, engineers, and astronauts. The 2 spacewalkers today, and for the series of the repairs, Drew Morgan and Luca Parmitano, had 7 training sessions in the Neutral Buoyancy Laboratory dedicated to repair training for these alpha magnetic spectrometer spacewalks.
My gloves are intact for steam. They look like baseline, the half is dry.
The 2 gloves are baseline. Like CVA1 and copy right.
Okay, copy. Thanks for those. So I don't know if you guys are just bored out there and filling time, but you could tell me, a non-spacewalker, what it looks like in a night pass looking down at the planet. What do you see?
Yeah, I was going to ask you where we were, because I don't think I've ever looked back down there at Earth during an EVA on a night pass. I just turned my lights out. I'm out here in the inky black above the ISS looking down. I can see the entire truss, but just past the charge, we just flew over a lot of great night lights.
Yeah, it looks like you're about the Sea of Japan, just off the east side of Asia there.
Okay, yeah, so that, yeah, it looks very heavily populated, so we'll be over Japan then shortly?
I can already see it below me.
There it is. Yep, I saw them with the Sea of Japan. We just passed it. You can see some fishing fleets out there in the Sea of Japan, and then you can see the entire island of Japan. Hello, Scuba.
I'm hearing on the back loops that Chris is in Tokyo today, so you can wave at him on your way by.
That's right. Chris and we, both you guys have been great mentors, and yeah, we got a note from Chris wishing us luck.
And I agree on both counts on the mentorship.
Well, it's been everyone's pleasure for sure. So, Luke, I got to know, what made you pick number 5 first?
It was the closest. That's the simple sound, so it was right in front of me. I'm like, sounds like a good point to start.
Just wondering if you had some sort of intuition or something.
Yeah, like I say, it's always better to be lucky than good.
Well,
it was both.
Suppose it saved us some time on the clock, getting that one, getting the timer started on that one first. But there's no other way to do that to create more drama than giving us that look on the first one. I think everybody's heart stopped.
Yeah, I wonder what my my flight surgeon saw on the download on my heart rate.
Yeah, they're not allowed to tell us, I don't think.
It's either flatline or spiked, one of the two.
Yeah, no doubt. All right, 8 more minutes to go. So, Drew, how quickly does the view change? Do you still see population, or is it just out in the black of the Pacific now?
Now I can see Japan just past my feet, kind of disappearing. Still see the lights. Definitely can make out probably Tokyo, I imagine, because it's very bright. Looks like maybe it's cloud covered enough because of the way that the night lights reflect on the clouds at night, kind of gives it a more smudged, less distinct appearance. But yeah, we're definitely out over the Pacific now.
So when you look out in the direction of Pacific, you just see nothing out there?
Yeah, right now there is in closer, like the Sea of Japan is there. We do see fishing fleets very distinctly, but this far out, I don't know that we usually see fishing this far off the coast, where it's not concentrated enough to make out the lights.
And can you guys look out from the station and see the stars, or is there too much light on the station?
I'm looking out over my left shoulder. I can make out a couple stars for sure. We do have the light looks like from one of the looks like the lab light or something shining kind of at us, so that that kind of washes it out a bit. But there definitely can see some. All I see is a vacuum case and a bunch of tubes.
Drew definitely has the better view. So, like, when you see those stars, though, Drew, are they bright or are they dark? Like, how does it compare to being in a dark place on the planet?
Right now, just with the floodlight competing, they look very comparable to what we would see on Earth looking up through the atmosphere. But when there isn't light like that, and when you can't see stars, they are distinctively bright, and they don't twinkle the way that the atmosphere causes the twinkling effect, so they're more constant.
Yeah, of course.
And then Luca had previously had seen, well, I don't think we ever determined what planet it was, but I mean, very distinctly saw one on the horizon from out here. I called it out doing a GCA.
All right, 5 minutes left on the clock.
545. All right, Luca, we're going to find the best body position ever for this. Like a raw egg. Handle it like a raw egg. No, I had the first suspicion that something was not how it should have been because it was so hard up in the VLI. All the other, and now, it was the first one, so I didn't have anything to compare it to. But then once I started the others, and they just opened so easily, and there was no motion whatsoever, other than the expected spring motion. This one is now very obvious that it was a leak. Yeah. Did you end up having to? You didn't use the wrench. You just opened it by hand.
I opened it by hand. Yes, the VLI, and it sprung back to red.
The crew is still standing by for the clock to run out in just under 5 minutes. When that clock does run out, they'll be able to recheck the tube that Parmitano tightened. If the tube shows a slight sliver of red, Parmitano will be able to tighten the tube again, and if it's more than a sliver, the crews will reevaluate how to proceed.
I see the light on the lab. I also see there's a light on us. Looks like from maybe CP8.
Sorry, I heard you talking about the lights, Drew, but was you just pointing it out, or do you want something?
No, don't need anything. I was just earlier I had said that it was a light from the lab, but we do see there's a light on from the lab and a light on from one of the other CPs out for the port side. No, all's good. It's not observation.
Yeah, we got a great view of you actually hanging from the arm. To us, it looks like you're hanging from your feet. Yeah, see you waving. Okay, Luca, the clock is not expired yet. We've got 2 minutes to go, but you can open the MLI, but do not touch the VLI yet.
It's starting to scrunch up the MLI.
One option you said to, if we were to turn another flat, it will be a full flat then, we'll turn. We go down that route.
Yeah, that's right, Drew. One flat. So he already did one flat, and then we would do it once more.
Copy.
And VLI is exposed.
Okay, minute and a half to go. I'll let you know.
Copy, standing by. Crossing whatever finger I can cross.
We are too, Luca.
You can still see that tape that we put on.
Now 1 minute away from the reinspection of the tube that Parmitano found a leak in and was able to tighten.
Everything looks as it should look.
Copy that, Luca. You got another 50 seconds to go.
Copy.
Moment of truth.
Okay, Luca, you can open the VLI. Do not touch the cap.
All right, Luca. Got this. Have faith.
Do you guys have a view?
No, we don't have a good enough view to see.
Sorry to report that I do have a leak.
Okay, we copy that, Luca. How much red we got?
Looks like a large leak to me. It's fully open.
Okay, we copy that. All right, we're going to need a few minutes to talk about what we're going to do from here, gentlemen, so give us a few and we'll get back to you.
Copy. Copy.
Luca Parmitano reporting that he did find another leak on this tube. Crews here in Houston are evaluating the steps to take next.
Luca, have you already cycled the cap to confirm it was full travel or not?
Negative.
Okay, so you can go ahead and move the cap and just give us an idea whether it was already full travel.
Yeah, it was full travel.
Okay, copy. Stand by. Okay, Luca, let's go ahead and close the VLI handle. Then we're going to wait just a few seconds. We're going to open it up and just give us an assessment of how bad this leak is.
Okay, so do you want me to close the cap again?
A-firm, close the VLI handle, which will close the cap.
Okay.
Okay, just hold there for a few seconds.
Sure.
Okay, open it, Luca.
Open.
What do you see?
No red.
No red, okay.
No red.
Sorry, I think I misunderstood. Did you say full red or no red?
No red. Zero. Non-visible.
Okay, no red. Copy. Okay, for everybody involved, here's the plan. We're going to quickly throw one more flat on this AAF, and we'll start the clock on that, and then we're going to start setting up to do the jumper, which is going to probably take us the better part of that hour. We may be able to finish that leak check, but we'll come back to that decision later. So the first thing we're going to do now is get that clock started. So Luca, we're going to put another flat on that AAF. Step one is to open the VLI, and then vent.
VLI is up.
Okay, now go ahead and vent the VLI cap.
Vented and we closed.
Okay.
And I'm going to release the VLI till a soft stop, correct?
Yeah, you can, well, before you do that, open the AAF handle and report the number letter alignment.
Bravo 21.
Okay, you need to install the wrench, and then you can open the VLI.
Copy, and that's complete and there's no motion. Bravo 21 is set.
Okay, you opened it all the way, the VLI, and then tightened it one turn?
No, negative. Right now, I just have the motion with the VLI fully open to a soft stop, and Bravo 21 still there. So now you want me to tighten it?
Yeah, tighten it one turn only.
Okay, I am at Bravo 23.
Okay, you're at Bravo 23, that's a good number. You can tighten the VLI handle, snug.
Okay, that's complete.
All right, close the
VLI.
That's right. Close the VLI, close the AAF, and the MLI.
Work.
Okay, Luca, you can start making your way to the airlock, and Drew and Nana, we're going to take you to the VSB worksite. And Drew, whenever you have a good place to get out of the arm, you're free to do that and start setting up the worksite.
So I think we're going to need Luca for some parts of the VSB CA.
Yeah, and the back room's saying the same thing to me as you're saying, so probably stand by a sec there, Luca. We got to rethink that.
Standing by.
Okay. All right. So Drew and Nana, you start on your way to the VSB worksite. And as soon as you can get out of the arm, Drew, just stop Nana, get out of the arm, and then we'll be able to send Luca back to the airlock.
Copy. Right now, I'm with you.
And Drew, I am with you as well. Stand by while we set up.
Copy. One thing we could have Luca do, go back to the nominal APFR setting for the work site.
Okay, that sounds right. I'll look up those settings, Luca.
Copy.
Drew, this is going to be a 2-minute JOCAS in course to VSB Intermediate.
Copy.
Starting motion.
Luca, you're looking for India, Kilo 12.
Copy. India, Kilo 12.
Andrew, there's a request for you when you exit the APFR, if you could just do it on the ingress aid alone and then reach over to structure, not use AMS to get out of the arm.
Absolutely.
Andrew, that's position hold. Stand by while we set up the next.
Take copy.
Andrew and Luca, we are ready for the next motion. It's going to be a 1.5-minute JOCAS in Vern to VSB back off. And Luca, it looks like Drew will be coming into the position where you're at right now doing that APFR work. So I'll pause until you're in a good config to watch him drive in.
Yeah, I'm having a sticky kitchen up.
Luca, let me recommend you just leave it as is for now. Let's keep the arm moving, and we can work the APFR later.
Copy. Okay. And you're coming right in between me, I suppose, so go ahead with the motion. I'm not familiar with what it's going to look like, so go ahead and move it and move the arm and myself and the APFR accordingly.
Okay, copy that. And it is going to be kind of, just for your awareness, just aft of the VSB Worksite, kind of right before we start threading that needle between the ELC and the Worksite.
Okay.
So I think you are in a good config. And with that, Drew, if you're ready, we'll start motion.
Ready for motion.
Ready motion?
Good motion.
Copy, good motion.
If I need to lean, Luca.
You're good now. Stop motion. Stop motion.
And we have paused the JOCAS. And I see position hold.
Okay, I'm trying to rotate the APFR. I don't know where Drew is going to end up, so just want to be...
I mean, it's going to be right in here, but, I mean, I have any idea how much further we've got in the OCAS? Luca, yaw it with the toe loops more like this way.
Drew, we just confirmed with Houston that we are very close to the end of the JoeCast, so if you all can get comfortable with a little bit more motion in the same direction you were going, I think it'll be about 20 centimeters more, then we can reevaluate for the manual moves that are coming up.
Copy, continue.
I'm go to continue.
Copy. Andrew, starting motion, it'll just be a short motion.
Copy. Airfield motion started.
Copy. And that's position hold.
Okay, and for weed, at this point, I could get to the APFR, so we could hold here. If this is a good place, I could egress. I could get the APFR and do configuration, and then I can start setting up the worksite.
So why don't you fly into the? Okay. Yeah. Okay. That sounds like a plan.
Yeah. Sounds good.
Let's check with you, big guy. I think we wanted only to go as far as we needed to. I think is what I gathered.
That's it, Drew. Sooner you get out of the arm, the sooner we can send one of you to the airlock.
Okay, and I copy as well. With that, we're going to put brakes on standby.
Copy.
Brakes are on, and you have a go to egress.
Okay, just a reminder, we can only have one of you move in on the ELC at a time. So just before you get on the ELC, Drew, Luca can actually, you might as well get on your way back to the airlock, Luca, if Drew doesn't need you.
Yep. Okay. I'll get out of your way so you can, and then so watch the ingress aid, go up over. And if you would, when you take up the air lead, we'll just leave that adjustable in place. Sure.
This is Mission Control Houston, recapping some of the procedures that the crew has gone through so far. Drew Morgan completed the leak inspections at the Nader worksite and found no leaks earlier. Luca Parmitano tightened the connection on the leaking tube that he found, starting the 1-hour dwell clock, after which it would be re-inspected. Luca Parmitano also completed the remaining VSB, or vertical support beam tube inspections, and found no additional leaks. After an hour of waiting, Parmitano rechecked the tube, again saw an indication of a leak, and tightened the connection again. If the inspection in the next 48 minutes continues to show a leak, the team is working toward installing a jumper that would work around the leaking connection.
Okay, Luca, I'm going to be handing over in 25 seconds. Just a reminder, you do not need to get your green hook on the way back.
Copy.
Ender?
Yeah, ELC.
I don't see ELC.
Again, the crew is back on a timer now before they can recheck that tube that was leaking for a second time. And if that inspection continues to show a leak, the team is working toward installing a jumper that would work around the leaking connection. The International Space Station is currently flying 269 statute miles above the Pacific Ocean.
On APFR adjusted to India.
I'm back with you guys.
I'm on the DMT.
We have got the ELC APFR at India.
India, Kilo 12.
Kilo 12. Okay.
Okay, first job for you, Drew, once you're in a good config, is to get the tool board.
Okay. Okay, since we're a little off script, I'll talk out loud a little bit more. I'm going to put my weight tether on the opposite ingress aid than my own for egress. My safety tether is staying where it is. I'm not touching it.
Okay.
Okay, that's egress.
I guess, do we want to keep the arm moving, Drew, with you doing the clearing the arm for now to get it into the position?
I think it will be. We can move it a little bit. Because right now, I just egressed it, and so Luca would have no problem ingressing it.
Yeah, it's just a time-saving thing. The arm is...
Yeah, with the airlock, and I opened the cover.
Okay, Luca, what I need you to get is the 2 contingency bags. So there's a crew lock bag and a small ORU bag number 2, and you're bringing them both. You can bring the large small rets if you want. They might be useful out there, but that's your call.
So I need to pack them?
Yeah, you'll need to bundle them and bring them with you. And for you, Drew and Nana, we think we should get the arm moving.
Okay, so just to be clear that I'm tethered to it. My safety tether is to the arm. I'm the HFR and ELC.
Yep, we're with you.
Okay, stand by. I'd like to ingress the other APFR.
And I copy as well and confirm that we're going to be pushing into the VSB worksite.
Good copy, Nana.
Okay, I'm ingressing the other APFR. Now I'm ready to make our next move.
Copy, we're setting up for that. And Drew, we're ready to move the arm. It's going to be moving about a meter station forward in towards the worksite.
Okay, copy.
Starting motion.
Copy. Good motion.
Copy, good motion. Drew, that's our first maneuver complete. Stand by while we set up for the next.
Copy. So now at this point, you're going to fly to the previous ETA position.
That's affirmative. We're going to first fly to the VSB Worksite position, the published position, and then we'll check back in on whether we also are going to put in the as flown position from last time.
Copy. I understand.
Okay, Drew, the next motion is actually going to be a wrist yaw motion. If you were in the APFR, it would be as if you were coming body in, as we discussed, kind of like a gentle pitch body forward.
Okay, copy.
Starting motion.
Motion.
Copy.
Okay, I've the deck bundled and I'm rested and...
If the next leak inspection just 40 minutes from now continues to show a leak, the team is working toward installing a jumper that would work around the leaking connection. Drew Morgan and Luca Parmitano are headed to the airlock now to get contingency bags in case they do need to install that jumper.
And Drew, we're keeping a close eye on met rates here for you, so this is a good time to just take a pause so we can monitor that consumable.
No changes on my gloves.
Okay, I heard the handles check, Luca, and your gloves and hat are good.
Negative check on the handles yet, I'm not out. My gloves and hat are good, and check your handles.
Copy.
And my handles are down.
All right, thanks, Luca. Thermal cover, and you're on your way.
Work. Thermal cover is closed.
Okay, two boards out to the handrail.
You can see that contingency bag on your screen now, and that bag would be used in the case that there was another leak at the next inspection. This helmet camera view now from Luca Parmitano. He's the one carrying those contingency bags back to the worksite.
Hey, Drew, what are you thinking? Are we going to use the tape off the tool board or the tape off the contingency bags?
Let me see how this looks. We have plenty here. It's just all how it's going to behave having sat out here, but it's intact and it looks like it'll start to peel up all right. But we have 6 additional ones on the lid of the contingency bag.
Okay. Do you have a preference?
Andrew, this is Nana with you. We are going to be flying the as-flown GCA for this position, so I am ready to input that if you are. The first one will be a 15 degrees roll to the right. The clearances you're monitoring, if someone were in the APFR, would be that person and the APFR itself to the row you. So let me know when you have those clearances.
Okay, copy. I have the clearances for motion.
Copy. Starting motion.
Motion.
Copy. Okay, and that roll motion is complete. The next is going to be 30 centimeters to the right.
Okay.
And this would still be general clearance to AMS, and again, this would be to the right as if someone were in the APFR.
Copy.
Views now from Luca Parmitano's helmet camera as the International Space Station and the spacewalkers today fly over the Atlantic Ocean.
Motion.
Copy. Okay, and there's that motion. Next is going to be what would be body up 20 centimeters.
Copy.
Motion.
Motion.
And keep an eye on boot plate to diagonal beam for this.
Copy.
We did motion.
Good clearance.
That completes that motion. For the next motion, it's going to be another 15 degrees, roll to the right.
15 degrees, roll to the right. Okay, let's continue with that.
Okay, and this clearance will be APFR to the row U, starting motion.
Copy. Motion. Clearance.
See.
Motion, good clearance.
Copy. Okay, that completes the roll. The next is going to be a pitch down. It's going to be about 8 degrees. Pitching down as if someone were in the APFR.
Copy.
Starting motion.
Motion. Clearance.
And that's that motion. Final one will be body in 40 centimeters.
Copy.
And again, that would be the APFR or an EV crew member to AMS.
Copy.
Motion.
Motion.
Copy.
3 clearances. Motion. Not motion. Not motion.
Out.
Okay. I'm going to recommend we just end GCA here.
Okay, and that's no problem. We're only about 8 centimeters short of the final in that motion, so I think we're good. And copy GCA complete.
Okay. Yeah. Overall, it's a lot easier to GCA without a Remember in there. So,
I'm on the ELC, so you should get requiescent.
okay, yep, I'm in the APFR and I'm nice and still.
Okay. I'm working my way around.
Okay. We're getting there, gentlemen. So you stay still for a bit there, Drew. Luca will get you in the arm, and then we'll get back on to the next steps. I'll just give you a little sense of the heartbeat here on the ground. You know, the good news story here, we have 7 out of 8 successful. So we have the equipment and the procedures to get AMS in a good final config. So overall, we're heading in the right direction here. And kind of the mentality for you going forward is we're not rushing any of this. We have time to do this right once, and there isn't really enough time in this EVA to get it all done today anyway. So we just take these next steps slow and intentional.
Copy.
Copy.
All right, so I think so I'll take these off of you.
Yeah, I'll expect the bags off.
And we got the large smalls with them.
I only took one large small. They are tethered together.
Luke and Drew, this is Christina for your SA. I still have brakes off, so you are not go to ingress the APFR on the arm. I wanted to make sure the position looks good. Once you verify it's good for ingress, we'll go brakes on.
Copy.
Copy.
And let's think about tethers here, gentlemen.
All right, go ahead, Reed.
Yeah, let's just talk tethers. What do you want to do? You want to do the tether swap now, or do you have another vision for that?
Let us get in a position where we are actively what we're doing. Let me drop a lock also and I'm safe, and then we'll talk about that.
Yep, sounds good.
I'll see a scenario, Weed, where we just leave the tethers as is. And don't leave all reps in place.
Moving to rapid.
I take the integral off of this bag. Go ahead and release your BRT.
Okay, the BRT is released, but I'm still ready to it.
Yep, keep the red. And okay, so I see this integral here is you have 2 to the bag, so there's still the large small between them. Okay. Contingency crew lock bag is the hook 2 in the red bag, and then the small Oreo bag. Hey, Luca, in the meantime, if you could take that right, that large small, and tack it down.
This one here?
Yeah, take that and tack it down a little lower on the ELC, just so it pulls this more straight down.
How about here?
That's great. Okay. Okay, the bags are tethered now inside the red bag. And
The contingency one?
those contingency ones are
Okay,
redded
I'll be
inside.
feeding my BRT red. The way I'm free.
Yep. Okay.
me a good moment to pause.
Okay, I'm at a good moment to pause. And
okay. So, my right hand waist tether is locked black on black. That's going to act for now as my safety tether. Okay.
Stand by one. We just confirm. Are we definitely doing this swap, or is there a scenario where we leave them in place?
So if you go as you are now, we'll have to swap you back into the arm at the end of the EVA. If we swap them now, then we can kind of go with what we're used to.
Okay.
We're not pushing you one way or the other.
A view now from Luca Parmitano's helmet as the International Space Station flies 266 statute miles above the Atlantic Ocean.
Okay, my right hand side waist tether is locked, black on black. Okay, closed. It's safe now.
Okay, I'll put mine over here on the diagonal beam handrail, and it's gate closed, slider lock, black on black, both ends, large hook and small hook.
Drew, you're going to have to pick something on the ELC, I think. And Luca, what are you tethered to, Luca?
I'm on the ELC. I'm tethered to the ELC, in a dog bound that says DRT.
Right, so I got to be on structure, so that means I'm probably going to have to be out of the APFR. It's not ideal.
Actually, only one of us has to be there, because I can give you my safety tether and then you'll be safe. And then you can get off and give me your safety tether.
Does my waist tether to the APFR count?
All right, Luca, I like what you're saying. The only caveat is you need to be on a numbered handrail on the ELC, and we haven't heard that yet.
On a numbered handrail.
So you could use that, the short one, 8601.
Yeah, okay, I'll do that. 8601 is going to be my numbered handrail.
Okay, good words, Luca.
601.
All right, and then double check.
Locked, black on black, the gate closed.
Okay, both ends are locked, confirm.
Confirmed.
Okay, so you can give Drew your safety tether. Make sure we're redded to it in some fashion so we don't lose it.
Okay, I'm going to red you it.
And my waist tether, it needs to be to a numbered handrail as well.
Negative. We're happy with Luca's plan where he's given you his first, and then you're going to be safe, and then we move from there.
Yep. Okay, copy.
Thank you. Here comes the structural safety tether. It's now locked black on black on you.
Okay.
And I'm going to release my tether from it. I'm going to put my tether on the arm.
Yep. Right on there.
Okay. Okay, now I have a red on your safety, on the arm safety tether.
Okay, here's the arm safety tether.
Okay, and I need to find my viewing extender.
You come up just a little bit, I'll grab it. Okay. This is the arm one. Okay. Okay, it's on your left D-ring extender. The red hook from the arm, gate closed, slider lock, black on black.
Okay, you can't release the red.
Red from the reel, released. Okay, you're safe on the arm.
Copy, safe on the arm.
Let me put it on the other side of the ingress aid. Okay. Now I'm going to have you send your feet down that way. I'll turn you towards the ingress aid.
Okay, I'm going to grab my waist tether now. I'm safe.
Yeah, we're with you. Good job, gentlemen. All right. Just a reminder, only one of you moving at a time on the EOC. Next thing for you, Luca, is getting in the arm. And we'd like you to use the ingress aid.
Copy. Drew, I put the adjustable around your safety pattern, so now you also have a fairly correct. Okay. And now I have to find the arm.
Okay, it's continue that direction. Come up my ingress aid a little bit, and then start to roll to your left. And then there's your ingress aid. Okay, and then let's make sure that go ahead and throw your local down on the ingress aid when you want.
And Luca, Christina here. I'm ready to accept any GCA. If you like the position, I'll go ahead and put brakes on.
Right, I'm on there. Right now I'm currently holding, and I would say that you can go ahead and put the brakes on.
Copy. Brakes are on. You go for ingress.
Go for ingress.
Okay, and doing a little bit of yaw. You're on the yaw pedal there. I think you ought to shimmy down there and fix the yaw. Okay. One more to the. Would you just step on it and then?
Let me do the ingress through, and then I'll deal with it.
Drew, can you cycle your WVS for me?
Roger.
Okay.
Okay, your yaw looks correct.
Yeah, I mean, I'm ingress, I'm on the arm. Keep it locked. Doing good. I'm in a good position.
Okay, so Luca, you're ready to do another leak check for us on number 5. Confirm.
I am in position to do it.
Okay, you can go ahead and prepare the MLI, and just let me double check before we move the VLI. Drew, we need the trash bag and the PGT out of the MLI bag.
Copy.
Okay. I have the VLI available for check.
Okay, Luca, you can go ahead and do the leak check. Open the VLI without touching the cap.
And TMs here in Mission Control Houston are reporting that that leak check is going to come a little early, actually about 17 minutes early. Standing by now for that leak check to begin.
Very carefully.
No red.
No red.
No red. No. No leak.
Okay, close it quick.
Again, if this inspection shows a leak for the third time, the team is working toward installing a jumper that would work around the leaking connection.
Okay, let us all take a breath down here, and I'll get back to you. You can close up that MLI, Luca, while you're waiting.
Copy, it worked.
And no leak has been detected. Crews in Mission Control Houston are reporting that all fittings are good and we can proceed with the spacewalk today.
It's closed, and it's covering the time sheet.
Copy, Luca. I'm checking. Stand by.
Copy, standing by.
Just to recap the events that have happened over the last hour, Drew Morgan completed the leak inspections at the Nader Worksite and found no leaks on his end. Luca Parmitano then found one leak out of 8 tubes, and that was on the first tube that he checked. He was able to tighten the connection on the leaking tube, after which it was re-inspected. He also completed the remaining VSB, or vertical support beam tube inspections, and found no additional leaks. When Parmitano went to re-inspect the tube, it again showed an indication of a leak, so he tightened that connection one more time, and on the third check just now, the tube showed no signs of a leak. The crew will now proceed down the timeline as normal with installing the multi-layer tents, which was next on the task list.
Okay, good news. So we're happy with all that. We're back on the original timeline. So question for you, are you happy staying in the arm, Luca, or do you guys want to undo what we just did and just swap roles?
I mean, that was quick enough for us to do. If we don't feel like it's going to have this huge impact on accomplishing the task today, we had definitely rehearsed with the roles reversed.
And I agree 100% with Drew's assessment.
Okay, we're going to go with your instincts on this one. So let me just double check. I think we're into the tether swap here, but let me double check that.
Drew, why don't you grab the animates in the meantime?
The 7/8 off of you?
No, the one from the board.
You'll keep one too?
Actually, you're right. Yeah, I don't need it.
I have a red on it. All right. Yep. And if you agree, we put the tool board away, or we need to keep this staged?
We put it away, but I'm inclined to do the cleanup stuff after we get the arm moving to the next site. Because the next thing we're doing here is opening the accumulator valve, and I'm assuming we're going to do that from the zenith worksite or arm position. Is that what you're thinking?
Yes, that was the plan.
Yep. Okay.
And Luca, could you do the accumulator valve from where you are or not?
Good. Yeah, I definitely can open it, yes.
Okay, Drew, you want to grab the PGT then? And we're talking about putting the MLI tent on from this position.
Copy. If we're going to go the direction of starting to initiate the MLI tent from this position, then definitely for now, we'll stay as we are, Luca in the arm and me where I am.
Stand by, Drew.
You have a ret on the PGT. In the meantime, we'll put this in motion here. Yeah, Drew, it's better if let's get that feel of that.
Okay, Luca, while we're working through when we're going to move the arm, we're going to do the accumulator valve. So your PGT settings are alpha 4, counter 1.
Okay, copy alpha 4, counter 1.
Okay, Luca, this is 1 to 1 1/4 turns only.
Okay, vacuum motor, do the LED test. And one more time, I have alpha.
Alpha 4, counter 1.
Alpha 4, counter 1. Check. Alpha 4, counter 1.
Okay, 1 to 1 1/4 turns only.
Verify you can read accumulator.
I see accumulator valve, which is the lower one. Start in motion.
And just confirm 1 to 1.
Luca Parmitano is now opening the accumulator valve, which will pressurize the new system, ensuring all the cooling lines are holding pressure as expected for the resumption of the activation of the system.
Stop, or do I
No, you do not. That's it. You're done.
So one turn.
Affirm. You are complete.
Correct, 1 turn.
Okay, 1 turn complete.
Do you see a torque value on there, Luca?
I see 2.4.
Copy. Okay. I need one assessment from you, Luca, to help us with our decision on the arm. So originally we were going to install the MLI tent with the arm in this location. Before we take it to the zenith location, how confident are you that you want to go with the plan that we were working on yesterday, which is that Drew would be up top in the zenith and you would do the rest of the MLI tent free float?
I think this is a call for Drew, Jeremy. I'm confident that I can continue with the original plan. From where I was, I could do all the positions. This is going to be easier in a way, but
yeah, I'd say we don't burn any bridges. We're in position. Let's start the MLI tent according to the original plan, where Luca was in, where there was we came to the VSP site to start the MLI. So I'd say we start the MLI with us in our current positions from right here.
Okay. That makes flight very happy. That's the preferred option. So let's start working the MLI tent. Drew, you know where it is.
It's in my hands. Okay, Luke, here's the tether. Take that off.
Don't we remove the...
You got to take the Velcro saver.
We have to take the Velcro saver first.
Yep.
So, you want me to take these anyway?
No, I'll hang on to that.
Yeah. Okay, so first, the next step is actually for you, Luca, going back into the Worksite. Let's just do one last check of those AAFs. So checking the MLI, no exposed tubes or contact between tubes. We'll grab a couple closeout photos.
Okay, the only thing that is off nominal is that number 7 and number 3 are not over the scrunchies, deep in the kelp. Do you want me to go in and reach down and try to put them over the scrunchies?
Is there any exposed metal, Luca?
I do not see any exposed metal. But I can also get there and work it down. And just let's do it.
The 7/8 if you need to put a little extra reach on it.
Okay, 7 is covered over the scrunch.
Yeah, I agree.
And 3 is covered over the scrunch. And I don't see. Do you have the 7/8?
Yep. That's just for some extra.
Now 3 hours into the spacewalk today, recapping some milestones, Drew Morgan completed the leak inspections at the Nader worksite and found no leaks. Luca Parmitano found 1 leak out of 8 tubes on the first tube that he checked and was able to tighten the connection on the leaking tube. And after it was re-inspected, the tube failed again and had another leak. On the third reinspection, the tube had no indication of a leak, and the duo is now moving down the timeline as originally planned. Luca Parmitano just opened up the accumulator valve, which will pressurize the new system, ensuring all the cooling lines are holding pressure as expected for the resumption of the activation of the system. They'll now take closeout photos at the work site before they move on to the next task.
You make the call.
Well, I want your concurrence, but I think, this will fall into our old roles.
I think that from now on, we have enough confidence in the rehearsals that we both know what to do.
Yeah. So.
We're back with you, gentlemen.
Yeah,
we'll say.
We were just taking some closeout photos, and Luke and I discussed briefly, but from this point forward, we're not going to have any trouble installing the MLI or starting the MLI from this position, and at this point it just makes sense for us to fall back into our old roles, and Lucas stays on the arm, and I stay where I am, and back in business with the bags again.
You are the bag master, so we all feel good about that.
All right. Given that, I'm going to give this back to you to it.
Yeah, hold on.
Okay, right back to me.
Okay. We need the scrunchy for the.
So you have got the adjustable ready to take the Velcro savers.
Yeah.
And I see the 2 tabs. Let's wait until make sure that we're all. Are we ready for that?
We are. Your go for Velcro savers. Save the Velcro.
Okay. So. Right. So do you see the other one out past the handrail?
I have to get out of the arm. Yeah.
Yeah. I think you're going to have to. Got 2 hooks there. Put 1 hook to each. I think the whole thing will be best done with you out of the arm.
Use the ingress aid, Luca, to get out of the arm, please. So, Drew, you made sure all the hardware is off
yeah,
AMS?
Yeah, that handrail on the... I'm looking it over right now. The diagonal beam handrail has nothing on it. The Nader vacuum case handrail has nothing on it, nothing, none of our hardware. The Zenith vacuum case handrail has nothing on it. So we're clean.
Okay. Where's the PGT?
PGT is back in the medium ORU bag.
Okay, copy. So, Luca, as you go around on these Velcro savers, this is where you might be able to get that almost impossible flap, or barely possible flap that we were talking about yesterday.
Copy. The almost impossible flap right there in the corner.
Luca, and then I would just maybe go around the row I'm reeling in the Velcro savers as you go. And you're almost free with that right one. You just gotta not even, there you go, free. And then the left one. And then as you free that left one, that flap should be kind of liberated, or at least unfolded. Liberated, but unfolded.
Okay. Okay. Breathe out.
Okay,
You can reel it in.
reeling it in. Is it all free?
Yeah, and I'm opening the flap.
I see it, yeah. Nice. The folds open into, it's like folded in half. You know?
Yeah, it's still folded enough.
You have to keep pushing a little more. There you go. Yep, that's exactly what they wanted it to look like. Right, the impossible flap, we wanted it to extend all the way over until it was resting on the IPA. That's what we understood.
Yeah.
And it looks like it's there.
Yeah, we saw in the WVS. It looked good to me too. All right, so you've stowed the Velcro savers in the MLI bag, and now it's time for the tent.
Okay. I have the tent in my hand.
Okay, and Luca, while you're up there, we got some cables on the radiator there. We want to move those. Looks like you're doing it.
I just did that.
Yep, we're thinking alike.
So the cables are all tucked. Okay.
Andrew, now I'm waiting for Alpha 1, Alpha 2, I think.
Okay, so which one's at your right hand, Alpha 2 or Alpha 1?
Alpha 2 is on my right hand.
Right hand, okay. So here's the tether point, and then remind us which was the preferred handrail then for that, which stanchion?
It doesn't really matter.
It goes on the loop.
No, it doesn't, I don't think.
No, it doesn't go in the loop. It goes on the handrail. You either put it on the connector side, the far right side, right by the Alpha 2, or around the corner on the, I guess that'd be the vacuum case side.
Yep, okay, that's where it is. It is on the VSB side. On a stanchion on the VSB side. Go ahead and you can release that, Red.
Yeah, okay. Sorry, I said vacuum case.
It's to the UTPS.
Okay, that's good. I see you're removing the wire ties.
Okay, we're ready to that one. I'm going to take this one too, Luke, or you want to wait until you get out the wire?
No, I want to take it.
There's a rat on it.
Okay, the note here, Luca, is to make sure you push firmly on that Velcro.
Okay, Alpha 1, Alpha 2 is connected.
Okay, and then you just follow around onto the row U side. There's a strip of Velcro there is the next one. And then after that, we come back to kind of where you started with the hook, and we go down there with letter B. All right, we're handing over in 20 seconds here. I'll be back in a minute. I'll take a glove and a hap check from both of you at the next convenient point. Drew, what do you think's best for you? Maybe start a red bag inventory? I'll be back in 30 seconds.
We could copy.
We're in the middle of a handover period between satellites right now, but we should be regaining video communications with the crew soon. Again, on the third inspection, leak inspection earlier, no leaks were shown. Therefore, the jumper installation was not required, and Morgan and Parmitano were able to continue moving down the timeline as originally planned.
Yeah, I'll be able to assist Luke on a couple of the lettered parts of the tent, but in the meantime, we could do a bag inventory, red bag, if you're ready.
Okay, I'm ready for the red bag. Luca, you break in if you need any help with the tent. But do call out the hooks for us because we're keeping track. We're keeping score down here.
I will do. Okay, I've got red bag, and on the exterior there's two large small adjustables, and then a large small ret on the exterior. Then on the hooks on the inside, we have a contingency bag, and these just went on whatever hook I could get them on. Contingency crew lock bag to hook 2, and the contingency ORU bag to hook 4. On hook 7, the inspection mirror, and then on hook 6, I have the tool board. Never took anything off the tool board, and I can go tool by
The view now from Drew Morgan's helmet camera as he does a tool check with the crews here in Mission Control Houston.
7/8 combination wrench, rough cutter, tube straightener, tube puller, got in a adjustable and a small ret.
Meanwhile, Luca Parmitano has started the work to install an MLI, or multi-layer insulation, exposing the two fittings.
Yeah, that's it. You got it all. Inside the lid of the red bag is a small ret, and that bag will be complete.
Okay, and inside the lid, that small there, I can see it. Okay, how's that side, the rodeo side look?
Now I need to go back to the other side, because now I'm getting to the part where I need to lock on the different handles, the rails that we installed.
Here, Drew, here's a question for you. Those two contingency bags, did we ever open them?
Negative.
All right, bonus. That's perfect. Good news. Okay, and then Luca's still got a wrench on him, right?
Okay, has the 7/8 wrench on him.
Okay. All right, we've got a good red bag inventory.
Again, this helmet camera from Drew Morgan, who just completed an inventory check with the crews here in Mission Control Houston. Morgan confirmed that neither of the contingency bags needed to be used during this spacewalk.
All right, and we'll need a glove and hap check from you guys.
Hey, Luca. Sorry, Drew, go ahead.
Yeah, my hap is dry, and my gloves are got a little, looks like a little fragment of Kapton tape stuck to one finger, but otherwise they're intact. It is Kapton tape from the tool board, but good.
Copy.
Everything else looks good. Over to you, Luke.
Copy, Drew. The gloves are still in baseline conditions. They were happy to dry. Okay.
All right, copy. Luca, where are we at in the hooks?
I am working on Bravo side now. I'm trying to figure out if I can do it from here. It's actually probably easy if I get off the arm again and go high.
Okay, copy that.
You think, Drew?
For the
I'm trying to see
the Venus vacuum case.
Yeah. I need to get over here.
Yeah, no problem getting out of the arm, Luca. Use the ingress aid, please, and then only one of you moving at a time.
Copy.
Okay, the three sides of the initial MLI are installed, and I'm tapping as hard as I can.
Luca, what will help, I think, is if you start that one that goes over the zenith, over the hole that goes over to the zenith, and then the one over here that goes over the nadir handrail, that'll give you something to pull that taut and get that Velcro mated, I think.
I'm looking for the hole.
There's the B hole.
Oh, I see it.
Okay.
Going over easily. Okay. I have the B out of the hole. So you have the tether point going through there? Okay.
All right, we see Bravo, Luca. And the hole for Charlie goes over the nadir handrail. There's,
and there's
two Charlie labels.
Over there.
One where the hook comes out and one where the hole is.
All right.
Okay, we see a good Charlie. Delta is the clip over the nadir handrail.
Get that clip a push. Look at the, there's another one right here. Loop at Delta, are you able to see that one? Okay, see Golf. Golf is a hole. Yes, we need to get the clip on D. Delta. And then E gets pushed over that, and it can get a little steeper in. You can feel it. Okay. And then there's for this one, we release the hook, and we put the hook through. Do you have access to the hook? It's underneath the MLI, so I gotta. That's okay, I can get to it. And then she can hold it. I got it. There you go. And then rehook it on that loop. Right. From the nadir MLI, we have taken that hook and it's back through its original loop, trapping spot Gulf.
Okay, that all tracks good. We saw it happen. So the next thing is there's a stiffener on the Gulf side, I guess along the IPA, and we want to check the gap by the IPA there and push that stiffener in.
It's on the wrong shape, unfortunately, right now.
What?
The stiffener is the wrong shape. It's bent, a little bit bent. It goes over the IPA and inside, correct?
It gets tucked in behind, in behind the IPA. Remember the sharp edges back there.
Okay, do you have a view of that?
No, not really, Luca. It's just too dark for us to make anything out. But you see any gaps, or is it pretty much snug against the IPA? Oh, that looks pretty good. So it looks good to us. Does it look good to you, Luca?
Good, yeah.
Okay, and then just give us a peek over on the vacuum case side and make sure there's no gaps over there. That's the line from Bravo to Charlie.
The line, that's up here, and we'll have a better look at that when you come to the Zenith side.
Yeah, I think that it's easier if I do that from the Zenith side.
Okay.
I agree with Drew.
That's fine. And so then we're going to go to the Zenith side, and then we'll cover up the handrails on the box, the faces of the box. Confirm.
Okay, here's the Bravo Charlie line.
Yeah, but they want to see it all the way up there where we can't quite see you in the vacuum.
All right, I'm going to hold on to the rest of the handrail. Okay, there you go.
Yeah, the lighting's just a little off from us, but we're starting to see it there. Does it look good to you, Luca?
I mean, the vacuum case is red, so of course we're not coloring red.
Right. But it's up against the ribs, right? Yep. Okay.
It is up against the ribs.
Okay. And a couple things we just want to verify. The Delta clip went on. You guys had a good snap on that one?
We have a good clip, Delta.
Okay. And the Gulf, you pushed the end of the handrail into Gulf? I guess it's not the handrail, but it's like the slider. That's the pocket.
That pocket is Echo.
Oh, sorry. Yep. That's what I was talking about, but I think they wanted to hear Gulf in the end. We got the hook.
Gulf is on the handrail through the hole with a hook around it.
With the hook from the Nader blanket.
Yep. Okay. That's all of them.
And FYI, Jeremy, I've also strapping the handle, the covers for the UTTPS handles, because otherwise, once they move, it will be really hard to reach.
Okay.
So they are now halfway, so that I can reach them once I go to Zenith.
All right. Sounds good. We see them. So.
Drew, what you think? What you're thinking?
Yeah, I'm gonna take some pictures from here, but I think that everything that we're gonna be able to finish out is gonna have to come from the Zenith side.
I agree.
All right. I think we're ready to move the arm. You guys ready for it?
Let me get it, and then we'll give you a go.
Okay, big picture for you guys. They're working a robotics camera issue inside, so there might be a small wait here. We are at 3.5 hours, and we are on the timeline for the EVA right now.
Okay, I'm in the arm, so I'm ready for motion whenever the arm is ready.
Stand by while we work the camera view.
Remind.
Drew, is there any more cleanup we can do on your side?
I don't think we can. We're at the point that we can do.
And the work is now complete to install the multi-layer insulation.
Luca's got the 7/8 with him, and he's probably going to need it.
Okay, we concur, Drew.
The crew will now move to a mud flap install and a shower cap removal.
The timeline, as in the Plan A timeline, going to all 3 work sites, is that correct?
Yep, that's it.
The shower cap the crew will now move to remove was a cover that was temporarily placed over the radiator during the 3rd EVA.
Jeremy, while I have some time, Delta and Foxtrot are the only 2 cleats, is that correct?
Affirmative, Luca. And it does seem like we have a little bit more robo wait time here, so feel free to take some more close-out photos. People appreciate them.
Luke, I'm going to still plan on giving you the beam or U-bag at departure.
Okay.
And the red bag will not be as small as we thought it was going to be, but will be down. We won't have the crew lock bag and the ORU bag are inside the red bag now.
Okay, that takes care of a little bit.
Okay, Drew and Luca, back with you, and we are ready to begin our motion. The first will be taking out the GCA that we had put in originally. If you guys are ready.
E3's ready.
All right, and EV1, I'm ready to assist.
Okay, copy. The first motion is going to be a body out motion. It'll be approximately 35 centimeters.
Okay, copy.
And Drew, the clearance you'll be monitoring is Luca to ELC2.
Copy, Luca to ELC2.
And starting motion.
Copy. Good motion.
Copy.
Okay.
And that's the body out motion complete. Next will be a pitch up, approximately 8 degrees.
Copy.
Drew, your clearance is boot plate to AMS.
Copy.
Starting motion.
Okay, it's a good motion.
And that completes the pitch motion. The next is going to be a left roll, approximately 15 degrees.
Copy.
And Drew, you'll have eyes on the boot plate again. Starting motion.
Copy. Good motion.
Copy. Okay, and that was the first of your rolls. The next is going to be body down.
Copy.
This will be about 30 centimeters. Starting motion.
Copy. Motion.
Copy. And that's your body motion. Next is going to be to your left, approximately 30 centimeters. And you'll be watching Luca's left shoulder to the row U.
Okay, copy. And looking for this, maybe a little bit of lean back.
Starting motion. And that completes that. For the final maneuver, it will be a more left roll, another 15 degrees.
Okay. Luca, just check your ingress data. Look, it's inside tight, but and this will require a little bit of lean back, just a little bit, so I can see the clearance. All right. We're good for motion on you, Nana.
Copy. Starting motion.
Now 3 hours and 37 minutes into the spacewalk today, recapping some milestones that the crew has run throughout the day. Drew Morgan completed the leak inspections at the Nader worksite and found no leaks. Luca Parmitano then found 1 leak out of 8 tubes. On the first tube he checked and was able to tighten the connection on the leaking tube. Parmitano also completed the remaining VSB, or vertical support beam tube inspections, and found no additional leaks. Parmitano re-inspected the tube, again saw an indication of a leak, and tightened the connection once again. On the third inspection, no leaks were shown. Therefore, the jumper installation was not required, and Morgan and Parmitano were able to continue moving down the timeline as originally planned. They worked together most recently to install an MLI, or multi-layer insulation tent, underneath the AMS pump system to close out the formal debris shield worksite. And the crew will now install a mud flap between the new pump and vertical support beam, or VSB, then remove a shower cap to expose the new radiator system.
And Luca, our next motion is going to be a gentle pitch up. It'll be mostly body back for you. It'll be about that 15 degrees.
Copy.
Starting motion.
Good motion.
Please.
Lean forward a little bit. Forward and to your left.
How about that?
That's good.
Okay, that's that motion. Stand by with us the next. Okay, Drew and Luca, we're ready for the next manual maneuver. This is going to be about a meter station aft. It'll be mostly in the direction of your feet, Luca.
Copy.
Starting motion.
Yep, left arm. That's the one, yep. Lean left. Looking good. Motion and clear clearance.
Copy. Okay, and that's that maneuver. Stand by while I set the next. Luca, your next maneuver is going to be a Joe cast, 1.5 minutes invert to VSP intermediate.
Copy.
Motion.
Now 3 hours and 43 minutes into the fourth and final planned spacewalk to repair the alpha magnetic spectrometer. The AMS was launched on Space Shuttle Endeavour to the station 8.5 years ago to study dark matter and invisible matter that can't be directly detected. The goal of the alpha magnetic spectrometer has been for scientists to track down sources to help understand dark matter and the origins of the universe. And over the last 8.5 years, AMS has collected data on over 140 billion cosmic ray events. But as with many items that are exposed to the harsh environment of space, the alpha magnetic spectrometer needed to be upgraded to continue collecting data. AMS began showing signs of age in 2014 when one of the cooling pumps stopped working and another was found to have degraded. In March of 2017, researchers switched to the last fully functional pump to keep the science alive. The AMS team realized they would need to take action to keep the science instrument going and enable the AMS to function through the lifetime of the International Space Station, leading to the series of 4 spacewalks. The spacewalks are considered the most complex of their kind since the Hubble Space Telescope servicing missions. The AMS originally was designed for a 3-year mission and, unlike Hubble, was not designed to be serviced once in space.
Next is a Joe cast, 2 minutes in course to AMS Common.
The work to prepare for the spacewalk, which began about 4 years ago, involved making, testing, and launching more than 20 new tools to the space station, many specialized for specific steps of the spacewalk, such as removing the debris shield, which was done in the first spacewalk, and tools to splice cooling lines, which was performed in the second spacewalk. These tools have gone through years of iterations and tests here on Earth by scientists, engineers, and astronauts. The 2 spacewalkers today have both worked with these tools and had 7 training sessions in the Neutral Buoyancy Laboratory dedicated to repair training for these AMS spacewalks.
And there's position hold, setting up the next.
Copy.
Your next move is a 3.5-minute JOCAS to the zenith back off invern.
Did you copy?
Starting motion.
Copy.
And EV1, EV2, while we're driving, I'll go ahead and give you the clearances you'll be looking for during our next manual maneuver after this is over. Luca, for you, we'll be verifying your ingress aid is in and clear, and for Drew, you'll be checking Luca's clearance to structure and AMS.
Copy. And EV2, copy.
Copy.
Very well, we have a moment here, gentlemen. So we're 3 hours and 50 minutes in, and consumables have improved a little bit. We're METOX on EV1, 7 hours, 12 minutes.
Copy that, Wade. You copy.
Position hold, setting up the next.
You too.
Okay, Luca and Drew, your next move for Luca is going to be about 2 meters, station nadir, clearances as described.
Copy. EV2, copy.
Starting motion.
Motion to clearance.
Copy. 1 meter to go.
Copy. Copy. Motion.
Motion stopped.
You got everything. I think that this is. I don't want to get too much over it. So, and Christina, I'm gonna call GCA complete for now. No breaks.
Copy all. GCA complete.
All right, Luca. I see you working those covers.
I'm repositioning bags, getting ready for the plan to hand off the medium or ORU back to Luca.
Okay. Those are good words. The next thing you can expect is the shower cup cap coming back to you in a little bit.
Copy.
I have, looks like one bottom part of the handle on the vacuum gate side is not covered.
Luca, can you try and give us a WVS of what you're talking about? We don't see it.
Yeah. How about that?
Yeah, there it is. Okay, we're talking about it.
Me, Luca.
Yeah, I'm trying to push it down as much as I can.
I see what you're saying. It doesn't quite make it to that other stanchion.
Okay, Luca, what you're doing is what we the best we can expect, and we're okay with the end result there. So a little bit of the handrails exposed, that's fine.
Actually, I think I managed to cover it all.
Yeah, it looks pretty good.
Just scrunching down.
Okay, good work, Luca.
Just to give you a real quick glove update, my left thumb and right thumb panels, outer layer of RTV, are elevating kind of in the way that I have seen in the past on a previous set of gloves. There is intact RTV underneath, and there's a little bit of splitting in the outer layer of RTV on the right index finger, first panel in, similar to what I've seen before, and I've got good RTV visible underneath, so this was what expected.
All right. Copy, Drew.
Hey, Christina. I'm going to need some little GCA here. Christina, can you hear me?
And we're with you on one. Can you say your last, please?
Yes, I'm going to need a little bit of GCA.
Okay, I'm ready. What type?
I need straight to my right, about, I would say, 30 centimeters.
30 centimeters to your right. Stand by while we set it up. And look up for 30 centimeters to the right. You're going to be watching your shoulder to the row U.
Copy. I'm clear. You're good to go.
Copy. In work. Starting motion. There's your 30 to the right.
Continue through.
Copy. And look about how much more are you thinking?
About 10 centimeters.
Starting motion. There's about 10 more.
Okay, I'm going to try and work it this way, but I might need more. Is that going to be a problem?
And Luca, it's not a problem for us. If your right shoulder is still clear, just let us know what you need.
So I'm above the Ryu. The shoulder is not going to be an issue at all. Yep, and I can confirm it's well clear.
Okay, that's good to know. Yep, that makes sense since we didn't finish that other motion. So I'm ready, standing by for your inputs.
Yeah, continue right for another 30 centimeters.
Right, station right, another 30.
Shoulder right.
Starting motion. Okay, copy that. We're else you need.
Thank you.
Now approaching 4 hours into the spacewalk today, the crew, one of the most recent milestones was when the crew worked together to install an MLI, or multi-layer insulation tent, underneath the AMS pump system to close out the former debris shield worksite. And they just finished installing a mud flap between the new pump and vertical support beam, or VSB, and they're now wrapping up the removal of a shower cap to expose the new radiator system.
In.
Copy 20 to the right for now. Starting motion.
Good motion.
Copy, and there's your 20 to the right.
Continue 10 more.
Starting motion.
The International Space Station is currently flying 270 statute miles above the Pacific Ocean.
Copy, copy.
Thank you so much.
So it looks like you're doing it, Luca, but while we're in there and after the mud flap, we're going to want to make sure that all the power cables are covered.
So yeah, that's going to be a bit of an issue. Power cables are pretty stiff and locked in position, and I don't have a lot of play. So it's going to be hard to tuck them in. I'm going to do my best.
Yeah.
I'm going to get off. I'm going to have to get off the arm to get down there. And I'm going to have to use the ROU as if not. Okay.
So Luca, let me just clarify one thing for you, Luca. It's just the old cables, that are AMS cables, that we're really concerned about. The ones that we brought out and installed, we're expecting them to be exposed. It's just the ones that were previously existing that need to be covered by the mud flap and the MLI.
If I'm talking about this flap here, I won't be able to. It looks like it's going to be really hard to Velcro over the new cables. So I'm gonna have Christina, I'm gonna have you.
Can I ask you a question first, Luca? Do you since the ROU is there and holding that flap in place, maybe we don't need the Velcro. What are your thoughts?
I don't like it very much because, it's probably not, the light is probably not going anywhere. That handle is not going to be very well covered, so the concern, I think I have a plan. Let me try this.
Yeah, do your plan and we'll talk about it down here, Luca.
Okay, Christina, can you drive me 20 body right and then probably 30, 40 centimeters body in?
Copy 20 to the right and then 30 body in. I'll do the right motion first. Starting motion.
Motion.
Okay, there's 20 to the right is in, and would you still like the 30 body in?
Yes, please. And I'm leaning back, so I clear the ROU.
Copy. Starting motion.
Motion.
Copy. And there's your 30 body in.
Okay. I'll try to make it work this way.
All right, Luca, and one more new piece of information for you is what we really want to do is cover the handrail. If that means we bring the wires outside the MLI flap to make that happen, that's okay as well.
Copy all. Luca, your helmet's making contact with that ROU? Yeah. Okay, but I'm done. I'm done here. Okay. Success, because I got no view of it. Okay, I think I got success here. Actually, without thinking, I think I managed to strap it all down. It looks solid.
Looks good to us, Luca. We like it.
And all cables are covered, completely covered by the old MLI. Completely covered. And then make sure that the mud flap goes over there.
Yep. Okay. That's great.
And then we rotate back to my original position.
Drew, for your planning purposes, even though we called out the medium ORU bag going back with Luca, he can take the red bag back if we don't have time to inventory the medium ORU bag before that, or if that's your preference.
Yeah, no, that would work well. That might even allow me to, let's say, if there's a break point where I could throw the APFR back on the seated cart as soon as Luke is clear. Prior to him leaving, I'll give him one of the bags, but yeah, I think that the red bag would be a good candidate, and that'll allow me to inventory and stuff that one closed.
Okay.
Luca flips against the ROU. Luca, the helmet is making with that little clover leaf thing there in contact. Yeah, leaning back.
Yeah, okay. So next, I think it's going to be hot flap and shower cap. Is that correct?
That's right, Luca.
Right. Christina, for this, I'm going to go take those the motion body out, body in that we put in, get out, and we're going to go back to the center of the position. So I would say 20 out, 20 body out, and then body left.
Copy all, and if you'd like all of that body motion, it'll be 30 out. Does that sound good?
Sounds good.
And starting motion.
Motion.
Copy, and that was 30 out, so you're back to that position. And copy, you'd like body left now. Would you like the total that you had originally put in taken out?
Give me 60 centimeters.
Say again the amount?
60.
60, starting motion.
Nana, give me...
And that's your 60.
Yep, that's a great position for left and right. Now we're going to have to do a little bit of maneuvering. I'm going to need body out, another 30 centimeters, body, I guess, yeah, body out.
Copy, 30 centimeters body out, and Drew will take your clearance for between Luca to the ELC2 and the boot plate to the Missy.
Yes, I got that. Stand by, so, Missy, okay, copy.
Motion, 30 centimeters body out.
Motion to clearance.
Luca, there's your 30.
Yeah, I'm trying to see how I'm going to do this. Okay, Christina, now give me towards my feet, the body down. Body down, I would say 30 body down.
Copy, 30 body down, and just check your ingress state is clear.
Ingress state is tucked in.
I can see that it's tucked in.
Starting motion.
Motion.
And there's your 30.
Okay, give me another, let's see. Okay, that's good. Now I'm going to squat, and now, Christina, I want you to drive me to the body forward, and I'm probably going to need about 60 to 70 centimeters. Now take care of my head clearance. Can you, okay, you don't even see me at all, do you?
Yeah, I got a clear view of you. I'm right at, I'm straight above you.
Okay.
So I've got a good view. Understand the dilemma of that, this particular, because you're kind of in the
way there.
Kind of in the wrong body orientation. If you continue that way, I will lose sight of you.
Hey, I don't have a lot of options.
About,
the orientation is not favorable.
So, and if you pitched up, feet came closer to the radiator.
Pitch up this way.
Yeah, like that, and then we brought you down toward your feet. What do you think?
Okay, so if I stay in this position, I'm gonna need a meter and a half toward body in.
Yeah, and the only thing is that for robotics, that pitch motion I can see is probably, we can check with Christina, but it doesn't look like it's going to be favorable, but maybe we could get a little bit out of it.
Christina, can you give me a meter and a half body in?
Copy, you'd like 1 meter and a half body in.
That's correct. Good clearance is all over.
Can I break in here and ask you guys a question for a sec? Drew, do you think you could free float up there with Luca up there and kind of use him as a handrail, use Luke as a handrail, and just get some of this stuff done?
Take a look. You definitely don't have any handholds left on MS.
Yeah, you'd have to translate on the handrails of AMS underneath the MLI, knowing where they are, but you'd have to have a loco down somewhere.
Checking.
And then up to the row U.
Are we contacting each other yet? No.
I can lean forward and we have contact.
Okay.
I'm right here.
Just make sure you got a loco of Drew.
Where do you need Drew to be?
It was just a question whether he could help you with the mud flap instead of having to do all that pitching, and sounded like you didn't have a good body position. So it was just a thought, if it's helpful.
Drew, you're kicking. What's up with your feet and your plates? And I have contact with a tent.
Okay.
Like right now.
Okay, which direction?
Jeremy, I suggest not doing that.
Yeah. Okay. Sounds good.
I don't think. So, Jeremy, my plan is actually very simple. All I'm doing is pitching my own body with my legs and going straight down so that I get closer to the lid of the mud flap.
I'm with you, Luca. Just a thought, if it was helpful. It doesn't sound like it is.
If you can stay closer, that would be good for the shower cap. Jeremy, let me know when you guys are ready for some motion and...
We're ready, Luca. Here we go.
Okay. Christina, I'll start with 1 meter and 20 centimeters, the body in, and I'll take care of the clearances, and Drew will take care of the other one.
Copy, 1 meter, 20 centimeters, body in. Starting motion.
motion.
Copy. Later to go.
Okay, 3, 2, 1, stop motion.
Motion stop.
Okay, so you see the radiator then right at your feet?
Yeah, that one. That's why I stopped the motion.
Yeah.
And I'm opening the mud flap.
So I moved on ELC to the side, and even where the spot that Luca departed from, I wouldn't have been able to do that.
Yeah, understood.
Okay, do I try to tuck this in before I remove the mud flap or after?
You tuck the mud flap in now, and then we remove the shower cap.
Okay. Jeremy, just so you guys know, I'm doing this completely in the blind. I don't know what I'm pushing.
Okay, so just don't force anything, Luca. We got power cables back there.
All right.
So, Luca, the key here is just making sure that mud flap's not going to come back and cover the radiator in the future.
So, Jeremy, remind me, can I touch any of these straps, or these are all no touch?
I didn't understand what you asked.
Again?
You're talking about the radiator struts, Luca, is that it?
Yeah, the three struts that hold the radiator, those are don't translate on them, right?
Yeah, that's right. Don't translate on them. There's one that you can put a tiny bit of like stabilizing force into if you need to.
Which one was that? The middle one?
Hang on, Luca. I'm just getting clarification. We think what you're doing there, though, is probably going to suffice.
And this is a helmet camera view from Luca Parmitano's helmet camera.
How does that look?
Right now he's trying to put as many power cables underneath this thermal protection, which is the mud flap. He's trying to figure out the best way to do it without putting any excessive loads on those power cables.
Yeah, I can see that you've got it stuck mostly out of sight. I just had to get in a little higher point.
Okay.
Yeah, Drew, you from this side, Drew?
Okay, Drew.
That's good. It's good, Luca. We're ready for the shower cap, gentlemen. So, Drew, you ready to ret to that?
And yeah, I'll need to reposition again.
Okay, Luca, that's good. We can start working the shower cap. if you want to initially ret to it, then we can hand it off, or we can wait for Drew.
I'll do that. Yeah.
Caution for you, Luca, is avoid contact with the silver tape on the radiator.
Copy. And then Mather wants me to put some wax on it.
Now the work on the mud flap is complete. Now Luca Parmitano will move over to remove the shower cap to expose the new radiator system.
I think that's what I heard you say.
I think they were covered already with the old MLI, and then we added more, possibly with the shower cap, with the mud flap.
That's what we wanted to hear.
Okay. All right, I'm ready to release the shower cap. All right, you have a red on it? I have a red on it. All right. Which, if I could get you a red, that would be even better. Can you release that? Do you have access to that? What is, probably not. No. Okay. Christina?
Go ahead, Luca.
All right, take me body out about 20 centimeters.
Copy, 20 centimeters, body out. Starting motion.
Copy.
And before I start, Drew, to verify you've got his clearance in that direction?
Body out direction, yes.
Copy, starting motion.
Motion.
Copy. And there's your 40. Excuse me, there's your 20.
Perfect. Now, body left, 30 centimeters.
Left, 30 centimeters. And Drew, you'll be watching his boot plate to the Missy. Motion.
Okay, copy, I can see it. Motion.
Copy. And there's your 30.
Continue for 45.
Copy, continuing another 15. And there's that additional.
Okay, so, okay, yeah, that from there, I see that you're ready to it, and then we need to get that or a tether point to me. Okay. We're separated by quite a bit here.
And maybe you want a GCA if you need to, but we need to transfer the bag at some point too.
Keep sending. Okay, I have a red on it. Okay, you have a red. And I'm releasing my red. Okay. I'm release your red. Copy. Released. Okay. Okay, now for GCA for the bag. Let's see. I think probably the best thing I can do is go close to the ROU. Say, I mean, if you, yes, that will work.
Okay, they're working robo inside, Luca. If you want to grab some closeout photos while you're there.
Okay, can work.
So Nana and Luca, I'm not sure if you missed each other's call, but Luca's looking for a GCA.
Okay, Copy that. Luca, I'm with you. Go ahead, and I missed the description.
Yeah, I haven't done it yet because I'm trying to figure out what I want to do.
So, Luca, we don't have that far to go. In fact, if you can get a hand on it.
Okay, let me put the rest of it.
Yep.
Nicely done. Okay, I have a red.
Okay, you have a red on it.
Yeah.
Okay, so I'm going to release this one.
Yeah, release yours.
So, stand by.
And Luca, do you want to just bring that wrench back with you, or do you want to try and transfer it?
If I can put it on this bag when I'm done with it.
That's what I would recommend. Put it.
Put it in that.
Or keep it on you, either one. But okay, so the large small is released.
Okay, I have the bag.
Stand by. I'm going to make sure the ret is going to reel in. With this large small, you'll just need to connect it to something. Here it comes.
Yeah, okay. I'm going to set the whole bag. Okay, so for the arm, whenever you can, just take me back to common or to the next position to get ready to go back, I suppose.
Okay, copy. So you're done at this work site, and we're going to be heading back out.
That is correct.
One question before you go, Nana, is just make sure we have no shadows on the radiator. There's no tools or hardware creating a shadow on the radiator, Luca.
So the only shadow comes from the structure itself.
Okay. All right, you're good for Robo, Nana.
Thanks. And Luca, for you, the first motion we're going to be doing is 40 centimeters body out. So Drew will take your clearance in that direction.
Stand by.
Copy, standing by.
Okay, I've got the clearance.
Copy, starting motion.
Okay, good motion, good clearance.
Okay, and that concludes the body out motion. Next, we'll be doing Luca's body left, 15 centimeters.
Luca's body left, 15 centimeters. Okay, I see Missy's the big. All right. And Luca, the bag, just with it kind of moving around during this GCA in particular, if it's still for this movement, go ahead. Nana, on you.
Please, starting motion.
Copy. Motion.
And that concludes the left motion. Stand by while we set up for the next.
E1 copy. E2 copy. Very true. Old habits are hard to break. Jeremy, for the wrench, I just installed it in the large OU bag. So it's off my ret.
Okay, Drew, or Luca, we copy
And
that.
Luca, for your motion, it's going to be about 1 meter zenith in direction of your feet.
Okay, copy. And I think I can monitor my own clearance.
Copy, starting motion.
Copy motion. Motion.
Copy. Okay, and that's your motion. Stand by while we set up the next.
Copy, standing by.
Okay, Drew,
Okay,
if you want to
my
prioritize...
GFT is going down.
Drew, if you want to prioritize the APFR now while they're using the Robocom, and then we can come do the inventory after.
Okay, copy. So, what's our next move going to be, Nana, just so I know whether I'm going to need to be here for the clearance?
And Luca, this next motion is going to be a 3.5-minute JoeCast in Vern to AMS Common.
2 copies.
Motion.
Okay, see, it's a JoeCast, and...
Yeah, okay, so we're all good then, Drew. So we've got comm. We can do, we can go in any order you want. We can wrap up the bag inventory.
Copy. All right, I'd like to start with the lid of the bag. Actually, let's talk to the exterior. 2 large, small adjustables and a large, small ret. On the lid, I've got a small, small ret. To a wire tie, and then I have a small, small ret to an adjustable, to 2 Velcro savers. And then I have another, I just had another available hook that I put that second wire tie. So I have both wire ties, I have both Velcro savers. Got a PGT in the upper left corner of the bag, small, small ret, and it has an adjustable on the handle. In the lower left corner I have shower cap on a small, small ret. In the upper right corner I have wire tie caddy with all of its wires still in it. Another small, small ret that is empty. And then in the lower right, I have 2 small, small rets, one with a trash bag and one with an adjustable, and it has a dyno cutter and the lancer on it.
Okay, and the PGT has a 6-inch on it?
It has a 6-inch on it.
Okay, it's good inventory, Drew.
Now 4 hours and 35 minutes into the spacewalk today, Andrew Morgan and Luca Parmitano have finished installing a MLI, or a multi-layer insulation tent, underneath the AMS pump system to close out the former debris shield worksite. They also installed a mud flap between the new pump and vertical support beam, or VSB by its acronym. And just now, they removed the shower cap, exposing the new radiator, completing the AMS tasks. Drew Morgan and Luca Parmitano are now working to clean up the work site while the ground crew assesses additional tasks.
Okay, we're handing over in 15 seconds. I'll be back in a minute. Drew, we're ready for you to pick up the APFR and take it to the Cedar cart. It'll be the starboard Cedar cart. I'll be back in 30 seconds.
Okay. Copy.
And Luca, this is a 3-minute JoeCast in course.
Recapping the milestones from today, Drew Morgan completed the leak inspections at the Nader Worksite and found no leaks. Luca Parmitano found 1 leak out of 8 tubes on the first tube he checked and was able to tighten the connection on the leaking tube. Luca Parmitano also completed the remaining VSB, vertical support beam tube inspections, and found no additional leaks. Parmitano re-inspected the tube again and saw an indication of a leak and tightened the connection once again. On the third inspection, no leaks were shown, therefore the jumper installation was not required, and Morgan and Parmitano were able to continue moving down the timeline as originally planned. Luca Parmitano then opened the accumulator valve, which pressurized the new system, ensuring all the cooling lines were holding pressure as expected for the resumption of the activation of the system. They worked together to install an MLI, or multi-layer insulation tent, under the AMS pump system to close out the former debris shield worksite, then installed a mud flap between the new pump and vertical support beam, or VSB by its acronym. They then removed a shower cap most recently, exposing the new radiator, completing the AMS tasks. Morgan and Parmitano are now working to clean up the worksite.
And Luca, that's position hold, setting up the next.
Copy.
Luca, next is a 3-minute JOCAS in course to S1 intermediate.
Copy.
Questions?
I'd like to bundle this, if acceptable.
I'll double check, but that sounds good. We're good with it, Drew. The other unknown that I still have, Drew, is I think your tether is still fair led by that adjustable. We got to pick that up too. When you get to the CETA cart, I've got settings in case you're working something now. It's Yankee, Yankee, Delta 12.
I'll come again later.
And Luca, your next Stowcast is 3.5 minutes. Invert to S1 back off.
Copy.
Starting mission.
We'll put that adjustable just on my main workstation.
Copy.
On the fair lead.
All right.
While we have a little bit of time, what's going to be my next step?
Okay, so we're 4 hours, 45 minutes in. We're still looking good. We think we're going to have time for the just to get the camera lenses. We're still going to lean forward and try and do that. And so ideally, probably have you just cleaning up the arm by yourself, if that works for you, and then we can send Drew to start the camera task.
That sounds fine for me. So you want me to fence stow the bag and clean up the arm? Do a tether swap? What is the sequence that you expect from me?
Okay. Probably makes sense to do the tether swap and then take the bag back to the airlock and then come back and deconfigure the arm. Does that sound good to you?
That's what I was thinking about. I wanted to hear from you. Thank you.
Drew, how's that sound to you?
Could you give me the pitch when we start?
Yeah, we'll be looking for Yankee, Yankee, Delta 12. So Yankee, Yankee.
Okay, Yankee, Yankee.
And you get a good pitch knob check?
Yeah, it depresses.
Copy, thanks.
Okay, that's position hold, setting up the next.
Copy. Stand by.
All right, Drew. Looks like you're wrapping up your time in your nest. So have another look back at AMS. Make sure we haven't left anything behind. ELC is empty. And then you're heading to the CETA cart.
Okay, copy.
Good for you. Your next motion is going to be 1 meter, station aft. Check ingress rate.
Copy. Good clearance, and looks good.
Motion.
Okay, see nothing left on ELC. I'll get a peek at AMS coming around the corner.
All right. You're on your way. You're leaving it. Say so long. Sweet Liberty.
Feel like we lived there. Yeah.
Luca, that's your published APFR configuration maneuver position.
Okay, confirm the bits when I egress.
And yes, go back. This is actually your egress position.
Okay.
So if it looks good to you, then let me know and we'll call it GCA complete.
GCA complete.
See?
Hey, lead last look at my WBS.
They're on your go for egress.
Copy. For egress.
Wait, do you have WBS?
No, we don't. It's just too dark for us to pick anything up. But we trust you. We've got a good inventory. We just wanted that last chance check.
Copy.
All right, we're handing over in 30
Yeah,
seconds.
off the arm.
Okay, Luca. So probably pick up your safety tether would be your next steps for you. And we were going to have you just build, just rebuild a safety tether pack if that works, but you can probably go either way. I'll be back with you in 40 seconds.
Copy all.
Okay, Luca, I'm back with you. So preference to the safety tether pack build, and I can step you through it if you like. That'll give us rescue options with Drew going port.
Okay, I have the tether. I have both tethers on me. So I'm putting the green tether onto the red wheel.
That's right. Green tether on the red
and
wheel.
It stays unlocked. Yeah. And then the next thing is going to be once I let me think. So what's the?
And then the yellow hook
So I have the.
is going to go on the green reel.
Okay, so right now, though, in order to remove the yellow hook, I have to lock the green wheel.
Yep, let's do that. That makes sense.
Okay, so now I have the green wheel is locked black on black.
So all your
the red wheel.
all the hooks should be locked.
And now when I recover the yellow, I can put it on the green wheel, lock it. And I can also, as a matter of fact, why don't I go ahead and also lock my waste tether? Where I'm sure I'm not breaking any safety constraints.
Yeah, that's right, Luca.
Okay. I have a safe load, and
Now 4 hours and 52 minutes into the spacewalk today. With the AMS repair work complete, Drew Morgan will now make his way over to the intersection of the P4 and P6 truss to begin a get-ahead task, removing lens filters that have fogged over, creating a hazy vision for the high-definition cameras. In the meantime, Luca Parmitano will continue cleanup work at the worksite.
Okay, Drew.
And my motion has about 2 meters station zenith. Bye, we're setting it up.
I take that Whiff number.
Whiff 5, Drew. And so that's the Whiff between the CETA car connection and the MT.
Okay, it's right next to square H.
A firm.
Okay.
Okay, Drew. As you're setting that up, I just got a couple of thoughts for you. One, we're going to have to watch your met rates in order
Starting motion.
to have consumables past 6:30, and then we wanted your inputs on the plan to do the camera get ahead. What are your thoughts on that?
My thoughts right now are...
And Lucas, starting motion.
Get you on the other side of that GCA. Is a good motion?
Copy. Meter to go, or till you stop me.
Copy, continue. Three, two, one, stop motion.
Motion stopped.
GCA complete, brakes on.
Copy, GCA complete.
So you got the gums.
Brakes are on.
Copy. The pitch, I think you said, was delta.
Pitch is 11. Oh, sorry, the pitch is Yankee, Yankee. Clocking's 11, so it's 11, Yankee, Yankee, Delta, 12.
Okay, I meant roll delta, yeah.
You can have the comms for a second.
Go ahead.
All right. Okay, Jeremy. This is my configuration. On my left wing extender, I have a red hook, small hook, locked black on black. That's my red wheel, which is unlocked. The yellow hook is now locked black on black on the green wheel, which is also unlocked. Small green hook is on my red wheel, and then on the other side I have the anchor at the airlock.
That's a good config, Luca.
Okay, with that I'm going to unlock my waste tether, and I'm going to go back to the airlock and drop the large radio bag.
Okay, good words, Luca.
Thank you for the comms, Drew. You're me back.
Okay, copy. All right, so I've got it installed at 5 clocking of 12.
Clocking should be 11, Drew. And Drew, I know I broke your stride on that. You're still redded to that, right?
I'm still redded to this. I think that there's maybe some interference. Let me make sure I've got the right settings. I feel like I didn't get them all correctly. Yankee, Yankee.
Yes.
Delta for roll.
Yep.
And the yaw, looks like it was off by 1.
Okay, yaw should be 12.
12. Okay. And the clocking set is 11.
11, so single line 11, double line 5.
Now 5 hours into the spacewalk today, teams here in Mission Control Houston are assessing if time will permit the crew to do any get-ahead tasks during the spacewalk today.
Black on black. Full twist.
Good checks, Drew. All right, gentlemen, so we're 5 hours in. We're doing good here, so there's no rush. We just want to take it easy on the met rates and take our time, and we'll get through what we can get through.
Copy, read it. We'll see where we're at when I get back to the airlock.
Yeah, that sounds good.
And, Jeremy, since I'm here and I'm going up, back out, I can take the T1 get ahead bag and hand it to Drew. He doesn't have to come all the way here.
Checking down that, Luca. Yeah, that's good, Luca. You can take it with you. Save you a trip.
Okay. I already got the large U bag stowed in the airlock. Okay, T1 get ahead. Go Tether on it.
Okay, that's the right one.
Okay, the bag is on my DFT. I'm going to close the hatch and check my handles and my gloves.
Copy, Luca.
I got that yaw. I had to re-yaw to get the bag off. Bundling the bag was probably not worth it. I mean, all that I had to untangle to get it out again. But what yaw do you expect it to stay in?
Okay, so the yaw should be delta. Roll of 12.
Yaw expecting a number.
Okay,
I think it was 11.
then that's 12. So the overall settings
12.
were 11, Yankee, Yankee, Delta, 12.
Okay, that is set. I can confirm.
Jerry, I have baseline gloves, dry hat, handles down.
Okay, copy, Luca. Good checks. Okay, and Drew, we're going to have to grab the Cedar Cart brake pedals on your way by.
Roger.
And Drew, you probably said it to me, but I can't remember now. Did we get a good pull twist after that last 11 clocking?
We did, but I can go back and re-verify.
No, I don't need you to, as long as you said it. I just didn't want to get you too far away before I asked.
I'm going to check. Black on black. Full twist. Okay, I'm at the green hook location.
Okay, copy. You're picking up your green hook.
Green hook is up. I'll get the pedal, the brake pedal.
Good words, Drew.
Okay, good. 2 good pushes on the pedals. Gonna have to port seat cart.
Okay. And reminder to grab the brakes on the way by.
2 pumps on the brakes.
Okay.
Release.
Sounds good.
Hey, Jeremy, and whenever I can have a little bit of your attention, I'm ready to configure the ATSI and the Whiff extender for storage.
Okay. All right, Luca. So I want to take 30 seconds here for both of you. Let's just stop for a second and make a couple of decisions. So we're at 5 hours and 10 minutes. We do have time to tackle the camera get ahead if we want to go after that, or we're also happy to just come back in at this point. So there's a few options here. And so based on Drew's Met Talks, we could swap roles, have him clean up the arm, stay near the airlock, and Luca, you go to do the camera task. Or we could have Luca clean up the arm and Drew go do the camera task. Or based on the MEDOX we have left on Drew, we could just have Drew stay at the airlock, and Luca, we have enough time for you to clean up both those tasks. So what do you say, Drew?
So, what I'd like to do is we'll just proceed, let Luca clean up the arm. I will head out to the first CP. I'll tell him where the bag is, and if he comes out to join me to do the other CP, bonus.
Okay, it's a good plan. So Luca, here comes some info for you. Drew, you're heading back to the airlock. Luca, you are looking to, well, I guess what I need to know, are you going to bring them back all, both together again, Luca?
Yeah. I think it's going to get stowed together.
Yep, they do. So you...
Yeah.
All right, so wait, let's start at the APFR, and we'll work down to the Whiff extender.
Break. So, you're going to go to the get ahead, right? Yeah, but I got to drop this bag off. Okay. Can I leave this bag here? Is that a good position for you? If you would put it just a little bit more outboard of you, if you can slide it down there just past you. I will do that. And then I'll head that back down to the airlock. Sorry, Jeremy, I need it.
Yeah, it's all good. Okay, so the APFR settings should be 3, Quebec, Foxtrot 3.
3, Quebec, Foxtrot 3.
So that's, we're going to have to reclock that APFR.
Sure. Do you want me to put this back in the airlock? That would be preferred, I think.
We're happy with your preference. And Drew, do you recall, I know I called the brakes on the inboard seater cart. I thought I heard you say it, but we have a discrepancy down here. Do you remember getting the brakes on the inboard?
Absolutely do. I said 2 pumps on the brakes. On the,
after you prompted me for it.
All right, thanks for double checking. So that's Quebec, Quebec for the pitch.
Okay, I'm good, Quebec, Quebec, and the knob is out and can be depressed.
Okay, copy.
And so now I have to reclock this.
Hey, firm.
Now, remind me, I have to ret in order to reclock, or is it going to be...
Yeah, you need to ret to it to reclock it, yes.
I'm ready to it. Now we go black and white, and 3, meaning, so...
3 on the single line or 9 on the double line?
On the single line, okay. So it's going to be rotation.
Drew Morgan and Luca Parmitano will now make their way over to the intersection of the P4 and P6 truss to begin a get-ahead task, removing lens filters that have fogged over, creating a hazy vision for 2 high-definition cameras. They'll split the work to remove the lens filters. One will take the CP8 lens and one will take the CP9 lens.
Okay. So locked. Okay. Black on black, good tool test, good twist test.
Okay, Luca. And you got the Foxtrot 3?
And I already have Quebec, and Foxtrot 3 was the first thing I configured. So now I'm going to need to, now I can release the ret, right?
Well, you're going to need to ret to it somewhere, wherever you want to, either there or on the Whiff extender, your call.
Yeah, no, it's going to have to be on the Whiff extender.
The medium ORU bag is back in the airlock, and thermal cover's closed again.
Okay. Thanks, Drew. And you check your handles after you came out of the airlock. Luca, for you, you're looking for Alpha 1.
So it's already on Alpha. So what I'm going to do is shrunk it down to 1, I think.
Yep, that's right. Should already be Alpha.
Okay. Alpha. Verify. Yep. And I can confirm it's at Alpha. And now I'm going to ret to the Whiff extender. And get ready to BFT to it.
So, Drew, we need to stabilize your met rates a little bit. So we'll just have you hold there for a couple minutes.
Copy.
I have on the BFT the Whiff extender ATFR combo.
Okay, Luca, that's going back to where you got it from.
Okay, copy off. Going back to the airlock.
All right, I'm blocking your way. You're on the feeder spur.
And just about ready to come down. This is first. Okay, I'll go out the toolboxes.
Yeah, that sounds good, Drew.
Roger, I see you. You should be completely out of my way. So you got some nice fair leading in there. What's that? You got some nice fair leads in there. Yeah, because I had to readjust it when I was coming back, and on my back on my tether, yours was both a little bit kind of in the way. I'm gonna have to undo it though. This thing is, unwieldy, so. Yes, I see it. Yeah, let's watch out for. We'll go very slow. Your, release your, fair lead on 500. There it goes. Grab your fair lead on 500, and you'll leave it in place. Oh, that one I'm going to leave it in place. Okay. Just in case I come after you. Yeah, at this point we can probably just go together. Yeah, I think so. I think that'll be preferred. But anyway, continue on. Okay, and can we verify the Whiff is 12? Maybe we've got to keep going.
I'm just checking here. I don't have it written. Oh, it's Whiff 11.
It's 11.
Whiff 11, actually.
It's 11. I got it.
And
11.
it's a clocking of 10.
Clocking of 10. Okay.
So 10 on the single line, 4 in on the double line. And yeah, Drew, it's that Medox canister's not doing you any favors, so we're just being a bit conservative here. So let's just let Luca finish this out, and then we can decide whether you're both going to go or just Luca goes.
Okay. Okay, I've installed the 4, the double line, and I have
Good,
a
Luca.
good pull test, good pull, and good freeze test.
It's good, Luca.
Okay. Show you my rep. And just give me the plan.
Okay, Luca, you can start translating up the Cetus spur, and I'm going to give you guys the big picture here.
Okay, copy. I'm out of your way.
Okay, so here's where we're at. It's based on that Maddox canister for Drew. It's behaving now that he's not moving, but if we're afraid if we send Drew back out there, we may limit ourselves. So if you guys are good with the plan, we could have Luca go out and do one or maybe both cameras and have you just take care of the airlock there, Drew. If you really want to follow him out, we're okay with that, but you're going to have to really manage the met rates.
I'd really like to follow him out, and I will go super slow.
Okay, all right, we're good with that, super slow. All right, so we're all on the same page. Luca is leading out. He's picking up the bag and heading out to CP 8 and 9. And Drew, you're following him slowly behind him.
Good fairly then, Luca. Copy. And do we have any initial tele back on AMS? Are we able to do anything with it yet?
No, nothing really happens till tomorrow at this point, so we won't have any insights until at least tomorrow, maybe longer, from what I understand. But it still has a good heartbeat as far as we know, so we definitely didn't do any damage to it.
Copy.
Okay, Luca, I see you got the bag and you're heading out. So you're going to go to the nadir light first. The zenith light is not ready. We still got another 17 minutes on the countdown clock for the zenith light.
Okay. It works. Do you have a suggested route?
Just straight along face 1, and then let me pull that up.
And Luca, and I'll have a little bit of, I'll be able to see ahead of you and tell you when you need to turn north or south.
Okay, cool.
Should do the nadir one first, so
yeah,
that's
nadir.
CP9.
Sure.
Okay, that's helpful, Drew, if you can give him a vector. Okay, Luca, as you approach the FHRC, you may hit the end of your tether, so just be ready. You may need to drop your green hook.
Okay. Copy that.
Okay, and the light is just 2 bays outboard from the FHRC.
Now 5 hours and 26 minutes into the spacewalk today. All systems are showing a healthy AMS as they go through preliminary testing. Crews are reporting here on the ground. Drew Morgan and Luca Parmitano are now making their way over to the intersection of the P4 and P6 truss to begin a get-ahead task, removing lens filters that have fogged over, creating a hazy vision for 2 high-definition cameras.
We have powered off the light greater than 1 hour, so that's okay. On the high-definition camera, do not touch the vent ports. And then avoid inadvertent contact with the window shroud. So you shouldn't have any need to really touch the camera except for the lens itself. Avoid contact with any Z93 paint or camera silver Teflon. So that the PTU, which allows it to twist, will not be locked. So you're going to minimize loads when you're above that the joint where it twists, and try not to put any rotations into it. Avoid inadvertent contact with high-definition camera antennas and quartz aperture. Avoid imparting kick loads above the launch restraint bolts. And then finally, you're going to be working close to the radiator, so you don't want to kick the beam of the radiator.
Looking at the camera, trying to get everything you said into context. I think I have a good understanding.
Okay, copy that. So you are going to...
The other camera is opposite, so should I just drop the tag here in the middle so that...
Yes. Yeah, you need to drop it because you'll need your BRT to do the task.
Okay, it worked.
So what you need is a round scoop and a trash bag.
Copy. Okay, the bag is going to be dropped at NRL 3672.
Copy.
Numbers looking okay, Weed?
They are, Drew.
Putting out the scoop. The rest of it.
This view now from Drew Morgan's helmet camera as the International Space Station and the spacewalkers fly 271 statute miles above the Pacific Ocean.
Interesting. Looks like the scoop doesn't really go on the left-hand side because of interference with the attachment points. Go the other side, I guess.
Yeah, I didn't remember that either, Luca. That is interesting.
There you go. There it goes here. I have the scoop. I'm going to grab the trash bag.
Copy.
Those numbers look good enough to back in the game, or is that pushing it too much?
I'm checking, Drew.
Hey, Jamie, you got a scoop and a trash bag.
All right, Luca, your go to translate down to the light. first thing you're going to do is go ahead and install the round scoop on the microconical. Actually, before that, I'd put your local tether down on the tether point, which is just nadir of that microconical. All right, Drew. So your go to gather up a scoop and a trash bag and head to the zenith light, but just be real slow and gentle on those met rates for us.
Okay, copy. I'm gonna drop my green hook like Luca did. He dropped his on. Let's see what handrail. It was a handrail on the inside.
Okay, sounds.
See, Luca's at mile marker 9030, and I'm gonna be on that same vertical handrail on the opposite stanchion.
Okay, sounds good, Drew. Just for your essay, we're still 8 minutes away on our clock for being able to translate onto the camera.
Okay.
Okay, back to you, Luca. You're going to go ahead and put your loco down.
So I suppose that the tether point is on the box itself, and it's the one that's
yeah, it's just
on the left. There in the camera, there of you.
that wasn't the one that I was talking about, but let me see if that one's okay. Yeah, the one that we were talking about is the one that's right by your left hand there. But I'll check to see if.
Yeah, I thought that.
Okay, yeah. Why don't you just?
I thought that there was a target to that.
Yeah, just put it there, and then I don't have to check.
Okay, tethered.
Okay, and then the scoop goes on the conical that's just below that from your perspective, and you want the handle to kind of come up.
Away from the.
Yeah, up, pointing towards the camera. Drew, your mets are looking good right now, so just keep doing what you're doing.
Copy.
Scoop and a trash bag for you, Drew.
Okay.
So I don't know if there's any interference there, Luca, but in my diagram, I have that handle clocked kind of 45 degrees to your right. So as like the 2 o'clock position, it would be pointed like to the right, the camera that's on the right side.
Yeah, I don't see interference. It's good to go. Try one more time.
Yeah, that looks like what we planned for.
Okay. Here goes. BRT to it.
Yep, BRT to it, and then make sure your trash bag is ready, and then remove the cap. So, Luca, don't worry about that black shield until after you get the lens cap off, and then we'll adjust it just before we leave.
Okay. And now you want to square it?
Yeah, put it back. Make it look like you were never there.
Okay, it'll make it look like an accident, Dave.
It came off all right?
Yeah, it came out all right.
Okay, Drew, you got another 3 minutes on your timer.
Okay. That means I can't come anywhere near it.
I'm checking. Okay, Drew, so you are good to go up the light. You can't touch the camera or the light. So all you can do right now is you can put your local on the tether point and you can install the scoop, but don't translate up any further yet.
Copy. All right.
Okay, Luca, so you cleaning up, undoing everything you did, so you can go back and put those in the bag. I recommend you put the bag on your BRT and then wait for Drew, and Drew will lead back to the airlock. I'm going to hand over here in about 50 seconds. By the time I'm back, Drew, I'll be able to give you a go for your light.
Okay.
The lens cover that Luca Parmitano was just working on, lens CP9, has been removed. Now they're waiting for the CP8 lens and camera to cool down before removing that lens.
Okay, I'm back with you, Drew. Your timer has expired.
Okay, copy.
All right, I see you've got a round scoop there, and it looks like you're putting your local on the tether point.
Drew Morgan now has a go to remove the lens filter on the CP8 camera.
Yeah, I think you might as well. It's up to you, Luke. I think you might as well put it on your BRT and be ready to take the items from Drew. Work together to transfer him. He needs to lead back to the airlock anyway.
Okay.
Again, Luca Parmitano and Drew Morgan are completing a get-ahead task to remove lens filters that have fogged over, creating a hazy vision for the two high-definition cameras. The CP9 lens filter was removed by Luca Parmitano. We're now standing by for Drew Morgan to remove the lens on the CP8 camera.
Got eyes on me, Luke?
I do.
Hey, it's in the trash bag.
All right, nice work, Drew.
Scoop is released back to my, I got it to an adjustable on my workstation.
And Drew, can you just confirm that the black hood is square to the camera?
Square to the camera.
Thank you.
And here's our first look from the CP9 camera that Luca Parmitano worked to remove the lens filter from. This camera capturing those high-definition views once again.
Bag inventory.
Okay, so for right now, I have an adjustable to an integral, and on the adjustable, I have my scoop, my bag with the cover inside, and I have another integral with a white caddy. White caddy has 5 shorts, 4 longs. And then I have another adjustable to another integral, and the adjustable is empty.
Okay, that's good, Luca.
And that's what we'll put Drew's bounty. Now I'm ready to it with my ERT wrap. I'm releasing the bag. As soon as Drew puts the stuff back in the bag, I'll put it on my ERT.
I'm right above you and I can hand the things off to you. Here's,
this one is on adjustable. Okay. Really short. You have it on adjustable?
I do, yeah.
Okay.
Because that's what I had.
Here.
Did you take the trash bag off as well?
Yeah.
So put a red on it?
Oh, you don't have a red? No.
I mean, you put yours back in the bag, correct?
Yeah, Yeah, mine is in the back.
Okay. Okay, it's red on it?
Yeah, it's red.
Okay, I'm releasing it.
Yeah,
release station.
Yeah. Okay, and now final inventory. I have also another bag on the adjustable and another scoop on the other end of the adjustable that's directed to the integral rest.
Okay, that's all we're expecting. You can close that up.
Outside,
Let's go home.
On the outside, I have a large small rep.
Looks like they're happy.
Copy, Luca. Drew, you can lead back.
Copy.
We're at 5 hours 50.
Right above you.
We're doing good on time, so take your time, gentlemen.
And the lens cover is off the second camera. That would be CP8, the camera that Drew Morgan worked on. These cameras will both be capturing those high definition views once again.
Now pick up my green.
Okay, Drew.
Okay, retrieve my grain hook. You're cleared to come back inboard to your green hook, Luca.
Okay. I have the green hook.
Copy, Luca.
Following through.
I'm heading back inboard. Almost over the lab.
All right, we've turned on both cameras just for your SA. They look great. You guys just left one fingerprint on the lens, Drew.
Okay. I'll go wipe it up next time.
Now getting our first view from the CP8 camera that Drew Morgan worked to remove the lens from. Again, these cameras both capturing these high definition views once again.
They just leave pieces of themselves everywhere. Yeah.
Well, the last parrot that did this RTV flaking became my favorite. It's got a couple of EVAs out of them.
Yep. You know how to get the most out of your gloves.
Drew Morgan and Luca Parmitano now in the final stretch of the spacewalk today as they head back to the Quest airlock to begin repressurization.
Luca will have the red bag. Luca, where's that stowed?
The red bag is stowed on the inside, basically where the MLI was back, was stowed.
Okay.
Hey, Drew, I think that's the Amazon down there.
Yep, that would be about right.
Just out the Amazon.
Yeah, there you go.
Nice. Take some shots of that.
Now 5 hours and 55 minutes into the spacewalk today, both spacewalkers are now making their way back to the Quest airlock to begin repressurization.
Yeah, that's the same position that we had when I was coming in. So that's sounds like a plan.
In the middle of your screen now is Drew Morgan in the suit bearing the red stripes, and at the top left hand of your screen you'll see Luca Parmitano make his way into the camera shot.
I'm going to look at the rat nest to see if we take some good picture for the next drivers to go there for that cable. I don't know if the team is go with that. Hey, Jeremy.
Yeah, go ahead. I'll double check.
Yeah, I was gonna. Do you think it's a good idea? If we have a couple of minutes, I can translate back on phase 3, I think, and see if I can get good pictures for the next drivers to go there.
Well, what about just taking a picture from there?
Well, so from here, maybe if I can climb back to the Cetus spur.
Luca, it looks like we should just head back in. Let's wrap it up.
Okay.
Okay, we're good with that.
Maybe 2 coffees. Come back.
The thermal cover's open.
Copy.
Right, and Luca's putting the crew lock bag in, and then he'll go in and get safe on waist tether on the D-ring extender.
Okay, I concur. Luca's going in, attaches his waist tether to the airlock D-ring extender is our first step. And then just give us a visual that we got 3 bags in there that we had out. So the red bag, the MLI bag, and the contingency bag you just brought back.
3 bags visible and tethered. Gonna get my own tether. And attempt still to get the P1 get ahead.
And Luca said, confirm you do. You saw the medium RRU bag and the red RRU bag. Are they positioned well for? Try to get it as far close to the hatch as I could.
I'll play with them a little bit, but I think it's very a decent condition.
Okay, Luca, talk to us about your waist tether.
Oh, my waist tether is currently on the D-ring extender, and it's locked, close black on black, so I'm safe, and my safety tether can be released.
Okay, copy. I'm taking Luca's large hook and I'm putting it to my right waist tether.
Okay, copy.
My right waist tether and his anchor hook are locked black on black. So I'm safe to Luca.
Okay, good config.
Okay, and that means I'm releasing my anchor hook.
All right, copy. Looks like you're all cleaned up outside, ready for you to ingress.
Just having a look around and everything looks good. Okay, Luca, are you ready for my feet to come in?
I am ready.
Okay. Here's the start of my feet.
I'm all the way forward, Drew.
Okay. Waiting for the thermal cover to bounce back.
A view now from Drew Morgan's helmet camera as he makes his way back inside the Quest airlock for repressurization.
Okay. Thermal cover is closed.
And the thermal cover is closed.
Okay, next is your SCUs, and at some point, Drew, we want to make sure we get the tab on the thermal cover.
Copy confirm, we are going to go to connect SCUs.
You are both go to connect SCU.
One of the magnet's mated on the opposite side from the hinge. Other ones, you know, kind of potato chip out like they usually do.
Okay, so the Velcro tab needs to be brought inside there, and you can push in the middle of the cover a little bit to stop that potato chip effect.
Okay, I got the Velcro tab.
Yeah, that looks right. And then we still got a bit of that potato chip effect if you want to hold it closed with one hand and kind of push it in the middle. That looks good, Drew, I think.
It's as good as we've seen it.
Okay, copy that. All right, let me know when you're both on SCUs.
Copy. Copy.
And just confirm that they are locked, the SCUs, when you read that down. A reminder for both of you about cooling settings at this point. So a TCV setting of 8 to max cold will minimize time for effective cooling.
Copy. TV2 copy. Okay, SU locked. TV2 SQ locked.
Okay, for both of you, switch water off.
TV1, water off. TV2, water off.
Okay, we're in our 2-minute timer now. We're 1 minute in.
Copy.
And just for your awareness, it's been a 6-hour, 8-minute EVA so far. We have about another 40 seconds to go. Drew, you can verify that the hatch area is clear and ready to be closed.
Hatch area is clear.
Okay, you can prepare the hatch, but don't close it yet.
Understood.
All right, your go to close the hatch, Drew.
Copy. Hey, Luca. Cool. I need you to rotate your pliss forward because we're locked pliss to pliss. Hey, how about now? Hey, diesel got away. That's better. Bend your knees. There you go. Okay, close the latch.
Okay, I heard closed and locked. Confirmed, Drew?
Closed and locked.
Okay, Luca, on the UIA, check oxygen, EMU 1 and 2 valves are open.
EMU 1 and 2 oxygen open.
Okay, on the UIA, switch power EV 1 and 2 to on.
Over, EV1, EV2 on.
Okay,
This is LED 1A.6.
Okay. And now for both of you on your DCM, switch power to SCU. Expect a warning tone.
EV1 SCU.
EV2 SCU.
Okay, gentlemen, that brings us to the end of my part of the Depress Q card. I can tell you with great assurance there's a huge team of people on the ground that have breathed a huge sigh of relief after your work today. And you certainly saved the most entertaining EVA to repair, AMS to last. So it was hard fought today. Really well done. Cool heads prevailed, and your preparation really showed. So nice work to both of you, and a debt of gratitude from the whole team.
Oh, thanks so much. We did it. We all did it. The AMS team, the flight control teams, the science teams that have worked on this for the last 4 tough years, and by giving AMS a new coolant pump, we've given this magnificent scientific instrument a new life, and look forward to it teaching us more about the mysteries of our universe. It's undoubtedly going to be part of the ISS scientific legacy for years to come. But even if AMS never collects another single data point, what we've demonstrated over the list set of EVAs is what NASA and its international partners do best. We tackle the most complex problems under the toughest conditions, come up with engineering solutions, develop a plan, and then we execute it with grace. Luke and I are super proud to be part of this incredible international team. And finally, this wraps up the longest string of ISS stage EVAs in a single increment, and to the Expedition 61 increment team and every flight controller around the world that touched this expedition, you should be immensely proud of what we've all accomplished together. Thank you all.
could not have said it better, Drew. Thanks to you, and I'm going to hand you back over to Nana and Jessica.
All right, Drew and Luca, welcome back. Amazing job out there. It was definitely an interesting day, more interesting, I think, than any of us thought, but you guys rolled with all the punches and got the job done, and even some get-aheads. So congratulations, welcome back. Your dinner is waiting. With that, both of you on your DCMs, bring your oxygen actuators to press.
V1 press. V2 press.
Copy. Drew, check that the EV hatch MPEV is closed.
Closed.
Okay, copy. I'm going to throttle the equalization valve from off to norm. We'll start off slow, and you can let me know if you would like me to bump it up.
Copy. V2 copy. Break. I got an O2 actuator fault message. I'll double check that I'm in press.
Be Drew.
Okay, I show that I'm in press. I'm okay with increasing juice, York. I'm totally good with it. We can crank it up.
Okay, copy. I'll bump it up. And we're about half.
Repressurization is officially underway, marking the official end time for today's spacewalk at 12:20 p.m. Central Time. That makes today's spacewalk a total of 6 hours and 16 minutes.
Okay, copy. I'll bump it up. Still good with the rate?
We're good.
When the crew lock is at 4.0, you can expect an alert tone.
Copy. you copy? We got it 453. Yeah, 4. Copy.
Copy 4. And as you know, I'll be pausing once we get to 5.
Roger.
Okay, we've reached 5. I am pausing here. We'll wait for 2 minutes for the crew up pressure to stabilize.
Man, Jessica, you guys were awesome. Luca, great job.
You believe you want, man. You led us through this. And Jessica, Christina, fantastic job as IBM Robotics. I could not be more proud. I could not be more proud of you guys.
Thank you, guys. We feel the same about you. Okay, that's 2 minutes. We've got 1 more minute to wait.
Did you copy?
Ready when you are.
The spacewalk today was the 227th spacewalk in support of International Space Station assembly and maintenance, and the 3rd spacewalk from the station this year. It was the 7th spacewalk for NASA astronaut Drew Morgan, bringing his total spacewalk time to 45 hours and 48 minutes, putting him 16th on the all-time spacewalk list. Morgan's 7th spacewalk in a 6-month time span is a record A record for frequency by a U.S. astronaut in the spacewalk today is the 9th spacewalk for the Expedition 61 crew, which is more than any other increment in the history of the station. The 9 spacewalks during this increment brings the total time to 61 hours even. The spacewalk today was the 6th for Station Commander Luca Parmitano of the European Space Agency. His career total time now comes to 33 hours and 9 minutes.
Your glove heaters are off.
The spacewalk today was also the 4th and final planned spacewalk in a series to repair the alpha magnetic spectrometer, which lasted 6 hours and 16 minutes. The 227th spacewalk brings a total time of 1,428 hours and 26 minutes, which is the equivalent of 59 days, 12 hours, and 26 minutes of spacewalking time in support of International Space Station assembly and maintenance.
Okay, copy. I'll pick up the repress and I will bring it all the way to norm if you agree.
I'm good. Looking good. Yeah, go ahead.
The work to prepare for the series of spacewalks, which began about 4 years ago, involved making, testing, and launching more than 20 new tools to the space station, many specialized for specific steps of the spacewalk. These tools had gone through years of iterations and tests here on Earth by scientists, engineers, and astronauts. The 2 spacewalkers today, and for the series of the repairs, Drew Morgan and Luca Parmitano had 7 training sessions in the neutral buoyancy laboratory dedicated to repair training for the alpha magnetic spectrometer.
That's a little bit less than half. Would you like an increase?
Please. You too. Go ahead.
Again, the spacewalk today was the 9th spacewalk for the Expedition 61 crew, which is more than any other increment in the history of the station. The 9 spacewalks during this increment brings the total time to 61 hours even of spacewalking time.
Julie said, okay, it feels like, I feel like my ears are clearing up fine, so if you want to bump it up all the way, I'm good to go. Yes, you are clearing fine? I am clearing properly, yes. Okay.
Okay, I copy that. I'll bring it all the way to norm.
Go to norm.
Okay, guys, we are almost there. And Luca, could you make sure that the hatch mechanisms are clear of this bag?
It work. I don't have a whole lot of space, but I can make it up and... Okay, it's good.
Thank you.
Jessica Muir is now opening the hatch between the crew lock and the equipment lock section. And the hatch is now open.
Houston airlock on 2. We're ready for step 4 and 1.240.
Checking.
And Ricky, you good for us to proceed with pulling them out and getting the safers off?
Yeah, we are ready. Thank you. Airlock Houston, EV crew is no longer hot mic. Copy, thumbs up.
Drew Morgan and Luca Parmitano now back inside the equipment lock section of the Quest airlock. They'll continue to run through some formalities in that section before taking their helmets off.
Houston airlock on 1 for SCU.
Go ahead on 1.
Yeah, for EV2's SCU, we were just at step 20, and his SCU was apparently not locked and came halfway off. So he currently has no fan, no power to his suit.
Checking.
It is now reconnected. The SCU is now reconnected.
Hey, we're looking for additional...
Can we go power to bat?
Stand by, negative. We're in a safe config right now, and we will get back to you with the procedure here in a sec.
Okay, he currently has no ventilation.
Copy that. And if we have CO2 issues, have them report, and we need in 2.260. All right, now we're back with you, and we will take power to bat for EV2.
EV2 powers in bat, and I hear fan startup, and he's verifying he has airflow. Thank you. Okay, and we are going to be running 2.260 if we understand correctly.
Stand by 1 second, please. And Airlock Houston, in 2.260, we need you to execute 4 through 11.
Copy, we're in 2.260, 4 through 11.
That's a good readback.
You specified all these actions are just for EV2, correct?
That is correct.
Okay, on the PSA? An airlock on 1 in 2.260 in step 9, the voltage is approximately 7.
Checking.
Luca Parmitano had a momentary loss of cooling in his suit, but it was resolved with no further issue. The crew is still running through some final procedures before those helmets come off.
Sure.
Airlock Houston back with you. What we would like you to do is go back to step 5 and take the suit select switch for EV2 off. And in step 6, we need you to wait a full 7 seconds to completely reset the fault. And then you can pick up back up and head on through 11.
Copy that. Moving back to step 5. And Ricky, we repeated steps 5 through 9, waiting a full 7 seconds in step 6, and we have the same voltage showing 7.3.
And Airlock Houston, we're going to leave for EV2 the power in BAT. He's in a good configuration right now. We're going to get him out of the suit first, and we're just getting the steps together for you.
Yeah. And would you like on the PSA for EMU2 to remain in the on position? Selected EMU2.
The suit select off for EV2.
Suit select go into off.
Airlock Houston, we'd like you to go ahead back to the post-EVA and pick up in step 20 for EV2, and we'll get him out of the suit first. Sorry, Drew.
Okay, copy, Rookie. We are picking up in step 21 now. 20 has already been completed.
Copy that.
Jessica Meir and Christina Cook now working to take the gloves off of the spacewalkers today. Luca Parmitanos are officially off. Recapping some milestones from today, Drew Morgan and Luca Parmitano were assisted in the Quest airlock this morning and now by NASA astronauts Christina Cook and Jessica Meir. Earlier, the two of them helped the spacewalkers get suited up and run through various checks before stepping out into the vacuum of space. Jessica Meir closed the hatch at 5:21 a.m. Central Time this morning to begin depressurization. The depress was temporarily paused as a result of a loose tether obstructing the hatch between the crew lock and equipment lock sections. The tether was removed and the crew lock depress started back up officially at 5:32 a.m. Central Time and was then completed. After depressurization, Drew Morgan and Luca Parmitano's suits were placed on internal battery power, officially marking the start of today's spacewalk at 6:04 a.m. Central Time. Following the official start of the spacewalk, Morgan and Parmitano translated to the Worksite on the station's Starboard 3 truss to begin the fourth spacewalk in the Alpha Magnetic Spectrometer Spacewalk series, with critical leak checks of the newly installed system and the installation of thermal insulation on the upgraded AMS. The spacewalk today, which lasted 6 hours and 16 minutes, started this morning with several leak checks. Drew Morgan completed the leak inspections on the Nader Worksite and found no leaks. Luca Parmitano found one leak out of 8 tubes on the first tube he checked and was able to tighten the connection on the leaking tube. Luca Parmitano also completed the remaining VSB, or vertical support beam tube, inspectors and found no additional leaks. Parmitano re-inspected the tube for a second time and saw an indication of a leak and tightened the connection once again. And on the third inspection, no leaks were shown, therefore the jumper installation was not required, and Morgan and Parmitano were able to continue moving down the timeline as originally planned. Luca Parmitano then opened the accumulator valve, which pressurized the new system, ensuring all the cooling lines were holding pressure as expected for the resumption of the activation of this system. The spacewalkers then worked together to install an MLI, or multi-layer insulation tent, underneath the AMS pump system to close out the former debris Worksite, then installed a mud flap between the new pump and the vertical support beam, or VSB as the acronym. They then removed the shower cap, exposing the new radiator, completing the AMS tasks. Drew Morgan and Luca Parmitano then made their way over to the intersection of the P4 and P6 truss to complete a get-ahead task, removing lens filters that had fogged over, creating a hazy vision on 2 high-definition cameras. With the work complete on the AMS, the project office has forecasted a preliminary date for the reactivation of the instrument and the resumption of science by Wednesday, January 29th. So Sunday, tomorrow, we'll complete the filling of the thermal control loop with CO2, then allow the system to stabilize. Monday, January 27th, the first pump will be powered on, which will allow it to filter out any debris in the system. The tracker will also be turned on that day. Then on Thursday, January 28th, verification of the other 3 pumps to verify proper operation will begin. And finally, on Wednesday, January 29th, is when teams expect to be receiving good scientific data again from the cosmic ray detector. The Alpha Magnetic Spectrometer has been capturing high-energy cosmic rays to help researchers answer fundamental questions about the nature of the unseen dark matter that makes up most of the mass in the universe. Our coverage of the 4th spacewalk to repair the alpha magnetic spectrometer will end here, but we hope to see you back here on Friday for live coverage of the departure of Northrop Grumman's Cygnus cargo spacecraft. Live coverage of the spacecraft's release will air on NASA television and the agency's website beginning at 8:15 a.m. Central Time, with release scheduled for 8:35 a.m. Central Time. With the work to repair the alpha magnetic spectrometer complete, and with Drew Morgan and Luca Parmitano safely back inside the station, that'll wrap up our coverage for today. This is Mission Control Houston.
This year, 5 new missions are taking off to investigate our home planet. From coast to coast, these missions will take a closer look at everything from sea level rise to snowstorms, all based right here in the United States. About 200 miles off the coast of San Francisco, the Submesoscale Ocean Dynamics Experiment, or S-MODE, will use measurements from a research vessel and 3 planes, a King Air, a Gulfstream, and a Twin Otter, to look at how swirling ocean eddies affect the movement of heat between the ocean and the atmosphere. Autonomous wave gliders and ocean gliders will dive below the surface of the water to get a full picture of the ocean and atmosphere. Together, the mission will collect data about temperature, salinity, and ocean velocity to get a better understanding of how small eddies affect the upper ocean. Traveling inland to the Midwest, the summer months can bring intense thunderstorms. Strong winds formed by these storms can overshoot the troposphere and reach higher in Earth's atmosphere, injecting pollutants into the stratosphere, which can affect the ozone layer. Using an ER-2 plane flying up to 70,000 feet, the dynamics and chemistry of the summer stratosphere, or DCOTS mission, will investigate how the pollutants reach the stratosphere and how their impact could change in the future. Farther south, the Mississippi River Delta is sinking as sea levels continue to rise globally. The Delta X mission, no acronyms here, will combine measurements from 2 planes, a King Air and a Gulfstream, with measurements taken on the ground and in the water to study how and where soil is naturally transported and deposited by water. This can help researchers better understand how the coastal regions will be affected by rising sea levels. On the east coast of the United States, the Aerosol Cloud Meteorology Interactions over the Western Atlantic Experiment, or ACTIVATE mission, will look at how clouds in the marine boundary layer, roughly the 2 kilometers above the ocean, affect the water cycle. These cloud systems cover large stretches of the ocean and are not well represented in climate models. ACTIVATE will use 2 planes, a Falcon and a King Air, to take measurements remotely and in situ, including releasing dropsondes through the clouds. Flying the same corridor, the investigation of microphysics and precipitation for Atlantic coast threatening snowstorms, or IMPACTS mission, will use measurements on the ground, scientific balloons, and 2 planes, the ER2 and the P3, to measure snowstorms at all altitudes. IMPACTS is looking closely at the intense bands of snow that form inside clouds to improve forecasting of snowstorms in the future. Stay tuned for more as these 5 missions take off.
MSOLO stands for Mass Spectrometer Observing Lunar Operations. We took an off-the-shelf mass spectrometer and worked with Enphicon to ruggedize the design to withstand the harshness of space. We bolstered the glass instrument detector, redesigned the avionics boards for better heat flow and increased radiation tolerance, and applied other standard spaceflight practices into the design. On the lunar surface, MSOLO can measure resources like water, crucial to deep space exploration, and it can measure the gases coming off a lander during touchdown. This is important so we know what is truly coming from the moon and what we brought with us. Being able to identify the lander signature will ensure we are only measuring what was already on the lunar surface. MSOLO will be sent to the moon as part of the Commercial Lunar Payload Services contract. Essentially, commercial companies are building lunar landers, and technology like ours is hitching a ride down to the surface. Not only will MSOLO help us learn more about the moon and ultimately change the way we explore our solar system, but the new rugged design we helped create is changing things down here on Earth too. By modifying an off-the-shelf mass spectrometer, NASA helped Enphicon identify ways they could improve their product that would also help universities and other researchers using their equipment in harsh environments here on Earth. In Costa Rica, investigators are flying a commercial mass spectrometer on drones over volcanoes, safely detecting what gases are being emitted. Information from volcanic plumes provides insight into what is happening inside the volcano, alerting researchers if a major eruption is imminent. We are proud of MSOLO's capabilities in space and right here on Earth. And now we're headed to the moon. From Kennedy Space Center, I'm Patricia Valendia.
When it opens its eyes to our universe in the mid-2020s, Wfirst, the Wide Field Infrared Survey Telescope, will capture images unlike any satellite before it. Wfirst will have the same image resolution as Hubble, but will cover an area 100 times larger. Wfirst will also view the sky in carefully selected wavelengths of infrared light, which will allow it to see through obscuring dust to reveal hidden stars and watch the growth of galaxies over the last 10 billion years. To see what the sky will look like to Wfirst, scientists use special processing techniques to create simulated images. In this case, they began with a Hubble mosaic of Andromeda, one of the closest galaxies to our own. Released in 2015, This mosaic was created out of over 400 individual Hubble images and took more than 3 years. Because of its enormous coverage, Wfirst will be able to create a similar mosaic with just 2 images, each taking about 90 minutes. Wfirst images are actually made of 18 separate panels, each one corresponding to a single 16-megapixel detector. The arrangement of these detectors creates the distinctive Wfirst image shape. The simulated image is not just special because of its size, however. It also shows Andromeda as it will appear through Wfirst's optics and infrared filters. To achieve this, scientists started with Hubble filters that are closest to Wfirst's. Then, they used software to measure the positions and brightnesses of the roughly 100 million stars in those images and applied those as input to Wfirst image simulation software, which added each star back to the image after applying the expected effects of the Wfirst optics, filters, and detectors. The resulting image reveals many stars that were blocked by dust in visible light. It highlights Wfirst's role in providing a more comprehensive view of the stars in the local universe. Wfirst will also use its broad view to search for planets around other stars in our galaxy, and to look for the fingerprint of dark matter and dark energy in the distant reaches of the universe. With an unprecedented combination of breadth and depth, Wfirst will open a new era in viewing our universe.
They are the best of the best. They represent the best of humanity and our most fervent hopes for the future. No pressure.
Folks used to tell kids when I was growing up, reach for the moon. But that's not the objective anymore. Now we've got to revise it to reach for Mars.
And what I'm so excited going forward with Artemis is that when the next astronaut lands on the moon, maybe one of these men and women, and by the way, as the father of 2 daughters, I could not be more excited that we will land a woman on the moon and bring her home safely.
Hi, I'm Nikki Fox, and I'm in charge of all sun science here at NASA. This is Ask NASA, and I'm here to answer your questions. Is the sun a ball of fire? No, it's not. We know that the sun can't be a ball of fire because we need oxygen to be able to have combustion, and there's no oxygen in space. The sun, however, is a giant nuclear furnace. The core in the very center is very, very similar to a nuclear reactor, and all of these particles get squashed together, and there's a huge amount of pressure, and they undergo chemical reactions, and so there are very different layers as you move out towards the edge of the sun. Why does NASA send missions to the sun? Because the sun is the most important thing in our solar system. The sun generates light, but also a tremendous amount of energy, and it sends all of this material to us here on Earth. And so we live in the extended atmosphere of the sun. We've looked at the sun in every different wavelength, but recently, NASA launched the Parker Solar Probe, which is a daring mission to go into the very atmosphere, the very heart of the atmosphere of the sun. So I have a model of the Parker Solar Probe spacecraft here. Could I get some sun in here, please? So the important thing is, as the spacecraft moves around the sun, the heat shield has to remain pointed towards the sun at all times. So the heat shield, the front of the heat shield, will get to about 2,500 degrees Fahrenheit, but the main body of the spacecraft is nice and cool at about 80 degrees Fahrenheit, which is a bit like a balmy Florida evening in August, I guess. And that's Parker Solar Probe. Thank you. Good. Look how polite you are. So one of the things that we discovered with Parker Solar Probe on the very first orbit was switchbacks. Switchbacks. If only I had a model of the corona. Ah, thank you. So switchbacks are really reversals in the material coming from the sun. So the sun has a magnetic field, and that is continually moving away, or so we thought, continually moving away from the sun. But what we found with Parker Solar Probe is this magnetic field actually kind of reverses on itself and makes an S shape, and we call that a switchback. It's hard to twist a magnetic field. It's like trying to twist a rubber hose. It's hard, and so somehow there's this energy going into the magnetic field that's causing this S shape, and when it releases, it's letting all of this excess energy out into the solar wind. Thank you. Studying the sun is really important as we get ready to support the Artemis mission. We're really protected here on the planet by our magnetic field and all of that atmosphere around us. Our astronauts, when they will be on the moon, and of course as we journey further to Mars and beyond, we'll be traveling through the solar wind and living really more in the atmosphere of the sun. And so it's key as we go forward to the moon, to Mars and beyond with our Artemis mission, that we really understand the source of energy in the heart of our solar system. Parker Solar Probe on her final closest approach after she's done all of those Venus flybys. She will be at about 3.9 million miles above the sun's surface. We have many materials on Parker Solar Probe that don't melt despite how close they are to the sun. In fact, that was one of the big technology challenges for us, to find materials not only that don't melt, but can actually withstand the incredible change in temperature, because Parker goes very close to the sun and then comes out around the orbit of Venus, which means that all these materials go really hot and then really cold at least 24 times. So the critical thing for Parker Solar Probe, of course, is to keep that heat shield pointing at the sun. At some point, she will run out of fuel. At that point, unfortunately, she will start to turn, and the full illumination of the sun will hit parts of the spacecraft that are not designed to see the sun. And so she'll break up into large pieces, and then they will get gradually smaller and smaller until they become really tiny. And so I like to think that she will become part of the corona, and she will orbit the sun forever. So honestly, we don't know what new science we're going to expect. We've already seen unbelievable stuff on our first couple of orbits. Science is a voyage of discovery, and that is what Parker Solar Probe is doing. She is going into a region where we've never been before. And so honestly, we expect the unexpected. My favorite aspect about the sun is it's a star, and it's a star that we can go and visit. And so you think, you look up in the night sky, you see all of those stars, and yet we're actually sending a spacecraft right into the atmosphere of a star right now. And that means we're going to understand more about other stars in our universe, and that's amazing.
Do you have a question for NASA? Send your questions to our experts on Twitter using hashtag AskNASA.
You know, we've got to come up with a better system, a better way to make sure that these pilots are getting the oxygen and the protection they need to go fly.
If you're low on oxygen, basically sometimes get euphoric or you get sleepy or you're kind of pass out. And obviously if you have to fly the airplane, it's not a good scenario.
The Navy and the Air Force has been experiencing problems with oxygen levels and content and pilots blacking out.
You know, you have aircraft data, you have some, you don't have a lot, but what you don't have is any instrumentation on the pilot and their breathing. And so what we were really focused on was really trying to identify the root cause in the pilot. Remember, physiological episodes happen in people, not aircraft. So if you don't have the pilot instrumented, then you're really not going to be able to help resolve the problems.
Crew assignments, I'll be in the jet. You guys will be in the control room. Jack will be talking on the radio. Oh, okay.
The use of this project is going to go for a long time because it's going to establish a fundamental data set on how pilots breathe in a tactical environment.
NASA 1, ready at that mark. NASA 850, NASA 1, that mark in 3, 2, 1, mark.
High performance type aircraft like fighter jets, over the years they've become more and more advanced. They can fly with higher Gs, they fly faster, they fly at higher angles of attack. With all of those increases, physiological effects on pilots has increased dramatically.
Every pilot's going to be different in how they react to something. They want to kind of baseline what you're like before and what you're like after.
So how do we gather the data? How does it go through this process from the aircraft all the way through to arrive at the analyst's desk, and what do they do with it?
And one of the first things we have to do is we have to look and see what kind of flight they're doing. If they're doing a Navy configuration flight or an Air Force configuration flight.
We'll take spirometry, which is basically looking at lung capacity. We do that like an hour before the flight, just right after we strap into the cockpit, and then when we come back, we'll do that again in the cockpit, and then after we've been out for about an hour.
The RAD-97 is monitoring their pulse, their oxygen saturation, their blood. It's also monitoring how fast they're breathing. And that should be it.
Pilot wears a Vigilox system made by Cobham. With the Vigilox system, it measures a lot of key parameters that are useful and important for understanding what the pilot is breathing in and breathing out.
Put this side in first.
In order to capture all the data that we want, the pilots are flying different profiles. Some are just high altitude flights where they're flying 40 to 50,000 feet. Other ones are more aerobatic, so where they're up there doing spins and turns and dives.
And then can we correlate that type of flight and how it changes, you know, kind of your lung capacity or those kinds of things. So that's what the scientists are looking for.
We embarked on this with the idea that we have a lot of complex test methods that we're developing. And at the end of this, one of our goals originally is we want to be able to develop test methods that are useful to the Air Force and to the Navy in the sense that they can be used in a repeatable, consistent way that provide really quality data that then we can compare our results with the Navy's results and the Air Force's results.
So I think this will help make sure that the designs we have are set for what the pilot needs. Because if we don't really know what the pilot needs very well, we can't design to that. And previous systems, I think, just had a lot of margin to be able to accept different needs from a pilot. But now that we've gotten, you know, closer to designing those to basically just what they need, we really need to know what the pilots actually need in order to be safe.
Welcome to NASA Science Live, your chance to go behind the scenes at your space agency and get your questions answered by NASA scientists and experts. I'm your host, Gray Hautaloma, and today we're here at the American Geophysical Union Conference in San Francisco. It's one of the largest conferences in the world, and people are presenting papers on all kinds of topics. We're going to learn more about our Osiris-Rex mission, NASA's first mission to get a sample from an asteroid and return it to Earth. We want you to ask your questions to our NASA experts by using the hashtag AskNASA at Twitter and on Facebook or in the comment box wherever you're watching this. I'm going to head to the NASA booth right now to meet those experts, so please join us there, but first watch this video about Osiris-Rex.
On September 8th, 2016, in Cape Canaveral, Florida, Osiris-Rex began its journey, NASA's most ambitious sample collection attempt since the Apollo program. After 2 years, including a gravity assist from Earth, the spacecraft arrived at its destination, asteroid Bennu. As Osiris-Rex drew near, Bennu grew in detail from a few tiny pixels to a surprisingly rugged world, littered with giant boulders. The spacecraft has used its instrumentation to map the asteroid from all sides, mapping it in unprecedented detail. The mission team has been analyzing the data, scouring Bennu's surface to select the best sample site. Now, with just months to go before sample collection, the team has narrowed its target down to 4 potential sites.
Hello, and thank you for joining us in the booth here at AGU, the American Geophysical Union, for this special edition of NASA Science Live. Today, we have a big announcement from the Osiris-Rex mission. Osiris-Rex is NASA's first mission to retrieve a sample of an asteroid and return it to Earth. The mineral particles that make up Bennu, the asteroid that is being orbited by Osiris-Rex, they could be as old as the solar system itself. Dying particles from stars could have formed the planets and our own sun. And now we're going to get a sample from that asteroid and return it to Earth. And we're going to find out from where today. We're going to get maybe upwards of 30 sugar packet samples worth. So it's very exciting, and I'm really pleased to have here today some of the mission team members. So please let me welcome Danny DellaGustina.
Hey, Gray.
And Mike Moreau. And they're going to tell us a little bit more about the mission and the challenges and where we go next. So I guess the big obvious question is why? Why did we want to study Bennu?
Yeah, that's a great question, Gray, and I'm really excited to talk about Bennu and the mission ahead of this announcement. So Bennu is a near-Earth asteroid, and that means its orbit is in close proximity to our own planet, and it was fairly accessible for us to send a spacecraft there, so that's one reason. But because of its close proximity to planet Earth, it's also a potentially hazardous object, and so by sending a spacecraft there and flying in formation with Bennu for over 2 years, we're going to get a much better sense of Bennu's orbit and be able to better predict whether or not it is a hazard in the coming decades and centuries. But finally, Bennu is composed of water-bearing minerals, and that was a discovery we made very early on in the mission. And there's early indications that it might have organics as well, so we think that Bennu looks a lot like the objects that might have delivered the precursors to life to early Earth. And so it's also exceptionally scientifically exciting to be in orbit around this surface.
Wow. I can't wait to find out more about it. I know it gave us a lot of surprises. Do you want to tell us a little bit more about that, Mike?
Yeah, so one of the biggest surprises when we saw what Bennu looked like is what's on the screen here. It is just covered with rocks. So on the table next to Danny is a model of Bennu that was created before we arrived, and in many ways Bennu met our expectations of its general shape, its spin axis, and its mass. But the fact that it's just so covered in large boulders and such a dramatic surface was a big surprise. And that caused us to reevaluate the whole process and the data set that we would use for site selection and make some new improvements to the capabilities of the spacecraft so that we could actually go down to the surface of this asteroid.
Wow. And we'll talk about that a little bit more later too. Tell us what Bennu can tell us about other asteroids in general. I know there's a lot out there.
Yeah, so Bennu can tell us a lot about other asteroids in a number of ways, but something that sticks out is earlier this year we discovered Bennu is what we call an active asteroid. And so that means there is mass that is actively being ejected from the surface of Bennu. And we have seen similar activity on larger asteroids through telescopic observations, but we haven't seen this sort of activity at the low energies that we observe on Bennu. So it's giving us a better sense of the range of active asteroids that exist in the solar system. Just to give some perspective for the range of energies that we see these sort of ejection events, if you were to snap a cracker in half, the energy release there is comparable to the ejection events that we're observing on the asteroid.
Wow, there is a lot going on at that rock. So we want to get your questions, and they are already coming in, but if you use the hashtag AskNASA at Twitter or Facebook or in the comment stream, wherever you are watching this, we're going to try to take as many of them as we can during the program. So let me get to the first ones of those. Ankur on Twitter asks, how big is the asteroid and does it have a particular orbit?
So I can go ahead and answer the first part. So Bennu is about 500 meters in its longest dimension, and to give some perspective, that's about the size of the Empire State Building, so about 100 stories. Do you want to answer the question about the orbit, Mike?
Yeah, Bennu is in a near-Earth orbit, so it's in an orbit around the Sun that is very close to the Earth's orbit, and it actually crosses the Earth orbit. And as Danny alluded to, that's one of the reasons Bennu is such an interesting object for us to study in this mission. We are interested in precisely studying its orbit and how that orbit evolves over time to understand how close it might come to the Earth.
Okay, appreciate that. So, can you tell us where the name Osiris-Rex comes from?
So Osiris-Rex is, as our principal investigator likes to say, an awesome acronym. So all of those letters have individual meanings. It stands for origin, security, spectral interpretation, resource identification, regolith explorer. So there's a lot there.
That's pretty good. Okay, well, I hope that answers that question. Let's see what we got. Another one. Gemfef on YouTube asks, what are you looking for when you go to the sample site? When you're searching the sample site, what are you looking for?
Yeah, so the primary thing that we are looking for is the presence of sampleable material. We're also very interested in whether or not the site is safe. But from my perspective as a scientist, I'm very interested in whether or not these sites might have organic material or things that we think are similar to the precursors to life that were eventually delivered to Earth. Is there anything you want to add about the safety?
From my perspective, our number one goal is to keep the spacecraft safe while navigating down to these potential tag sites. And so we're interested in the fact that there are, some of the sites have very large boulders in the vicinity of them and smaller rocks within the area we're trying to contact that could be potentially hazardous to the spacecraft. So we've had to take precautions in order to keep the spacecraft safe.
Okay, well, I want to thank you both. That's been really fascinating. And now we've got a video that we're going to show you some of the surprises at Bennu that they were talking about. That's going to go into greater detail about it. So let's watch that right now.
In late 2018, as NASA's Osiris-Rex spacecraft neared its target, Bennu, the asteroid grew in detail from a few tiny pixels to an incredibly high-resolution image. Osiris-Rex confirmed the asteroid's basic shape, which was originally observed in 1999 by ground-based radar at Arecibo Observatory. What scientists didn't expect was just how rough and boulder-filled the asteroid would turn out to be. While it can be difficult to fully grasp Bennu's unfamiliar surface, it's helpful to understand the scale of what you're seeing here. In this image, the brightest boulder is the length of a horse, and the large boulder in this image is the width of a soccer field. Another challenge for the mission is the asteroid's small size and weak gravity. This means that Osiris-Rex needs to fly daringly close to the surface in order to enter into orbit. With its orbital A phase, Osiris-Rex successfully entered the closest ever orbit for a spacecraft, setting a Guinness World Record in the process. Then, 6 months later, it beat its own record during its orbital B phase and approached to within a few hundred meters of the rocky surface. Because OSIRIS-REx flew so closely over the surface during Orbital B, the team was able to map the topography and shape of Bennu better than we have our own moon. In addition to mapping asteroid Bennu, OSIRIS-REx plans to collect and return a sample back to Earth. To do that, the spacecraft will carefully tag the surface of Bennu. The OSIRIS-REx team has selected 4 possible sample sites for the mission: Osprey, Kingfisher, Nightingale, and Sandpiper. The spacecraft has been closely imaging these sites from different angles to select the best touchdown spot for OSIRIS-REx. What was originally envisioned as a smooth and easy touchdown on Bennu's surface has become a complex endeavor to tag a small, crowded space on the asteroid, an area no larger than a few parking spots, by mid-2020. The OSIRIS-REx team has already pushed the boundaries of scientific exploration, going from ground-based radar images all the way to being a few hundred meters from the asteroid's surface, and is now mere months away from a sample collection attempt.
All right, well, that video gave us a lot of perspective on just how hard it has been to explore Bennu once the spacecraft got there and all the surprises that the team encountered. But we are now getting ready to select that sample site and tell the world about it. And we've heard a little bit about Bennu and where it is, what it looks like, and now we're going to get a little bit more into the why of why we do this. I'm pleased to be joined by Dr. Lori Glaze, who's head of the Planetary Science Division at NASA headquarters.
Hi, Gray.
Welcome, Lori. So, yeah, tell us, why do we do sample return?
It's a great question. So we've been observing Bennu now for about 20 years, first observed using ground-based telescopes, and then over that 20-year period we've continued to observe the asteroid using ground-based and space-based observations, and then over the last year, of course, we've been able to observe using the OSIRIS-REx spacecraft. But all of those measurements and observations are remote sensing observations. They're done from a distance, and there really is just no substitute for being able to actually pick up some of that material from the surface and bring it back to Earth. By bringing it back, that allows us to use the full capabilities of all of our state-of-the-art technologies and laboratory facilities to analyze those samples, to answer some of the really big questions that we have that Danny was talking about when she was sitting here. And not only can we answer those questions using our facilities today, but we'll actually preserve most of the sample for all of the generations to come, that they can then use new facilities and new instrumentation that we haven't even dreamed of yet.
Wow, that's going to be amazing. So, what in particular do we think we'll learn from Bennu?
So, Bennu is actually going to address several major questions, and 3 big ones in particular. First off, you heard, or you said earlier, that Bennu we think is a really old object that's really a remnant and preserved from the very earliest parts of our solar system. So by looking at those samples, we'll get insights and information telling us about what conditions were like when the solar system formed. And then Danny talked about how we think there are hydrated minerals and perhaps organic molecules on the surface. And by looking at those, we'll better understand how those types of materials were delivered to Earth and perhaps were the seeds for how life actually began to form on Earth back in the earliest times. And then finally, it's also going to help us better understand what types of resources might be available on these asteroids that are out there, that as we start to take human exploration beyond the moon and start to go other places, there may be resources there that may be of use to us in the future.
Well, these are some really big questions.
Yeah.
And I know OSIRIS-REx is a unique mission, but there are other missions in place going forward to get samples from other places, building on the Apollo moon rocks we have and going to Mars and so forth. How does that whole field fill in this?
Absolutely. So, of course, the Apollo missions were the first missions to actually bring samples back. We get natural samples all the time, of course, with meteorites that come through the atmosphere. But the Apollo missions brought those samples back. We're still analyzing those samples today, 50 years later. We just opened up some pristine samples a few months ago, or just trying to look at those with our new technologies, as I was saying. But we also are working right now with the Japanese Space Agency on their mission to visit another asteroid called Ryugu, and next December they'll be returning some samples from Ryugu. that we'll be able to study another asteroid in comparison with Bennu. And then Japanese Space Agency is also planning a mission to the Mars moon named Phobos to bring back samples from there. And of course, NASA, next summer, will be launching the Mars 2020 rover, which will land in Jezero Crater, drive around, and collect samples from Mars that will be left on the surface for eventual return by a Mars sample return mission.
Well, there's a lot going on in this area. Thank you so much, Lori, for that perspective. Really appreciate it.
My pleasure.
Well, now we're going to bring up the man with the answers. Dante Loretta is the principal investigator of Osiris-Rex, and his team has been working round the clock since Osiris-Rex arrived at Bennu last January 1st, and they discovered all those surprises we've been talking about. And he's going to give us an overview of how they narrowed down the multiple candidates for site selection and then announce the real one. So Dante, tell us about the whole process of narrowing these down.
Yeah, thanks, Gray. As you can see from the map of the asteroid behind us, when we first got there, the most obvious feature that we saw were these abundant, very large boulders, and overall a rough and rugged surface, very different than what we designed the spacecraft to sample. We were looking at sampling areas that were 25 meters in radius across, and quite honestly, I thought it was going to be obvious from the first images where the sample regions were and that it was going to be a straightforward site selection, and it was nothing of the sort. So the first thing to do was to complete the global characterization of the asteroid. We used our camera systems, we have laser altimeters for getting the topography, and we have several spectrometers for analyzing the mineralogy and the chemistry. And the science team did an amazing job of synthesizing all of that information and making a whole series of maps of the asteroid's surface. And then we went through several different ways to characterize it. We had the team looking at the imagery and the other data to pick areas that looked sampleable. We used machine learning algorithms. We also wrote specific software to find flat areas on the asteroid surface. And we also crowdsourced some of this information out to get the community involved in helping us select the sites. After that process, we actually had 50 different areas on the asteroid surface that looked like they might be interesting for us. And so I set it up kind of a tournament-style bracket. We ultimately got down to our Sweet 16 and then the Elite 8 and to the Final 4 where we are right now, about to crown the champion and the runner-up of this process.
All right, well, I understand you have some really cool videos of those Final 4 sites, so why don't you go over them with us?
Yeah, let's take a look at the Final 4 candidate sample sites. So we're going to start out with the Osprey crater. This is about 20 meters in diameter. One of the key features is the big flat rock that's 5 meters long. We call that 12 o'clock rock because it's almost pointing due north, and it kind of sets our orientation for us. It does look like it has some fine-grained sampled material, especially right towards the central region and in the trough or the ridge, beyond the ridge to the east there. But it is a kind of a rough and rugged surface, and so we do worry that it might be a little more challenging to ingest those 2 centimeter sized particles from its interior. But overall, the surrounding area, because it's up on kind of a hill, it's relatively free of hazards that we might fly into on the back away from collection. Let's take a look at the next one. This is the Kingfisher site. So this is similar to Osprey in that it's in an equatorial region, and we like the equator because the navigation team has higher accuracy when we're targeting equatorial sites. This is a smaller crater, about 10 meters in diameter. One of the most intriguing features are the 2 smaller craters that we in fact call the Mickey Mouse ears. Those look like the best, finest grained sampleable regions on the asteroid, but they're really small, on the order of 2 meters across, and we know we can't get the spacecraft into a spot that tight, but the hope was that that same kind of fine-grained material was accumulating in the center of this smaller crater. If we take a look at our next candidate, this is the Nightingale crater. So unlike Osprey and Kingfisher, this one's at high latitude up in the northern region of the asteroid. It's a crater about 20 meters in diameter. It's characterized by a lot of apparently fine-grained material. We do see a few large boulders that look like they've rolled down into the lowest depression over here on the right side of our image. And the most characteristic feature for me is this large wall of tall rocks. That does represent a potential hazard to the spacecraft, because when we make contact with the surface, the only thing that touches it is the sample collection head at the end of a long robotic arm. That may tip over a little bit, and we back away at whatever angle we've tipped to, and we're concerned that we might fly into some of those hazards. So let's take a look at the final site. This is the Sandpiper site. So this is also a high latitude site, except it's in the southern hemisphere of the asteroid. And unlike the other 3 sites, it's part of a much larger crater, about 50 meters in diameter. And what's really interesting here is the site itself is on one of the slopes of the crater wall. And it looks like there's a whole series of boulders that are kind of rolling down this terrain like a slow motion landslide. But the Sandpiper site appears to be shielded from that process by this large rock off to the south. So there's a whole swath of the crater wall that's relatively free of boulders and appears to be dominated by that fine-grained sampleable material.
All right. Well, those all look like great candidates. Well, you've seen them all now, and some of those space rocks you're seeing right now are going to be brought back to Earth. That's pretty exciting. So, Dante, do you want to tell us which one you've picked?
I will. So I'll say that just thinking that we're going to get this sample back to Earth sends chills down my spine. So the winner of the Osiris-Rex Site Selection Championship is the Nightingale site.
All right. Make some noise, audience.
Thank you. So we recognize that this does have some hazards around it, and so we are doing a lot of work to make sure that we're targeting the safe regions, but this one really came out on top because of the scientific value. The high latitudes means that it stays relatively cool, and the primary objective of Osiris-Rex is to bring back organic material and water-bearing material from the early solar system, and being in those high latitudes we think gives us the best chance to preserve that kind of material. Since we are dealing with a site with some hazards nearby, we have put some safety mechanisms onto the spacecraft. The spacecraft can actually tell if it's coming down onto a hazardous region and wave off and abort and fly away, fire thrusters and fly away from the asteroid. That may disturb the surface and make that region unsampleable. So we also have a backup site. The runner-up is the Osprey site. That's the 20-meter crater near the equator. We know we can get in there. It doesn't have the hazards that Nightingale does, but it also may be more challenging to collect a sample, but we think the lower hazards makes it the right choice for the backup.
Well, thanks for that, Dante. We do have a bunch of questions flowing in from social media. Again, use the hashtag AskNASA if you have one. And let's just go right to someone from in our audience. Aaron in the audience asks, what is the biggest challenge of the site?
So the biggest challenge of the Nightingale site is those large boulders that are off on the eastern edge of the crater, because that tallest one, I colloquially call it Mount Doom because it has the classic kind of peak shape that we're familiar with from the literature. That's about 7 meters tall, and then when you're down at the bottom of the crater, that's another 3 meters. So we're talking 10 meters or 30 feet. So it's a substantial building-sized obstruction, and we're trying to get into a crater that's on the order of a few parking lot spaces wide. So we are doing a really tight job parking that, and we're aware that we have hazards around us. So precision navigation to that sampled material is our biggest challenge.
Wow, well that's going to be some amazing engineering. Well, that's all the time we have for questions right now with Dante, but keep sending them in, and thank you so much, Dante, and congratulations. So right now I'm going to invite Mike Moreau back to the stage, and he's going to talk a little bit more about the engineering that makes this amazing sample return possible. We have an instrument aboard Osiris-Rex called the TAG-SAM, which is actually going to ingest the sample in a very unique way that Mike's going to explain, and then cache that sample and to return it to Earth later after we get it. So welcome back, Mike.
Thank
you. Tell us a little bit about the challenges of the sample collection using this instrument.
Yeah, so you can imagine when the Osiris-Rex mission was being formulated, engineers had a really interesting design challenge, and that's how do you collect a sample from an asteroid millions of miles away using a robotic spacecraft. And the TAG-SAM is the innovation that our partners at Lockheed Martin came up with to do just that. The TAG-SAM, as is shown here in full scale, and it actually sits at the end of a robotic arm at the end of the spacecraft. So the TAG-SAM is the only piece of the spacecraft that will touch the surface. And in doing so, once contact with the surface is detected, there will be a nitrogen gas bottle that is fired, which stirs up the surface underneath the TAG-SAM, churns up some of that fine-grained material, which will then be captured in the outer ring here. Once the spacecraft has been in contact for just a few seconds, it will fire its thrusters and back away, hopefully with the sample in hand.
So There's so many contingencies potentially here. What happens if it gets too close and it realizes it's a hazard or there isn't enough to even sample?
Yeah, so Dante alluded to this in his remarks. We've had to make some changes to the capabilities of the spacecraft to allow us to navigate into a site like Nightingale. And we've implemented something called a hazard map, which will be uploaded to the spacecraft. And then the onboard knowledge that the spacecraft has of where it's coming down, if it detects we're coming down on one of these hazards or too close, it will back away and we'll have a chance to try again.
Wow. Well, that's a good backup. What happens once you do get the sample collected? What happens to it?
So once we back away, the next couple of days will be spent assessing the health and safety of the spacecraft after contacting the surface and trying to figure out if we have a sample. The two primary ways that we'll figure out if we have a sample, one is just simply imaging the tag SAM with the cameras on board the spacecraft. We'll be able to see if there's material that's captured inside the ring. The other technique that we're going to use is called the sample mass measurement. And we will be actually spinning the spacecraft in a little pirouette, and that will help us determine the mass of sample that's at the end of the arm.
Wow. So you're an engineer. We have a question from Andrew Siegel on YouTube. Wants to know, how do you decide the maneuvers the spacecraft has to do, and how do you assess your options in such a tight space?
That's a great question. The navigation team and our Lockheed Martin team are spending many hours designing the trajectories that have allowed us to fly in proximity to Bennu and collect all of the images that are shown in this mosaic on the screen. And they're right now that we've selected the Nightingale site, doing the final designs of the trajectory that will take us from orbit down to the surface and contact the sample. And there's been a lot of work already done to determine those trajectories and how accurately we can actually contact the surface.
At Benjamin on Twitter wants to know, how is the team's work changing now that you've got the focus? You know where you're going.
The team is incredibly excited now to have the site selection decision. And Nightingale is an exciting site to go into because of the challenges it's posing. And the team has really risen to the challenge, both to come up with how we would make the decision about the best site, but also to convince ourselves that we can actually get there and navigate the spacecraft successfully. So the team, I think, is really excited to be able to move forward and put all of our attention towards tagging at the Nightingale site.
Great. We've got just a couple more real quick here. Maybe, I'm not sure if you'll be able to answer this yourself, but Lucy on Periscope wants to know, are there going to be precautions for quarantine once this is brought back?
That's not my expertise, but there will be great care taken when the sample returns to the Earth. It will enter the atmosphere in a small sample return capsule that will land in the Utah desert, and there will be a huge effort to recover the capsule and then transport it to Johnson Space Center, where there are facilities in place to curate and make the sample available to the public for analysis, for scientific analysis.
Thanks so much, Mike, and I want to thank everybody who was on the show today. That's all the time we have right now, but please continue to go to nasa.gov/OsirisRex and keep following the mission. It's only going to get more exciting as it gets closer and does these sample return maneuvers and then gets the sample back to Earth later. So that's all the time we have for now. Until next time, let's go play tag.
A critical test for our commercial crew program, spacewalkers focus on upgrades aboard the space station and paying tribute to one of our great observatories. A few of the stories to tell you about this week at NASA.
Ignition, liftoff, Semper Fi, aim high.
We teamed with SpaceX on January 19th to test the launch escape system of the company's Crew Dragon spacecraft and Falcon 9 rocket. The system protects astronauts in the unlikely event of an emergency during launch. This was the final major flight test before crew flights to the International Space Station. The International Space Station's Expedition 61 crew conducted a pair of spacewalks to complete some important upgrades. On January 20th, our Jessica Meir and Christina Cook installed the final new lithium-ion battery as part of an overall upgrade to the station's power system that began in January 2017. 5 days later, our Andrew Morgan and Isis Luca Parmitano finished repairs of a cosmic ray detector. After 16 years of amazing discoveries, the mission of our Spitzer Space Telescope will soon end. Its infrared scans of the cosmos have discovered several Earth-size exoplanets and produced some breathtaking images. Engineers will decommission the spacecraft on January 30th. Our Osiris-Rex spacecraft completed the closest science observations to date of a sample site during a flyover only 0.4 of a mile above Nightingale, the mission's primary sample site on asteroid Bennu. High-resolution images collected during the flyover will help the spacecraft avoid hazards during sample collection later this year.
Keep your eyes on the prize. Hold on.
Our annual commemoration of Martin Luther King Jr. included a program at our headquarters featuring words from former astronaut Scott Altman and Janice Mathis Esquire, Executive Director of the National Council of Negro Women. And from space, astronauts Jessica Meir and Christina Cook had these words of tribute to Dr. King at the conclusion of their January 20th spacewalk.
And one has the spectacular view that we had today, looking down on our one common home, planet Earth. These words resonate loudly. It's so meaningful for us today to be out here on the day we honor Martin Luther King Jr., who paved the way not only for us, for so many that have a dream.
That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready.
International School of Panama, this is Mission Control Houston. Please call station for a voice check.
Space Station, this is the International School of Panama. How do you hear me?
To the International School of Panama, the International Space Station has you loud and clear. Welcome on board.
Copy. My name is Danny DePietro. I am a middle school science teacher here at the International School of Panama. We are a school of approximately 1,400 students from around 40 different nationalities. We also have some other schools here from Panama representing the entire country. We just want to say thank you so very much for spending your time and talking to us, as well as congratulations on your historic all-female spacewalk, and we wish you all the best with the rest of Expedition 61. I'd now like to introduce the two high schoolers who will run the Q&A. They are Jose and Paloma. And thanks again, ladies. You rock.
Let's welcome our first speaker, Red Joe, from kindergarten, our youngest inquirer.
For Christina, my question is, what does it feel like when you look down on your home country or town from space?
Yes, that's a wonderful question. And before I answer it, I just wanted to say hello to Danny and to all of you. Thank you for having us. And Danny, it's great to hear your voice again. It is indeed a wonderful feeling to look down on your hometown. I've had that great honor a couple times, and I'll never forget the very first time. I am from coastal North Carolina, and I remember, you know, the distinctive outer banks of coastal North Carolina kind of coming into focus the first time I saw them around the horizon of Earth, and it completely took my breath away. It was like looking at a map, except it was real, and I used all the same identifying features that I've used when I would look at a map to find my hometown and to see where I was from. And that perspective of recognizing your place on the planet and what it means to be from somewhere was just really, really special, and it's still special. I still love looking down on my hometown.